There are many types of databases today. The tried and tested relational database, the new and popular DocumentDB, and many others. And all of these have their strengths. But one place they all fall short is in handling complex connections between your data. Sure, any database may be able to return friend of a friend queries of 3 or 4 degrees, but what if you need 20 degrees and need it quickly? That's where Neo4j comes in. Unlike other databases, Neo4j Graph Database doesn't need to compute the relationships between your data at query time. The connections are already there, stored right in the database. Because of this, queries of deeply connected data are orders of magnitude faster. We get used to the limitations of the tools we work with. Neo4j blows those limits wide open, enabling queries never before imagined at speeds never thought possible. That's why Neo4j has become a key technology driving business-critical applications for hundreds of Fortune 500 companies, government agencies, and NGOs. Learn more at neo4j.com. Are you looking to try graph technology for your next project but don't know where to jump in? Neo4j's new AuraDB free tier is the fastest path to graph with zero friction, zero hassle, and zero cost. AuraDB is Neo4j's fully managed, always-on, cloud-native graph database service built to harness relationships in your data with lightning speed. You can learn, prototype, and test on the world's most trusted graph database platform without worrying about database management or administration. The best part? AuraDB is ready to scale when you are. Neo4j's AuraDB is easy, powerful, and now cost-free. Visit neo4j.com/AuraDB to get started today. Cypher is an open-source query language created by Neo4j that is designed from the ground up for working with graph data. Cypher's easy-to-learn pattern constructs make it easier for developers, data scientists, and operations professionals to intuitively transition whiteboard models into reliable queries in seconds, deriving insights from connected data quickly and efficiently. With Cypher, users can simply express what data to retrieve, declarative, while the underlying engine completes the task without requiring them to understand implementation details. With Cypher, you can easily follow a chain of relationships to an arbitrary depth and return the full path, or even the shortest path. You can combine reads and writes in a single statement, allowing you to select data to update and to return updated data directly to the customer. Query pipelining is easy using with and implicit grouping to simplify aggregations and multi-part analytics queries. If you are ready to dive into the most widely used graph query language, Neo4j has plenty of resources to explore. Learn more at neo4j.com/product/Cypher. Are you interested in graph data science but don't know where to begin? The Neo4j Sandbox is the best way to get started and learn graph data science basics with interesting preloaded datasets like fraud detection, contact tracing, and Twitter trolls. It's easy to jump right in, follow our guides, and explore visualization with Bloom. There's no download required, and you can get up and running in less than a minute. Try it for free today. Introducing Neo4j 5, ushering in a new era in graph technology that is transforming the way we use connected data. And with this latest update, Neo4j is more powerful than ever. You want enhanced performance? Neo4j is unmatched in the market. Neo4j was already 1,000 times faster than relational databases, and with version 5, Neo4j widens the performance lead with new features like K-hop query optimization, graph pattern matching, and granular indexes. You want your data to scale? With 5, Neo4j has unbounded scalability. Autonomous clustering lets you scale out horizontally with less manual overhead and better use of computing resources. And when your datasets lie in multiple databases, Fabric instantly helps you create a composite graph of insights hidden in disparate silos. You want agility? Neo4j 5 has unparalleled operational agility. Neo4j fits your IT strategy, whether it's on-premise, cloud, hybrid, or multi-cloud. And with Neo4j Ops Manager and a continuous release support model, it's easier than ever to manage your database in the cloud. Neo4j 5 helps you achieve unbounded performance, scale, and agility. Find out more at neo4j.com.
Your machine learning models are working. You're seeing results, but you know there's more for you to uncover. What if you could use the network structure within your data without disrupting your machine learning pipeline? With Graph Data Science, you can. Here's how it works. You load your data into the Neo4j Graph database, which reveals the connections in your data. Then you ask questions using graph queries and uncover hidden patterns in your data using graph algorithms. For example, similarity and community detection algorithms examine the network structures in your data to uncover tightly knit communities, such as fraud rings. Then you can use graph feature engineering to extract predictive elements to augment your machine learning models. Now you have the power to make better predictions from existing data. To learn more about Graph Data Science, visit neo4j.com.
Twenty of the 20 top financial institutions in the U.S. trust Neo4j to solve previously unsolvable challenges and to see new patterns in existing data. Why? Relationships are the core of your business and drive everything you do. Whether you need recommendations, customer 360, client onboarding, fraud detection, or machine learning, relationships are fundamental to all of them. Neo4j, the world's leading graph database, makes these complex tasks easier and faster than traditional databases by putting relationships first. Moreover, graphs are a high-fidelity way of representing what's important in your business as they are designed to mimic the way the real world works. Neo4j's Graph Data Science gives you the fastest path to bring graph analytics to production, and with AuraDB, Neo4j's fully managed cloud service, you can get started in minutes and easily scale on demand. Find out more at neo4j.com. Neo4j is the #1 database for connected data, built from the ground up to leverage not only data, but also data relationships. Neo4j is a native graph database, which makes it critically different from other data stores. But what does native even mean? Neo4j is designed around a simple yet powerful optimization. Each data record, or node, contains direct pointers to all the nodes that it's connected to. These direct pointers are called relationships. All the information needed to find the next node in a sequence is available in the node itself. The native storage layer is a connected graph. That's what native means. Because of this principle, Neo4j doesn't need to compute the relationships between your data at query time. The connections are already there, stored right in the database. Because of this, queries of densely connected data are orders of magnitude faster. Other databases don't save direct pointers between records. They need to compute connections by searching through a separate data structure called an index. This lookup process, which has to be done repeatedly to find each connection, is extremely expensive and gets exponentially slower as the data size and query complexity grows. This makes them inherently slower than Neo4j for relationship-intensive queries. Over the past decade, Neo4j has made graph databases a key technology powering modern applications for hundreds of Fortune 500 companies, government agencies, and NGOs. Neo4j is used to detect fraud, enhance artificial intelligence, manage supply chains, gain a 360-degree view of data, and much more. Learn more at neo4j.com.
Users generate 2.5 quintillion bytes of data per day. A staggering 55% of that data is left untapped, with even more data stored stripped of their relationship and context. This means that the need for an intelligent data visualization tool to make sense of rapidly growing, unconnected data has become nothing short of essential for driving innovation and business transformation opportunities within organizations. Neo4j Bloom, a graph data visualization product from the creator and leader of graph database technology, is here to help. A Neo4j graph database empowers developers and data scientists to uncover data context for deeper insights, better decision-making, and faster innovation, making organizations go from data-driven to intelligence-driven. Neo4j Bloom is a beautiful and expressive data visualization tool that allows developers and data scientists to easily visualize and freely interact with Neo4j graphs. Bloom also makes it simple to translate complex data concepts and findings for less tech-savvy stakeholders. Want to analyze a particular graph property of interest? With Bloom, simply go from generating a friendly search phrase to investigating your results and sharing with colleagues. Need help identifying malicious network traffic using large volumes of data but not sure where to start? Bloom gives you a head start by helping you generate hypotheses as you explore complex data. With Bloom, users can filter and add more data, view algorithm results, stylize data, and much more. Best of all, Bloom's codeless search paradigm makes visualizing data even easier with a few key phrases. Out of the box, Neo4j Bloom works across many domains requiring graph analysis, including fraud detection, network analysis, supply chain management, and much more. Discover meaningful value from your data and open new paths towards innovation and business transformation with Neo4j Bloom. Get started now for free on neo4j.com/bloom.
Graph embeddings are a new technology that learns from your data, revealing new ways to solve problems and adding visibility to your business's blind spots. Real-world uses for graph embeddings include finding fraud, improving recommendations, entity resolution, discovering new drugs, or predicting churn. To get in on the cutting edge of graph technology, learn more at neo4j.com.
Hello, everyone. Today is a great day. The Artemis mission launched successfully to the moon, and Cypher highlighting support became available on GitHub. Both took actually equally long, and I'm not sure which one is the actual rocket science, but I'm really happy about it. As of today, also Neo4j Workspace, including educational guides, is available for all users of AuraDB, Pro and free, and you can switch it back and forth between Workspace and the classic 3-app experience, which makes me personally really, really happy. And as of last week, Neo4j 5 was released, and as of today, Aura Desktop, Graph Data Science Library, and even Epoch Core and Extended will be possible and available for Neo4j 5. So great day altogether. What else happens today? Oh yes, Nodes. Welcome everyone to Nodes, our largest graph technology conference, online graph technology conference of the year. I fondly remember our team in 2019 coming together in Sweden for the very first Nodes. But back then we would have never dreamed of getting it so big and so kind of across the world into such a massive event. As a technical conference, it's very close to my heart. I'm really happy that we get so much technical content at the conference, and I'm happy that you all came here today together to learn and share and connect. So welcome all of you, and that's actually literally a graph of all the Nodes attendees and all the countries that you're coming from. And if you squint a little bit and look really closely, you might even find yourself in there as such. But it's really impressive to see so many people here. But it wouldn't have been possible and with all the people helping and building this event. First of all, of course, the speakers who submitted their talks and made this really amazing content available, our community partners who helped to spread the word, and the team, the awesome team at Neo4j who helped to build all the things, dealt with the time zones, all the bits, ins and outs of the conference, and made everything possible. But of course, a conference would not be anything without the attendees. So thank you all for being here today. Nodes is happening today and tomorrow for 24 hours. So we're starting now in the US at 8 a.m. Pacific, continuing tomorrow at 8 a.m. Indian time, and then continuing for the third segment at 10 a.m. GMT for the EMEA time zone. We have in total more than 100 talks presented by 113 speakers, and more than 9,000 of you want to participate in the event, which is really, really amazing. And we want to make nodes and very educational and inclusive event. So I hope we made this happen this year by being around the globe and making it available everywhere as such. In each of the 3 regions, we have 3 tracks. We have a beginner track, an intermediate, and advanced track. So it's really educational. You can pick and choose what is interesting for you, and kind of have a little bit of pre-selection of the talks, and also a lot of lightning talks spread in. Personally, I'm really happy that also Anton agreed to run a mindful meditation session in each of these regions, because I think taking care of yourself and of your mental health is really important. And so I hope that helps you also to take a breath in between. So make sure to check out his session as well. You're already seeing this now live on stage. You have the 3 stages there. After the keynote, each of the stages will start individually. And there you can also watch talks, ask questions in the chat for the speakers to answer, and you can rate also the talks in the poll. In terms of topic, we have a really broad range of topics. So when we put together the agenda, we try to make it really broad in terms of technical topics, app development, graph data science, or data science in general, use cases, deployment, DevOps, security, cybersecurity, looking at some use cases, for instance, like healthcare, or also like analytics on fraud detection and things like that. So I hope there's something for everyone, and that will make it a really, really good event. Of course, the main questions actually for today is, will it be recorded? Can I watch it later? Can I watch the other time zones? Will I get the slides? And yes, all of these, I can answer them all with yes. And so you don't need to worry about any of this. Just enjoy the conference, connect with the other people, and have a good day. To actually connect with the others, this platform Hopin has a really nice interaction and networking feature built in. You can basically, like in speed dating, connect with other people based on your interests that you can set up, and just exchange from 30 seconds to 3 minutes. Just meet someone random, like you would do in a conference at a hallway track. Basically, connect, have a quick conversation, and part again, and then perhaps you can connect later offline or on the platform as well. So I think that's capturing something really important of in-person conferences with this networking aspect. We don't have a traditional expo with exhibitors, but we thought we'd throw in some really nice goodies. So for instance, if you want to get a second ORDV free instance, or Will's GraphQL book for free, or you want to get a chance to win a special t-shirt, this is the area where to go to the goodie bags. There's also an area where you can get tech support about your Hopin platform, so you can go there and have a video call with them, with the tech support team, and talk to them about this. I'm really, really happy that my friend, CEO and co-founder of Neo4j, Emil, agreed to answer your questions. So 3 times in the next 24 hours, he will be joined by also our longtime friend, Andreas, at the end of each section, and do an AMA. So basically, there's an Ask Emil tab at the right side of your screen, and you can just put in your questions to Emil about graphs, graph databases, Neo4j in particular, or other questions that you always wanted to ask him, and knock yourselves out and ask some really good questions for Emil. During the conference, we also want to encourage everyone to share and tweet about it, and to make it more interesting, we thought we'd do a little bit of a competition. So if you're watching a talk, you like something, you learned something, please take a screenshot, tweet it out, attach Notes 2022 and live tweet to your tweet, and then you can win 30 different t-shirts, or 30 special t-shirts from that as such. That's also in the goodie bag section. And now I can leave you, enjoy the conference. I hope you learn new things, meet new people, exchange with others. Don't forget to share what you've learned. And with that, I want to actually close the loop. 12 years ago, at the first Graph Connect, the author of Connected, this book here, which is really, really good, I can recommend it to everyone, gave a keynote. So James Fowler, the author of the book, gave a keynote, and it was really great. And now, 12 years later, actually, I'm really happy to have the other co-author of this book, Nicholas Christakis, give the keynote for Nodes. And I'm a big fanboy of his. He's doing a lot of social network research, how it applies to society, to humans, to diseases, to spreading fake information, all the other things. And I'm really happy to welcome Nicholas for the keynote today. And enjoy.
Thank you, Michael. Thank you so much for having me at Nodes this year. I'm very grateful to be here. So human beings are embedded in social networks, and these networks obey very particular biological, psychological, sociological, and mathematical principles. And taking this into account offers us tremendous opportunities to gain new insights into behaviors and also to change them. We can use an understanding of social network structure and function for good, to intervene in both online and offline worlds in order to enhance our health and our well-being, our public policy, and our business objectives. And in the broadest possible sense, taking human embeddedness in networks seriously shifts our focus to the externalities of interventions. That is, it engages us in an exploration of how it is that when we intervene in a group, we affect not just the people that we target, but also all the other people around them. I'm interested in real social networks, the kind we humans have been making and embedding ourselves in for tens of thousands of years, and not just the recent online variety. Real social networks look like this. Every dot is a person. Every line connecting them is a relationship between two people. Who's whose friend, who's coworker, who's sibling or spouse or neighbor, for example. And these social networks are intricate things of beauty. And they are so elaborate and so complex and so ubiquitous, in fact, that one has to wonder, what purpose do they serve? Why are we embedded in them? How do they form? How do they work? And how do they affect us? And I've spent the last 20 years researching how and why human beings form social networks and how they affect our lives, our health, our desires, our feelings, our thoughts, and our actions. Now, part of this work has involved exploring the biological predicates and consequences of social networks and the evolutionary basis for social network structure and function to begin with. Social networks, you see, afford the people within them different possible structural positions. And I'm going to introduce these ideas right now, and we'll return to these basic points. There are a number of mathematical ways we can understand what it means to be in different parts of a human social network. But three of the simplest ways are illustrated on this slide. First of all, there's the number of connections that an individual has. So once again, this is a network. Every dot is a person. Every line represents a relationship between two people. And if we look at this network, we can see that node B in the upper left is different than node D on the far right in that they have different numbers of connections. B has 4 connections and D has 6 connections. This is known as the degree of a node, this number of connections, and people know this about themselves. People know how many connections they have, for example, or at least they can know it. But now we, with this bird's eye view, can see that there are other possible structural locations within the network that individuals might not be able to appreciate about themselves. For example, if you compare nodes C and D, C is in the middle of the network and D is on the periphery, they both have 6 connections. And if you talk to those two people, that might be the limit of their understanding of how many connections they have. But we, with this bird's eye view, can see that C and D are very different. And I can cultivate this intuition in you by asking you, who would you rather be if a deadly germ was spreading through the network? You should have the intuition that it's better to be D, that D is going to get whatever's spreading later in the course of the epidemic, if they get it at all. Conversely, who would you rather be if a juicy piece of gossip were spreading through the network? You'd rather be C. And because you have the intuition that C's in the thick of it, they're going to get whatever's spreading sooner in the course of the epidemic and are more likely to get it. So this property is called the centrality of a node, how central the node is in the network. And this can be quantified mathematically in a number of ways as well. Last, if you look at the nodes on the far left, A and B both have 4 connections. But the difference between the two is that B's friends are not connected to each other. They're not friends of each other. But A's friends are connected to each other. This is known as the transitivity of a node, whether your friends are knit together or not. And this might also affect your fate in life. Your ability, for example, to work together in a group might depend on whether your connections are in turn connected to each other. Now, one early project that we did in my laboratory was to look at the extent to which these 3 properties are heritable. This graph shows the extent to which this is the case. On the y-axis is the percent of the variance that's explained, or the heritability, by your genes. To what extent do your genes explain these properties? And on the x-axis is the 3 properties. And on the far left, what we show is that 46% of the variation in how many friends people have can be explained by their genes. Now, this is not very surprising. People vary. Some people are born shy. Some people are born gregarious. People vary in their taste for friendship. But we also found that 47% of your transitivity can depend on your genes. And this is one of the more bizarre results to come out of my lab in the last few years. Because what I've just told you is that if Tom, Dick, and Harry are in a room, whether Dick is friends with Harry depends on Tom's genes. Whether those 2 people over there are friends with each other depends on my genes. How can that be? Well, we think the reason is that people vary in their tendency to introduce their friends to each other. Some people knit the networks around them together, and some keep their friends apart. And last, if you look on the far right there on the centrality, 29% of the variation in how central you are in the network can depend on your genes. We think this is related to whether you have a predilection for befriending popular or unpopular people. If you befriend popular people, then you want 4 popular friends, I want 4 unpopular friends. That'll put us in different positions within the network. So the fundamental reality of our desire for connection and our susceptibility to social influence, it turns out, has always been with us. Where you are in this vast fabric of humanity depends in part on your genes. And our lab has been amassing evidence that it is indeed not a coincidence that we form social networks with particular mathematical properties. We've shown that there is an evolutionary significance to and heritability of social network structure and function. And that phenomena like peer influence, how we affect each other, and homophily, the fact that we tend to prefer the company of people we resemble, are of fundamental significance. Across evolutionary time, it seems that the benefits of connected life must and do outweigh the costs. Now, if social network structure has genetic antecedents and significance, it begs the question of how ancient this structure is and whether we might be able to document such structural features in human populations living in non-industrialized settings. In other words, the fantasy experiment we would love to do is to say, well, okay, could we fly back 10,000 years ago and map the social networks of our ancestors and see what kind of networks they made? Obviously, we can't do that. So we hit upon what we think is the second best thing, which is to map the social networks of the Hadza hunter-gatherers. The Hadza live in around Lake Eyasi in Tanzania in the ancestral human environment. They live like we did during the Pleistocene. They hunt and they gather for their food. They have no material possessions to speak of. They sleep out under the stars. And there are only about 1,000 of them left that live in this very ancient way. So what we did is we prepared a photographic census of all living adult Hadza using 10 years of field photographs. And we printed them onto these posters like a kind of Hadza Facebook. And we went into the field, and every time we could find a Hadza person, we asked them to tell us who their friends are. And we therefore painstakingly mapped the social networks of the Hadza. And we found a number of things. First of all, we found that Hadza networks look, both mathematically and visually, just like ours, just like modernized networks. In other words, despite the fact that in the last 10,000 years, we've invented agriculture, we've invented cities, We've invented telecommunications. The networks that we make are just like theirs. You see, network structure likely, and this is consistent with the very ancient origin of network structure and consistent with its partially genetic basis. Now, while we were there, we also found something else. This is an image of the Hadza network among women in the Hadza. Every dot is a person. Every line, again, represents different kinds of social relationships. We make the dot size and color related to how generous and altruistic people were. We had the Hadza play what is known as a public goods game. We gave them some resources and we said, if you share these resources with your neighbors, we will double those resources and you'll get back a fraction of what you shared with others. So you have to pay a little sacrifice. You have to make a little sacrifice, but everyone else will benefit more. And so the yellow dots are the high donation people, the more cooperative people. The red dots are the low donation people. They're known as defectors. And if you look at this, you can see that there are clusters of nice cooperative people and mean defector people located within the social network. And this clustering of cooperative behaviors within the social network is also consistent with the ancient significance of human social networks. I'll come back to this with some experiments in just a moment. Now, in a parallel, an early stream of work that we also did in my lab, using both observational and experimental methods, we and others have provided evidence that a variety of behaviors and phenomena beyond germs spread within our networks, beyond just dyadic ties. In other words, when you affect your friend, when you influence them in some way, your influence doesn't stop there. It keeps rippling through the network. And the challenge is to document that, to document the extent of that and the reasons for that. And across a wide variety of phenomena, we found that people's influence tends to spread to 3 degrees of separation, to your friends' friends, and your friends' friends. And that this happens for a variety of phenomena, like obesity, smoking, drinking, and drug use, with emotional states like happiness, loneliness, depression, or behaviors like altruism, like I just showed you in the Hadza, or with things like criminal behavior or voting or purchasing behavior or ideas. People's attitudes, decisions, and behaviors depend in quantifiable ways on the attitudes, decisions, and behaviors of others to whom they are directly or indirectly connected. A key idea about networks is that networks magnify whatever they are seeded with. If you put something in a network, the network functions like a kind of social magnifying glass. It makes more of it. But the network is agnostic. It doesn't care what you put in it. Networks will magnify Ebola or COVID or fascism or violence or fake news. But equally, they will magnify love and kindness and happiness and productivity and ideas. But something has to impinge on the network to get the process started. Now, of course, there's more going on than just this kind of social contagion I just alluded to. For instance, in the case of the contagion of obesity, several things might be happening. For example, the first thing that might be happening is straight up social contagion, or what you might also call induction, or a social domino effect. I gain weight, it makes my friend gain weight. My friend gains weight, it makes my friend's friend gain weight. There's a kind of spreading process in the network. Another possibility is that it's not my weight gain that causes your weight gain. Rather, it might be that birds of a feather flock together, or homophily, which is love of like. Maybe I befriend other people because they have a similar body size to me, or similar taste in exercise or in foods, for example. A third possibility is that it's neither that my weight gain causes your weight gain, nor that we form a connection because we have a similar body size, but rather that we share an exposure to something like a gym that makes us both lose weight, or a fast food joint that makes us both gain weight at the same time. And all 3 of these are typically present in any social phenomenon. For example, why are people buying a particular product? Are they buying a product because their friends are buying that product? Do people who like that kind of product preferentially form attachments to each other? Or is the marketing campaign of the firm really effective at getting many people to buy the product? So it takes effort using diverse statistical and experimental techniques to tease these sorts of effects apart. Here's one early experiment that we did to isolate social contagion. In this experiment, groups of college students were brought into the laboratory and they were randomly assigned into groups of 4 strangers, these little boxes of letters shown on the left-hand side here. And they were given a little bit of money, and they were told that if they gave $1, let's say, to their group, we would double that dollar so that the group would gain $2 of wealth, and each person would get 1/4 of that because there are 4 people in the group. So you give $1, you get back 50 cents, but your group gains $2. So obviously the best thing is for everyone to give maximally. This is called a public goods game. It's an economic model for human altruism. The best is for everyone to give maximally, but of course, from a selfish point of view, what you really want to do is give nothing and hope that everyone else gives. But of course, if everyone thinks that way, nobody gives and then nobody benefits. So what we did is we put these people into this type of a challenging situation, and they played one round, and then a bell would ring, and they would play another round, and a bell would with new people, then they'd be randomly assigned to new people. Then a bell would ring, and they'd be randomly assigned to new people and play again. And as a result of this, we were able to create simple artificial linear networks where we could trace back the sequence of interactions that previous individuals had had. And what we were able to find is that this kind of altruistic effect could spread from person to person. So for example, what we found is that if Eleni is kind to Lucas in period 1, Lucas is kind to Erica in period 2, Erica is kind to Jay in period 3, and Jay is kind to Brecken in period 4, a kind of cascade highlighted in red on this slide. And this is another one of the most bizarre results to come out of my lab in the last few years. Because what I've just told you is that how Jay treats Brecken depends on how Eleni treats Lucas, even though neither Jay nor Brecken ever saw or interacted with Eleni or Lucas. How 2 members of this audience treat each other may depend on how 2 other members of this audience treat each other, even though neither pair ever interacted with any other member of the other pair. So this is an experimental documentation of social contagion. And this geodesic, through the network spread of altruism, is distinct from the temporal persistence of altruism highlighted in yellow. In other words, if Eleni is kind to Lucas in period 1, Lucas learns to be kind. And he's kind to Erica in period 2, and Lysander in period 3, and Bemi in period 4, and so on. In fact, if you fold back all the downstream benefits, for every extra dollar that Eleni gives Lucas, the network functions like a kind of matching grant, doubling the downstream benefit. Or one other way of thinking about this is that pay it forward is real. Now, to be clear, we are affected in another way by social networks. It's not just what's happening around us that matters. The actual structure of the network also matters. Think about these 2 objects that you all studied in high school chemistry. They're both made of carbon. And on the left, you have graphite, which is soft and dark. And on the right, you have diamond, which is hard and clear. And there are 2 key intellectual ideas here. First of all, these 2 properties of softness and darkness and hardness and clearness aren't properties of the carbon atoms. They're properties of the collection of carbon atoms. And second, which properties you get depends on how you connect the carbon atoms to each other. Connect them one way, you get one set of properties. Take the same carbon atoms and connect them another way, you get a completely different set of properties. Similarly, the pattern of our connections affects the properties of our social groups. It's the ties between people that make the whole greater than the sum of its parts. New properties such as cooperation and violence, health and happiness, innovation and productivity can emerge because of the connections, because of the ties between people, and not necessarily because of the people themselves. So it's not just what's happening to the people around us that matters, whether they are happy or rich or thin, for example. Our experience of the world also depends on the actual structure of the ties around us, near and far. Let me give you one of my favorite examples of this. This is some work done by my colleague Brian Utsi, who became unaccountably interested in the success or failure of Broadway musicals. And he put together a data set of 326 Broadway musical production companies. And he mapped the social interactions of the teams producing these Broadway musicals. You know, the director, the producers, the musicians, the actors, and so on. And he computed something very similar to the transitivity that I introduced a few slides ago. So on the far left, you have, let's say, 6 people. You have the person in the middle. There are 5 people to whom that person is connected to, and there are 5 times 4 divided by 2, 10 possible connections among those people, but none of them are present. So you have 0% density on the far left. In the middle, 4 of those 10 connections are present, so you have 40% density. And then next over, all 10 of those ties are present, so you would say there's 100% density. And then he plotted in the cartoon on the far right, he plotted the density of the social structure of the ties among the members of these Broadway musical production companies on the x-axis, and on the y-axis, he quantified the success of these Broadway musicals. Now, Broadway musicals take hundreds of millions of dollars to make. They're high stakes, high risk business ventures. And he quantified the success either in terms of the money that they made or the fraction of positive reviews. And he found this parabolic shape. In other words, towards the lower end, towards 0%, if nobody knew each other from before, the show was a flop. And at the upper end, if everybody knew each other from before, the show was a flop. Optimal innovation and productivity was achieved in the middling range of density, where maybe some people knew each other from before and could work together effectively, and other people were fresh, brought in fresh ideas, and created a new chemistry in the group, which allowed the group to be more productive. So these sorts of observations have suggested to us 3 broad ways to intervene in networks so as to enhance public policy and in various ways, to use social networks for good. We can manipulate connection, which is change the structure of the network. Or we can manipulate contagion, which is to change the flows through the network. And finally, in a way I'll come to in a moment, we can manipulate position, which is to change the location of individuals within a network. And there's expanding science in all 3 areas using both online and offline settings. And I'd like to give you a feel for some of our results. These results are all from experiments, but we have other findings as well that from observational studies that I won't be presenting today. So over the last few years in our lab, we've developed software that we call Breadboard that allows us to easily recruit test subjects, including on Amazon Mechanical Turk or other settings, and create temporary artificial societies of real people. So we can, in a kind of godlike way, socially engineer different social arrangements, seamlessly recruit research subjects, drop them into these little worlds, have them interact with each other, pay them money for their trouble, and then experimentally manipulate these in order to test ideas experimentally about social organization. By the way, we've made this software publicly available. It's at breadboard.yale.edu. Here's some work involving the manipulation of connection that I mentioned that illustrates both the use of the software and this principle of the importance of social connection. We took hundreds of research subjects. We randomly assigned them to different worlds in which they were dropped into networks which obeyed different rules. On the bottom, we dropped, and then they played multiple rounds of a public goods game across time. 10 rounds, for example, is shown on the bottom, where it says 1, 2, 6, and 10. That's the round number. This game took about 40 minutes to play. So in the bottom row, people were dropped into a fixed network. They were dropped into one of the network structure was determined, and they were assigned a location as shown by the blue and red dots. And the color, and then they were given some money, and they were asked, would you like to share this money with your newly assigned neighbors? If you do, we'll double the money, everyone will benefit, but you have to pay a little price. Of course, you hope that your neighbors will reciprocate, or you can defect. You can be a red dot and not contribute and hope that others contribute. And what happened in that branch of the experiment was that about 2/3 of the people were nice blue dots, cooperative, altruistic, kind people at the beginning, but they were taken advantage of by their red neighbors who abused them. And so why should you keep contributing if your neighbors are mean to you? You start defecting as well and also not contributing. And across time, what you find if you trace out the lower row is by the end, everyone has converted into a defector. You've got a sea of red dots, except a few blue dots on the edge of the network, keeping civilization alive. In a different branch of the experiment, however, in addition to asking people whether they wanted to, and by the way, that branch of the experiment is typical of the kind of experience many of us had in high school when the teacher randomly assigned you to be with some people and in a work group to do a project and said, you're all going to be given the same grade, you have to work together. And if you were assigned with people who were lazy or incompetent, you had two unpleasant choices. Either you could do all the work because you wanted a good grade, and they would get credit for having done nothing, or if that annoyed you, you would also stop working and then everyone would get a bad grade, including you. That's the dilemma faced by the people in the bottom row. In the top row, however, in addition to giving the people the option of whether in this public goods game, whether to be generous to their neighbors or not, we also gave them a little bit of ability to manipulate their social connections. At each time step, they could cut ties to people who were defectors or form ties to people who were cooperators. And in that branch of the experiment, as you can see, cooperation persists. So in other words, I could take a group of you and randomly assign you to one regime of social connection, and you'll be really sweet and nice to each other. Or I take the same people and assign you to a different regime of social connection, and you're mean jerks to each other. So it's not who you are that matters. It's how the network is organized and structured that might elicit this property of cooperation, just like the carbon example I mentioned a few minutes ago. In a subsequent experiment, we explored the parameter space of the rewiring rate, this social fluidity that I mentioned a moment ago, whether you could break or make ties using hundreds of subjects in dozens of groups. And on the y-axis, on the x-axis here, we put the rewiring rate from 0 to 100%. 0% rewiring means you're in a rigid network, you have no control over your social connections. 5 and 10% means a little bit of control. 100% means every time step, every one of your social connections is up for renewal or can change or does change. And then in the middle is everything in between. And on the y-axis is a regression-based estimate of how cooperative the groups are. And here you see a parabolic shape. What this says is that if you're in a rigid social structure, cooperation is low. And if you're in an overly fluid social structure, cooperation is low. And the optimal cooperation is achieved in a middle range. This sounds like the result with transitivity that I told you earlier, but it's completely different. This is not transitivity, this is social fluidity, which again has this parabolic shape. And I can cultivate an intuition in you in this by asking you to think about different kinds of institutions we have in our society. For example, the kind of institutions related to marriage. If you live in a society in which marriage, no divorce is possible, on the far left, social rigidity. Once you pick your spouse, you're stuck with your spouse forever. If your spouse is mean to you, your choice is to be kind to your spouse forever and have them take advantage of you, or to also become mean, both of which are unpleasant. So, but meanness rises and sweetness declines in that kind of regime. At the other extreme, if you constantly have a new spouse, if every day you're assigned a new spouse, there's so much fluidity, you have no incentive to be nice to your spouse because they're not going to be there tomorrow. So what you want is a regime in which divorce is possible, but not too easy. You want a set of institutions that move people into middling levels of social rigidity. And I would suggest the same kind of thing happens with work groups in businesses and firms. You don't want overly rigid work groups, but you don't want overly fluid ones either if you want to optimize cooperation and actually other properties like innovation within these groups. Here's still another experiment of ours, a more recent experiment. This was published in 2015, manipulating another feature of our social interactions, namely whether we can see each other's wealth. This is a complicated experiment with many results, but let me give you some highlights from this experiment. Once again here, we dropped people. We recruited hundreds of people into dozens of groups. Actually, there were 1,400 people in this experiment who were put into these artificial societies. We gave them real money to play with, and we randomly assigned them to be rich or poor, and we have a lot of money or little money, and we randomly assigned them to be in either unequal, very unequal, slightly unequal, or very equal social worlds. For example, here, On the left, we assign people into a very unequal social world, which is measured by the Gini coefficient, which is a number that goes from 0 to 1, and it's 0.41 on the lower left. That's a very high Gini that has a high level of inequality, like Morocco or the United States, for example. And then the dot size is proportional to how much wealth people have. And then we put a little letter, R for rich and P for poor, which is what you're assigned at the beginning, the amount of wealth you're given. And then in one branch of the experiment, in the invisible condition, people now start playing the same public goods game I've been telling you about. And the color of the dots indicates the blue dots are the nice cooperative people, the red dots are the mean defectors. And they play multiple rounds of this game. And you can see in that on the left-hand side of this slide, in the invisible condition, that by the end of the game, many things have happened. The inequality has plummeted from 0.41 to 0.14. That's actually below Scandinavian level of inequality. All the dots are big. Everyone has gotten rich. And most of the dots are blue. Most of the people are cooperative. That seems kind of nice. In a different branch of the experiment, we flipped a switch and those people were put in the visible condition where they could see their neighbor's wealth in addition to their own wealth. And in that branch of the experiment, none of those outcomes obtained. The inequality stayed high, 0.38 and 0.36. Most of the dots were red defectors, and you don't have as many wealthy big dots produced on that branch of the experiment. So making the wealth of others visible was bad in this situation. And here's a summary of some other results from the same experiment shown differently. On the x-axis, we have the rounds across time as people play these games. And on the y-axis, we have the average wealth produced in these societies. And we had a 2x3 factorial design. We had 6 branches of this experiment where there were 3 different initial inequality conditions: no inequality in blue, low inequality in red, high inequality in yellow, and then 2 different visibility conditions: dotted line, the wealth was invisible; solid line, the wealth was visible. And if you can look at this slide, you find that actually, unexpectedly actually, in my case, the inequality didn't seem to corrupt or affect the ability of the group to produce wealth. But the visibility really did. When you made the wealth of others visible, you decreased the ability of the society to produce wealth. And the same kind of finding was obtained with respect to how cooperative these societies are. Here again on the x-axis is the round number. Now on the y-axis, we put the proportion of people who are cooperators, and you find the same results where inequality doesn't really affect people's cooperativity, but visibility really does. Now, these findings have implications for all kinds of policies in our society, everything from pay secrecy in firms, or sports teams, or school uniforms in schools. I used to be very much against school uniforms for various reasons. They struck me as kind of fascistic. But when we did this experiment, I began to kind of think of school uniforms as a kind of cloaking device, a kind of invisibility cloak that, maybe had the students focus on other things rather than on competing in terms of how wealthy they were, manifesting their wealth, for example, or social status. Here's another result on the importance of network structure, because we become interested in the sharing economy and in ways to optimize it. And we built a game that captures, now this is a more recent experiment, that captures some pertinent features of the challenges of sharing. Imagine wireless routers in people's homes, and that people can share the excess capacity when they don't need it. They leave their house, the neighbor can use their wireless capacity, but then when they come home in the evening and their neighbor's away, now they can borrow some of their neighbor's capacity. And in this game, people had to choose whether to share a resource that was essentially useless to them with their neighbor in the hopes that their neighbor would reciprocate. And using this scenario, we assessed how satisfied people were, and we randomly assigned people into 2 different network structures. And again, this is a complicated experiment, but the gist is kind of powerful in my view. Here, there are 2 different networks that are drawn on this slide. Both of these networks have 15 people. Both of these networks have 18 total connections. Even more than that, both of these networks have the same distribution in the degree of connections between people. For example, that little figures that are shown on the left there, if you look at how many people have one connection, 6 people have one connection in both networks. How many people have 2 connections? 3 people have 2 connections in both networks. How many people have 3 connections? 3 people have 3 connections in both networks. And how many people have 5 connections? 3 people have 5 connections in both networks. You basically couldn't tell the difference in which of these 2 worlds you were in. Same number of people, same number of ties, same number of people with the corresponding number of ties. And yet, when we drop people into these networks and have them play the Wi-Fi sharing game, you get completely different levels of satisfaction according to whether or not the network is organized to be assortative or disassortative. In an assortative network, popular people are connected to popular people and unpopular people are connected to unpopular people. In a disassortative network, it's the opposite. It's like an airplane network. Hubs are connected to small cities. So in a disassortative network, popular people are connected to unpopular people and vice versa. And what we found was that the assortative organization, which is what humans do, humans are organized in assortative networks, was optimal for satisfaction in this situation. So structure, again, matters, just like the carbon example. And we can engineer different structures of human groups to optimize different outcomes. Now, moving on, we can also perform experiments that manipulate contagion. For example, this is a paradigm of experiments we're conducting that illustrates how you might manipulate contagion, for example, in sets of villages, or in sets of firms, or in factories, or in work groups, or in classrooms, for example. Imagine you have 2 villages, the one on the left and the one on the right, and you have just enough money to target 6 people, the 6 yellow dots, with a public health intervention. For example, to teach people how to use a latrine or a vaccine intervention, for example. And the ordinary perspective in public health is you give those 6 yellow dots the intervention and you come back a year later and you ask, well, how many of those 6 people adopted the intervention? Maybe 3 of the 6. But that's not what I'm interested in. I'm not interested in response to treatment among the treated. I'm interested in response to treatment among the untreated. When you go into this village and you give those 6 people the intervention, I want to know what everyone else in the village does. Maybe you target those 6, you give them the public health intervention, 3 of them adopt, and maybe 3 of their friends also adopt, for a total of 6 people in the right-hand village, and in the control village, maybe 2 people adopt the practice. But now you should be thinking, well, maybe I shouldn't pick the 6 people at random. Maybe there's an intelligent way to pick the 6 people so I get more bang for my buck. And the answer is that that's true. Instead of, for example, picking 6 people at random, maybe you should pick 6 central people. Maybe you target 6 people again, maybe 3 of these people adopt, but maybe they persuade 30 of their neighbors to adopt. Same village, same intervention, same number of people targeted, 10 times the effect, because you have shrewdly used mathematical algorithms to target structurally influential people within the village. And then you can experiment with all kinds of algorithms, which is one of the things that my lab does. For example, one of the algorithms we use is an algorithm known as the friendship paradox. And this is the idea that your friends have more friends than you do. This is a mathematical fact about social networks. And I can cultivate this intuition in you by asking you at least to consider the people on the periphery of a network. For example, that person on the very far right there has 1 connection. That's why they're on the edge. They only have 1 tie. But their friend necessarily has more than 1 connection. In this case, 2 connections. And in fact, if you look at the bottom yellow dot at the bottom of the slide, their orange friend has 8 connections. And so for everyone on the periphery, their friends will have more friends than they do. It turns out this is a mathematical fact everywhere in the network. On average, your friends have more friends than you do. So if you pick the 6 yellow dots at random and take 1 random step to one of their friends, to the orange dots will have higher degree and higher centrality on average. And the reason this is fantastic is that you can find the orange dots without having to map the network. So now you don't have the cost or headache of doing it. You just pick 6 people at random, ask them who their friends are, and you give the intervention to their friends. And we've been doing this in a number of settings around the world. For example, in Honduras, where we work in the Western Highlands of Honduras, it's a very poor part of the world. People live on less than $2 a day. We have mapped the networks. We have another kind of software that we use called Trellis. This is which we make publicly available at trellis.yale.edu. This is tablet-based software that can efficiently map human social networks in the field. And in our first experiment, we had 32 villages, and we mapped the networks, and we randomly assigned the villages to 3 different targeting algorithms. And in 1/3 of the villages, 5% of the people, in all the villages, 5% of the people were chosen to get the intervention. In 1/3 of the villages, 5% were chosen by chance, randomly, to get it. In another 1/3 of the villages, 5% were chosen who had the highest degree. And in another 1/3 of the villages, 5% were chosen with the friendship paradox technique. And what we found is, so the question was, if you want to move a whole village and not just individuals to change their behavior, how do you do that? Who do you target? Who creates the most externalities for behavior change, and how can you exploit that? So, for example, here is how the targeting of 2 nodes might vary in one set of villages. The orange dots are 5% chosen at random, and the yellow dots are 5% chosen so as to be the people with the highest degree. So same village, different targeting algorithms, you can get a visual sense of the different people that would be chosen. And what we found in this experiment is that by using the friendship nomination technique, here on the x-axis is the days since they were targeted with, in this case, a multivitamin intervention. On the y-axis is the proportion of people that adopted the multivitamin intervention. And you can see that the nomination targeting strategy dominates the other strategies. So this is an illustration of manipulating social contagion. Finally, here's a recent experiment that involves manipulation of position. Now, just to give you an intuitive feel of what this is about, imagine you're a teacher and you have 20 desks nailed in front of you, and no one's seated in those desks, but the desks are nailed to the floor in a particular arrangement, and you have 20 students outside of the classroom with varying abilities. The question is, given that structure of interactions that the nailed desks on the floor allow, which student is near which student, where should you position the students in this network of desks to optimize learning in the classroom? Maybe you should put all the better students in the front or in the rear, or mix them up, for instance. This is a position intervention. How should workers, for example, be organized within a firm, given the same workers, given the same job functions, given the same organizational arrangements? Who should go where to optimize the performance of the groups? So this experiment explores this idea of a position intervention and also explores some other ideas involving artificial intelligence. So here what we did is we're exploring the ability of a group of people to solve not a cooperation task, but rather a coordination task. They're dropped into networks and they are told they have to pick a color dissimilar from their neighbors. Orange, yellow, and purple. And they're told that if they work together in this team over the course of 5 minutes, and they can change colors as often as they want, and they can all of them work together to converge on a solution where everyone has a color dissimilar from their neighbors, they'll be paid as a group. Otherwise, they get nothing. The point is they have to coordinate, they have to work together. And so on the upper left, at the beginning at 0 seconds, you can see that people are dropped into the network. They're given initially a random color. The red lines indicate who's in conflict with their neighbors. The purple connections indicate that there's no conflict. If you look in the upper left, you'll see there are 2 orange dots that are connected, and they have a red line showing that there's a conflict. You should have the sense that the dot on the very far left, that orange dot, if they turn to purple, they would eliminate the conflict with their neighbors. That's a smart move for them. At the bottom, we show the progress through the game. Time is on the x-axis. The number of color conflicts is on the y-axis. At the beginning, there are 12 color conflicts. and that everyone starts picking their colors and working on the game. And by 105 seconds, they've almost solved it. And you can see in the middle, there are 2 yellow dots, and now the group is stuck. They can't make a move that allows them to solve the problem. If one of the 2 yellow dots either picks orange or purple, they will increase the number of conflicts in the graph. But interestingly, that's what they have to do. They have to make a counterintuitive move. And in fact, that is what happens. And by the end, at 245 seconds, the graph is colored and the people are able to solve the problem. Now, in this experiment, what we did is we evaluated what we call hybrid systems of humans and bots, of humans and artificial intelligence players, and how it might be to work together, and how we might be able to add bots with certain kinds of programming to human social systems to make them perform better, and how the position of those bots within the system might affect what happens. We manipulated a couple of things in this experiment. We manipulated how the position of the bots, and that's shown on the rows. On the first row is the bots were put at random. So we dropped 3 bots into these systems. There were about 15 or 20 people. I'm sorry, there were 20 people and approximately 3 bots in each group. We had over 4,000 people in 210 groups in this experiment. Sometimes we dropped the bots in a random position. Sometimes in the middle row, the bots were put in the middle, in the central position in the network. And sometimes in the bottom row, they were put in the peripheral position in the network. In addition, we manipulated the behavior of the bots. In the first column, the bots had what we call 0% noise. At every 1.5 seconds, they looked at their neighbors and they picked the color with the least conflict with their neighbors, every 1.5 seconds trying to minimize conflicts. In the middle column, we gave them a little bit of noise. So every 1.5 seconds, they picked the color with the minimum conflict, but 1 out of 10 times they picked a color at random. And in the final column, they had 30% noise, which is 3 out of 10 times they picked a random color. Now, on these 9 squares, on the x-axis is the time in seconds, the duration of the game, and on the y-axis is the probability that the group has not solved the coordination game. The orange line shows the sessions with humans only, the control group. And you can see that at the beginning, the humans, and the orange line is the same in all 9 of these squares. At the beginning, 100% of the human groups have not solved the problem, but they work their way through, and by the end, 2/3 of the human groups have solved the problem. However, if we add 3 bots with a little noise, 10% noise, in the middle, we can substantially improve it, as shown by that purple line in the middle square, which a larger fraction of the groups is able to solve the problem. So bots with 10% behavioral noise added into the middle of social networks, a little bit of kind of random behavior in the middle of this group helps this group of people solve the coordination problem. And in fact, the humans learn to play better by having bots among them. And what's happening is that the bots are helping humans to help themselves. And we're building on this work to design and add simple bots to these and other situations involving social dilemmas and collective action problems. We're looking at ways to enhance the ability of groups' coordination, cooperation, communication, evacuation, navigation, and sharing by experimentally adding bots to these groups. And by the way, it's not just about inventing bots to add. When we do these experiments, we gain insights into what humans could do in human-only groups to make it easier for humans to function in these types of situations. What we're doing in my lab, in a sense, is exploring simple kinds of programming, what we call dumb AI, that might make human groups more effective. We're not focused on developing super smart AI to replace human cognition. We're inventing dumb AI to supplement human interaction. And because these dumb agents are added into collections of smart humans, the agents don't have to be that smart. They just have to help a little to help the humans to help themselves. Okay, I'd like to close with one final idea that'll take a couple of slides. And it has to do with what it means to intervene in a social network, because I think such interventions provide us with a way to manipulate social capital. And to understand one sense of this, consider this idea. What's a point of a connected life? Well, how does it help us as individuals and as a species? And it turns out that networks are a resource that we can all use. Networks are a kind of social capital. Now, most people, when they think about capital, think about money. But really, capital is any stock of resources that can be put to productive use. So capital is a reservoir of wealth that you can produce something with. And two further key ideas about capital are that in order to create capital, you have to invest skill and effort. You have to know something and do something in order to create capital. And second, and more subtle, and an idea that's been keeping me awake for 20 years, is that in order to create capital, fundamentally, what you have to do is make changes in a substance that make it yield a higher rate of return than it otherwise would. That fundamentally, the capital creation process is actually about the transformation of the natural world. What do I mean by that? Well, look at this idea. A farm is a stock of capital. By investing skill and effort to clear the forest, you make the land more productive of fruits and vegetables and grains and flowers, for example. And so you've transformed the natural world. You've transformed a forest into a farm, and you've endowed it as a reservoir of wealth, as a source of productive power. So land, especially improved land, is a form of capital. Or you can take this tree and you can invest skill and effort and mill it into lumber. And the lumber is more valuable than the tree because you can do things with the lumber you couldn't do with a tree. Namely, invest still more skill and effort and make a violin. And the violin is more valuable than the lumber because you can do things with a violin that you couldn't do with a lumber. Namely, make music. So at each step of the way, you invest skill and effort and you transform one thing into another thing, and you make it a stock, a reservoir of wealth and a source of productive power. Well, a key innovation in thinking took place in the 1960s to see people and their skills and talents as a form of human capital. And the chief example of this is education. If you endow someone with skills and knowledge, you change them and you make them more productive. Like you can take this dissolute former graduate student of mine on the far left, who's a drunkard, and you can invest skill and effort and clean him up. And now he's more productive and able to do things he wasn't able to do before. Or you can invest still more skill and effort and give him an education. And now he's still more able to do things than he was able to do before. Well, just like physical capital is created by a change in the material world, and human capital by a change in persons, social capital in organizations, in companies, in villages, in communities, indeed in our whole society, is a change in the relations among persons, a change that renders the group more productive and capable of doing things it was not previously able to do. And that is the deepest account I can give you of what social networks mean for our lives and why it is and how it is that we can use them to make the world better. Thank you very much.
How cool was that? I think that was pretty much amazing. The keynote finished. I'm super excited. Can I see some love in chat? I think I saw some great chat messages. People wrote how great it is, how much they shared this. You have not discovered the emoji chat, I think. Yes, here we go. This looks much better now. Lots of smileys that come in, so that's great. So we are on track with notes. So I'm very excited to be your track host for the beginning of this beginners track, and we are rolling right off to the next session. Next up is Stu Moore. Stu Moore is a product manager at Neo4j, and his talk title, that's the session that's coming up next, is introducing Neo4j 5 for administrators. So as you all know, Neo4j 5 just dropped the other week. So very interesting news. And Stu will talk in this session, give an introductory overview of Neo4j 5 and all the new features. So if you're interested in that, that's coming now. So Stu, thank you for being part of Nodes. Welcome to the stage. And let's kick it off.
Thanks for the introduction, Alexander. That's great of you. Thank you. That's a really tough act to follow. That was a very inspiring and thought-provoking keynote from Nicholas there. So I'm here, as you say, to talk about Neo4j 5. We went GA on the 24th of October. It was a really exciting release for us, not just for all the new features that we're delivering, but because this is the first time we've released our entire Neo4j product platform at the same time, all compatible. So that's everything from drivers, Bloom, browser, graph data science, the connectors, our whole product portfolio. So a fantastic achievement. So it's also obviously available in Aura and available through the AWS Cloud Marketplace with Azure and GCP coming soon. And just last week, we released the Helm charts for Neo4j 5's autonomous clusters. And I'll be talking about autonomous clusters later on. It's a really exciting new capability within our product. There's so much in Neo4j 5 that it wasn't really possible to fit it all in one session. So I'm focusing on the administration surface, the new capabilities that administrators can take advantage of. There's a companion session run by a colleague, John Stegman. It's on tomorrow. He's focusing on more the developer data science experience, drivers, how to kind of query and get value from your graph using Cypher and the other improvements. There's some focus on indexing, so being able to kind of get to that start point in your query before you run your traversals quickly and effectively. And there's a session after, John, where they're actually going a deep dive into indexing. So there's a lot here. It's spread across 2 sessions. We've grouped the things that are relevant to Aura and Neo4j 5 because Aura now has the ability to create Neo4j 5 databases as well. So we've split that. So you'll see kind of the developer data science and language and graph model, kind of the ability to interact through Cypher. That's all kind of our experience pillar. John will also be covering, because there's a bit of overlap, some read and export performance. We'll be talking about some of the indexing. My session here today, we're going to focus on kind of the improvements we've brought in write and import performance, scale and availability, some of the cloud native operations that we've introduced, admin, operability and observability, making it far easier to operate and manage your databases, and then supportability and security. So let's kick off with the write and import performance improvements. So Neo4j 5, you've always been able to, with admin import a large amount of data really quickly to load up your graph. However, administrators often need to pull data in, maybe in nightly batch jobs from other database systems, maybe as part of an ETL process. And up till now, that hasn't really been possible. There's some great new capability in Neo4j 5. You can now perform an offline incremental import. So what this means is you can have your production database up and running, and at some nightly process, you need to import a large amount of data into the database. You can now bring that in as a CSV file. You'll need to take your database offline, run a preparatory phase. If you want, you can then bring the database back up. It has to be in read-only mode at this stage, because we don't want any changes to the data before we've actually done the import. The build phase runs whilst the system can be online and read-only. It essentially creates like a delta of the database that is then merged in when the system's back offline. Now, the whole process can be run all in one in an offline mode, or you can phase it if you want to have the database available for read queries during the more lengthy build cycle. In terms of loading the data, it's 10 to 100 times faster than transactional loading, and is in terms of what you can expect in terms of incremental import speed. It will be comparable to the amount of time it took you to do your kind of initial data load at that kind of rate, because obviously it depends on your data model. Admin Importer this time supports importing new nodes with properties, new relationships between existing or new nodes. There are indexes will be updated, uniqueness constraints are upheld, property existence constraints are upheld as well. You will at this time need to manually seed the cluster if you're importing in an offline phase. So now I'm going to pass on to kind of some of the indexing. This is more for what admins need to be aware of. So I mentioned John's session tomorrow and a focus session on indexing right after it. Will kind of take you through more kind of querying and using the indexes. But I wanted to kind of get across some important considerations if you're migrating from Neo4j 4.4 to 5. You need to be aware that Neo4j 5 no longer supports B-tree indexes. These were replaced in Neo4j 4.4. We introduced new range indexes, which provide support for comparator operators. So you can do equals, greater than, less than, etc. And they work across booleans, ints, floats, and strings, which also include searching with starts with, and temporal values as well. New pointer indexes were introduced. These are great for kind of geospatial kind of map type situations where you need to compute range and distance between points. Now, whilst they were introduced in Neo4j 4.4, you couldn't actually make use of them. They continued to use the B-tree indexes. But as a preparatory step before you move and migrate from 4.4 to Neo4j 5, you need to create these new range and point indexes because during the migration process, Neo4j will check that they exist, and once it's complete doing the migration, it will remove the old B-tree indexes for you. We also introduced support for indexing lists and arrays in full text indexes. So again, making it easier to find data within your database. And there have been some text performance improvements. We've introduced a new trigram analyzer that speeds up, that contains and ends with searches as well. Scalability and availability. I mean, this is kind of like, the real killer feature for Neo4j 5. It really lays the foundation for our future. You may have heard at Graph Connect, Emil talking about our vision for the future around knowledge lakes. This is like our foundation technologies. I cover both of them, but I think it's important to stress that actually composite databases are now part of autonomous clusters. This is our fabric, how you do ultra large, high scale with sharding and federation. And I'll talk a bit more about each of those in a minute. But first, I want to kind of go through autonomous clustering. It's perhaps one of the most sophisticated clustering architectures in database. It enables elasticity within your cluster. You can now scale out with more and more servers within your cluster. The key kind of innovation change within our clustering technology has been this: you no longer need to run a copy of the database on every single server within the cluster. So previously, if you went from 3 servers to 5 servers, you increased your level of fault tolerance. You could obviously add more read replicas, dedicated servers for reads. But in Neo4j 5, what we allow a cluster to do is have as many servers as you want. Current scaling is up to 10s of machines. And each of those machines can host a read or a secondary copy or primary copies. You don't have every single copy of the database on every single server. So this kind of frees up and allows you to scale out. And I'm going to walk you through kind of an example in a minute. The other thing that is important to stress is obviously Fabric, or the composite databases, is now an integral part of the cluster. So this means you have a shared view of the schema and security within the cluster. So let's say the administrator, you want to create 3 different fault-tolerant databases within your cluster. And you've got 5 servers available to do that. What's required? Well, you need only specify what you need, and the cluster figures out where to run it. So you'll say, I want to create database. I'm giving it the name knowledge. And my topology that I want to create within the cluster is I want 3 primary copies because I want some level of fault tolerance, and I want 1 additional secondary copy to provide read replica, read kind of query support. And I also want to use it to take my backups because I don't want to place a load on the primary databases. So, you just issue the command, autonomous clustering picks 4 appropriate servers within the cluster, and that's job done. You then want to move on and say, I now want to create the databases in yellow. I run a similar command. I just specify 3 primaries. In fact, if I've set a default value, the cluster can create 3 without me specifying the topology. Again, they get allocated to members of the cluster, and autonomous clustering will use its first algorithm that we've provided, which is an equal number. So it will distribute the databases in an equal number of databases per server. Then as you add your third and final database, it does the same thing. So you've got an even distribution of databases within the cluster. And future versions of minor versions of Neo4j 5 will introduce more placement rules and other ways of allocating databases within the cluster. Now, let's take the kind of scenario that one step forward. Let's say there's some seasonal demand. You want to increase the capacity. You want to distribute some of the databases across, some more servers. You can add in a new server. You enable it as part of the cluster, and then you just run a deallocation command to move some of the databases. Run reallocate to reallocate the databases across the cluster. If you want to then scale back in, you want to go from 6 servers back to 5, you deallocate the databases from the server of your choosing, and then you run drop and you remove that server from the cluster. Once you specified a server to be deallocated, if some other administrator went ahead and created some other databases, they wouldn't get allocated to that server because it's been flagged as deallocate. And all of this is done safely without affecting the fault tolerance level of the cluster. So this brings me on to Fabric. So previously in Neo4j 4.4 and prior versions, Fabric stood outside of the cluster. We had individual Fabric proxies. But with Neo4j 5, Fabric is now an integral part of the cluster. And for those of you who may be unfamiliar with Fabric, it's our way of enabling you to execute queries in parallel across many databases. You can chain those queries together to perform some really sophisticated real-time analysis. And there are kind of two key use cases for Fabric. And the first, federation, where you're taking several databases, all with different schemas, and you're trying to aggregate the value of each of those databases and bring it up and solve and answer other questions within your business. The other is around kind of scale, enabling you to take a multi-terabyte database and shard it. So separate the data into individual databases that might be easier to manage than performing, backup and restores on, multi-terabyte data. Again, querying those shards is all done in parallel. So let's look at this in a little bit more detail. So in the case of you've got a cluster, you want to use it for sharding. Your application has customer accounts. How do you choose to shard it? Well, one way of sharding the application for accounts might be taking all the customer accounts that are A to G, or maybe it's a numerical identifier. You could do it in a range there, and then you've got H to M and N to Z. So this kind of gives you the opportunity. Each of these can kind of scale within their own databases. And you're able to access all that data by querying the composite database accounts. Accounts holds a reference to each of those three shards. Another example is the federation. So if you think about how fraudsters sometimes look to take money from financial institutions, one of the ways is to submit a large number of applications across different business systems, because they're relying on the fact that they're all kind of individual isolated systems. You could create a federated fraud detection system by spotting rapid applications with varying information for personal information across those different database, loans, credit card systems. You can go beyond the cluster. So whilst I said, Fabric is part of the cluster, that doesn't stop you from being able to query databases or clusters that are remote from it. So this kind of really opens up the possibility of querying archive data that you want to have in other clusters and kind of almost scale federated databases across clusters held by other parts of the organization. So just kind of quickly, I'm not going to go through this in a lot of detail. There's a dedicated session which I'll call out in a minute. But essentially, you're just creating a database, each of the shards. To create a composite database, you just say create composite database transactions. That's the name of the composite database. And then you create aliases which reside inside of the transaction database. When you then do show database on the transaction database, it tells you it's a composite database, and it gives you the constituent shards that exist within that configuration. This means that when you then query the composite database, you can then get back a list of those shards, which then allows you to query Fabric and iterate over the shards within the Fabric environment. So just to summarize, you can dynamically create sharded and federated graphs in Cypher It's fully integrated into the database availability infrastructure. You get full fault tolerance, and you can go beyond the cluster. You can find out far more about Foundations for Scale with Hugo Firth and Tobias Johansson. They're going to go into some great scenarios and worked example of all of this. So in keeping with, kind of our work and partnership with the Aura team, there are some kind of changes that we do, but these don't just benefit Aura, they benefit our customers who provide Neo4j as a database platform within their organization. So they may be serving databases to business units within their organization. And for those of you who want to self-manage in the cloud as well, we've made some changes. So the first of these is the server-side routing, which was introduced in Neo4j 4x, is now enabled. It was previously disabled and you had to enable it. So this makes it far easier to just deploy Neo4j 5 behind load balancers in the cloud. And server-side routing, for those of you who aren't familiar, basically means that instead of the client having to maintain which server is the leader, the cluster will tell and route requests to the right server. And this is kind of pretty important when you consider that not every database will be running on every server within the cluster. So it makes it far easier for application developers and those using drivers to just send requests, let the cluster figure out where to route it. For those of you who need to lock down Neo4j 5, the admin role in particular, you want to give the admin role to some individuals. You don't necessarily want them being to go off and create databases. You can configure this in a security init file and restrict their actions. So you can deny them the ability to create a database using the immutable keyword. And the only way this can be overridden is if someone has access to the physical file system where Neo4j is running, and obviously network and other security permissions kind of can be used within your organization to lock that down. I'm just going to go through some exciting improvements for the operations of our product. There's a whole talk about Neo4j Ops Manager. This was our new product release that came earlier this year. It's fantastic. It really opens up your capabilities to manage lots of servers and clusters. As an ops guy, you can manage multiple instances, you get your metrics and your status, help you with complex tasks, which are a bit easier to represent visually, like managing securities and cluster. And it provides some fantastic upgrade and migration wizards, which can kind of help you provide tailored steps and procedures to follow. You can find out more from Chris Shelmerdine, product manager for Neo4j Ops Manager, and some other great sessions as well. In terms of backup and restore, we've introduced far more capability with needing far less storage, up to 75% saving when it comes to using kind of the likes of full and differential backups. You can chain differential backups together and aggregate them and create a full backup if you want. You can do point and time restore within differential backups. So you can't do a point in time restore from a full backup. But once you've done a full backup, if you've got differentials, you can then go to any transaction or any point in time throughout that chain. There's an API to improve operability, and now the backup is done as an immutable file, so not a directory. So you don't have to worry about additional files getting copied in there accidentally or files going missing. It's a single file. Legacy backup available in Neo4j 4.4 is still available, you'll have to just modify one command just to inform it to use legacy mode, but your scripts and behavior will be the same. On the security front, we introduced impersonation. You could configure impersonation in the Cypher shell. You could use it in drivers, but what you weren't able to do was impersonate within the shell. So we've introduced the ability to start the shell impersonating a user, or once you're in the shell, to do : impersonate and then the username. This helps you test out the permissions that you've created. You can check scripts are executing correctly for users, and you can even then demonstrate effectiveness of your permissions policy to auditors or other sort of governance bodies. Supportability, there's some great changes. So we're excited to say that we're extending the migration window. So when you go from Neo4j 4.4 long-term support to Neo4j 5 long-term support, you'll now have 1 year to transition. So the nice overlap, and that will continue for Neo4j 6. Our old branching model we had with 4, where we had a patch release, so a minor release of 4.0, 4.1, 4.2, with each of those supported for 18 months. That's changed now. So in Neo4j 5, we have what's called a continuous release support model. This means that we'll release frequent features and fixes. That will happen all the way up to the long-term support release. And at that point, then we'll only release fixes. It does mean that it helps your move two-way migration from Aura to Neo4j or vice versa, because you need a version that will keep up with Aura as we release exciting new features and fixes. Self-managed customers will benefit as well. To facilitate this, we've vastly improved the upgrade experience that was previously available. You're no longer required to go from one minor version to the next. You can still go 5.1, 5.2, 5.3. But excitingly, you can now go from 5.1 to 5.5 or 5.5 to 5.10. You don't have to upgrade, but you will be upgraded if you need to take, if you need bug fixes that come out in the later minor versions. Obviously, if you want to take advantage of new features, you can do the any-to-any upgrade as well. And this works with rolling upgrade within clusters. Migration, I'm not going to go through this kind of in detail. I mean, suffice to say, it's most important to prepare, review the migration guide, and get NOM Ops Manager deployed as well. That can really help you in the preparation and planning and rollout. But basically, get 4 prepped by creating your indexes, check your configuration files, and 5 starts up. Then when you're ready, you can do Neo4j 4.4 online or offline backup. If you're going to do it online, make sure you set it to read only. Perform your online backups, then restore, perform the migration. It's really important to stress actually that migration in Neo4j 5 does not depend on the size of the database. It's ultra quick when you compare it to migrating from 3.5 to 4.4. You don't need to make large changes through the database structure. It's just an update to the metadata, so it's very quick. Then once you've got Neo4j 5 started, seed your cluster, and then cut over your clients to the new server. There are some breaking changes in 5. We'll only introduce breaking changes in the major version, so there'll be no further breaking changes throughout the whole of 5x. The admin commands have been improved, and the arguments and settings are way more consistent now. This caused a lot of problems for new users to get their heads around how commands worked. So our experience in 5 is going to be a lot better for new users. It will be tricky for people who are existing customers and users to be familiar with the changes, but the restructuring and big organization is a big improvement. I've talked about backup and restore. We've given better namespaces within the conf file. And also importantly, we help make sure that the database settings are applied appropriately to the database or the cluster. And Java 17 is now a requirement, up from Java 11 in 4X. So just to conclude and wrap up, and thanks so much for tuning in and watching. Neo4j 5 for administrators. We've delivered on write and import performance, read and export, scale availability, some cloud native operations, just general operational experience, bringing it in line with that great experience that you get in Bloom and browser, supportability and security. So thanks again and enjoy the rest of the show. Thank you.
Super cool. So thank you very much, Stu, for taking the time and for presenting. Technically, I think we have a minute or so we could answer one question live on stage, and then I know you will be moving down to the chat and help out with other questions. So do you want to take one question live?
Yeah, happy to. Yeah.
Yeah, do we do one? So from Anthony on the index question, comes a question on indexing. I put it in here as well. Does create index build a range index by default in version 5? Are B-tree indexes converted? Will performance degrade if range or other is not re-added? I guess it's like a bundle of questions. But maybe we do
in one. What we'll say, so just if you're migrating from 4.4, you need to create your new index types in 4.4, and then that, as you migrate, will ensure that your B-tree indexes are then cleaned up. So they're not so much converted as say, they get populated when you start up in 5. Yes, so your performance will be impacted. If you used to have B-tree indexes and you don't create your new ones, yes, you would have problems in the migration process, but also without indexes, your performance would be impacted because you can't use them to find data in the starting point in your graph query. I don't know the answer to the first one, but I thoroughly recommend attending the focus session on indexing, which is tomorrow, I believe. I forget the time, but definitely attend that one.
Okay, that's all right. Cool. Thank you very much, Stuart. I think you will be in chat as we go now. Continue with the day. So there were a couple other questions. So Stuart will move over to the chat and answer a couple of these other questions. So don't to be patient. We'll try to help with these questions as we go. So yeah, thank you, Stu, for presenting, and see you
Pleasure.
soon. Yeah. All right, so now we have a short break. So it's time for me to maybe put this one up. Stay hydrated. So I hope before this session I had only like a short time to welcome everybody, because we had a little the gap between the amazing keynote and Stu's session was super short. But now I think we have a little bit more time until the next session starts in 4 minutes. So I can properly welcome everybody. Thank you for joining. Thank you for being here at the beginner track of Nodes 2022. I hope you have a good time so far. So yeah, my name is Alexander. I'm hosting a couple of Neo4j live streams on YouTube and other channels. So if you are interested in attending some of these as we go in the future, you can just subscribe to our YouTube channel to be up to date of all things we are doing, or go to our community page. So I think that's you know, the shout outs I have. With that, I think, you know, for nodes and for the time being, you can stay in this channel, in this track all day long, and it's gonna be a full you know, platform with all the tracks and interesting sessions until basically tomorrow this time, if you so desire to stay on for 24 hours. If you are you know, wanted to switch, or have built your own agenda, you can always go back out of this stage and go to the reception hall basically, and move into another track. Don't forget to check out the goodie bag. So there's really cool things in there with our virtual goodie bag that Michael mentioned. So we have a couple of nice freebies. The highlight for me definitely is the second Aura free instance. So I think that is pretty exciting. So as you know, if you register with Aura, you get one free database for you that stays with you and that you can use as much as you like it. Maybe as well, you have watched a couple of the streams I'm doing with Michael on AuraDB, how to get going. So you're wondering, okay, I have an AuraDB instance, I know this already, but now with nodes, you get a second one. So that's pretty exclusive. So don't forget to grab that and to enroll for the second AuraDB instance. Other goodies are there as well. So explore. If you are, I mean, I hope not, but if you are done watching sessions, you can talk to other people. So we have a cool networking feature. So that gives you, like, in this short I think it's 3 minutes, video call with somebody randomly also attending nodes. So if you are up for a fun conversation with somebody else, then yeah, that should be that could be fun and very interesting to talk to some other graphistas. Yeah, and with that, I think almost ready to go. So I'll shut up now. Or not yet. Sorry, you got me a few more seconds. I'll introduce the next speaker. So, but let me get rid of this. All right. So next up is, let me put him here. Hi, Gregory. Next up is Gregory King. Gregory is product manager for developer tools at Neo4j. His session is bootstrapping your graph project with Neo4j Workspace. And what does this mean? So in this session, you learn a little bit more about the new Neo4j Workspace. I think that has been just publicly released today for all instances. So very exciting news released today. And the Neo4j Workspace blends data modeling, import, Cypher querying, and visual exploration in one place. So pretty cool tool. And yeah, with that, Gregory, take it away.
Thank you, Alexander. Great to be presenting on this topic. So yeah, in today's session, I'm going to be praying to the demo gods because I'm going to try and do this mostly hands-on. And I've got quite a lot to get through and show you. So yeah, let's get straight into it. So Workspace is available in beta today. And what I'm hoping to do in this session is tell you how you can take an idea, some raw data, some concepts, and kind of model them as a graph and do some initial nodes. Start querying it to derive some insights, and then think about kind of iterating and expanding on that. And then finally kind of looking at some of the ways you can visualize and explore the graph within Workspace. So to make this a bit more relatable, especially for me, residing as I do in the UK, I've maybe wisely or unwisely, I don't know, I've chosen to take a look at UK politics data. So yeah, the kind of comedy that you see going on the animation on the left there. So looking at some open source data, so I kind of had an idea. I wanted to see kind of what existed open source. So there are a few projects that exist out there, some kind of independent and all related kind of government data. There are some projects out there like Public Whip in the UK that try and make information about politicians, members of parliament, and the things they vote on, the divisions, the technical arcane term for it, and the policies and the houses they kind of sit in and the parties they represent, all available. And then there are also other websites like They Work For You, which is like a website that kind of gives you, amongst other things, a view of what kind of interests politicians have in terms of what people pay them to support them and that kind of stuff. And then we have a registry of companies in the UK that kind of helps you understand the companies that maybe give money to politicians, what kind of business they're in with industry codes. So in this, I was just kind of hoping to see, taking the seeds of an idea, some data, and kind of trying to see if some of the things you read about in the press that kind of a lot of people have heard of, regardless of the country you're in, conflicts of interest, what they look like in graph form. So a big disclaimer at the bottom. Nothing here has been verified for accuracy. This is kind of a rough and ready kind of exploration of the data, but it was pretty interesting to do. So starting off, this is Public Whip data that I was able to get my hands on. So this is a dump of a relational database that is fairly rich, but it's pretty complicated, as you can see from the image on the right. You've got information about MPs, members of Parliament. You've got their names, their MP IDs, the parties they represent, the areas of the country they represent, roles they hold, things they vote on, including the kind of links between the MPs and the things they vote on, and a whole host of other data. So how do you go about starting this with on this problem with Neo4j Workspace? So I'm going to show you kind of this rough process here that I went through, and I didn't want you to kind of sit through loads and loads of kind of several minute long data loads. So I've kind of seeded all the data in the project here already. And I'm opening, as you just saw there, I was opening up from my Aura instance that I've created, and then straight into Workspace, which is available for everybody as of today. And what I'm going to do in here, I'm going to switch first of all to the Import tab, and I'm going to go across and get some of that data that I was talking about. So some of this open source data. Let me just switch across to that. So here in Data Importer, I can drop in my flat files and I can start thinking about sketching out my graph model. So some of the things I was talking about, you have members of Parliament, and you have, let's see what else we have on the left-hand side. So we have, for example, in the MP file down here, we have the house that they sit in. So in the UK, it's the Commons or the Lords, and then there's a party that they represent. So you might name this relationship member, and sits. They do a lot of sitting down when they represent people and they do their debates, and they're, say, a member of a party. And then the process here is very much about mapping this flat data. Here I'm exclusively going to use this first file that you saw on my previous slide to do that. So you're going to have PWMP, select from there the MP ID. I'm going to bring in their constituency, because technically it's the person that is the name, and people get elected, for example, a member for Hackney, North and Stoke Newington, an area of the UK. I think that's everything we really need for the member there. So here it's kind of automatically chosen an ID based on a strong clue here to uniquely identify that MP. And then on this side, we can do the same process with this file, but this time for the house. So we're going to say, okay, we want to know how that person, or rather that member, what house they sit in the political party. And here the import tool is automatically mapping in for us how that relationship gets defined from the MP ID to the house in the same file. And we can do the same thing for the political party. So we can map in the party here. And it's doing lots of convenient things for us here, kind of choosing, we've only added one property, that's probably the ID to be used. And in the import tool, we can do a quick preview without committing any data, just to see whether this is taking shape and kind of doing what we expect. So we can load in here. We haven't loaded lots of properties on the members. But we're seeing some of the titles come through there, but we can see there are lots of members that sit in a certain house. So the Commons is the biggest house in the UK, and we can see the Labour Party here, and we can see some of the other parties kind of on the fringe here, maybe the smaller parties, the Scottish Nationalist Party, Plaid Cymru, I think this is, and Sinn Féin, Ulster Unionist Party in the Republic of Ireland. So that's pretty cool. So we can do that, and we can run the load, but I'm not going to show you kind of the load of here because I've loaded this data already, but I'm going to show you what the more extensive mapping looks like for this data. And I'm just going to bring back in the files here for completeness. And we can see how here we've got a fairly extensive model where, I was mapping out this part here earlier, but you can repeat the same process using different files to get quite an extensive model to load your data through. So that's pretty cool. That's a nice starting point. So here I've done all this without writing a single line of code, and you can then go and start querying that data. But there are, the tool I've shown you is designed to get people going, and it's not necessarily going to cater for every load case, but that's not a problem because we can break out to kind of other ways of loading data that allow us to kind of do more complex loads. So part of the model that we kind of couldn't quite load here with this tool is the policies and the policy sets, just because of the way they link with the complexity. So I'm just going to show you through how some of that stuff was done here, where we can load in, and I saved this here, and I'm going to run through this pretty quickly because I don't want to go into tons of the detail on it, but how you can do things like to make the load run more quickly, create an index, or we could have created a constraint on the policy and the thing that uniquely identifies it. Simply from referencing the file, we can make this available on the internet to kind of link into it, create policy nodes with those IDs and set the properties from those files. So, this file down here, I believe this is the one. And then this is where it gets a bit more complicated, creating an index kind of on a compound here that we can then use to do the match against things that are already in our model. So, for example, the divisions that we already loaded, and then link those into the policies and create new supports relationships. And this allows us to do some kind of quite cool stuff subsequently. So that's all done in here. We can see that I've got quite an extensive set of stuff loaded here already, and that data is loaded in to our model here. So we've now got some of these parts of the model. So the other part is loading in the policy sets. Now, when I was kind of working on exploring this kind of, bootstrapping my graph project for exploring UK politics data, there was also kind of a set of, the policies are the things people vote on. So I can probably show you a few of those things, show you what they look like. So you've got some policies like people who are, things that are votes for people who are, for example, against the Iraq war, and kind of more detail on there. But these are quite granular, and there are quite a lot of these. So it's pretty nice to be able to roll this up to a higher level to some policy sets. So kind of in this project, it was pretty complicated how these policy sets came up and together. And there was a lot of information about how people edit wikis to come up with definitions of how all that works. But in scraping the web in this project, we were able to come up with some pages that showed how to do that. And I was able to scrape from the web some kind of simple data structures that showed how particular policy sets with names were mapped to particular divisions. So this is a really nice example where I could scrape a basic set of data structures from the web and use this to create some nodes that kind of give me more clarity and higher level kind of abstractions in my graph. So I can run this in Workspace, and this sets a number of parameters that are ready for me to use to create new nodes that summarize some of the information in my graph. So the next stage here, kind of looking through all of those policy sets, creating kind of higher level policy sets that make kind of a part of set relationship. So you can imagine here, there's a high level policy set that aggregates some of these individual policies, so you can get a higher level view of what people are voting on. So I could rerun that. It would take a few seconds, but being as it's been run already, I'm not gonna do that. And then we could do some potentially interesting things here. We've got kind of a good core of our model in here, and we can start looking at things like how many different policies saw different votes on these divisions. So members of parliament voted on divisions that support policies, and then in turn, I've commented this bit out, are parts of sets. So we could start looking at how the policies and sizing them by the number of votes they've had on them, and also the policy sets, if I was to kind of comment this back in and then start summarizing on PS for policy set. So I've run this stuff already to kind of save, but primarily to save myself making mistakes but also to kind of in the interest of speed. But if we look here, the relationship I was creating, or rather the nodes I was affecting were the kind of part of set, so policies and part of set. So we can do a quick visualization in Bloom here. And if I type the name of the relationship, so it's part of set, I think we can see, yeah, that relationship coming in there. And we can start to explore what some of that looks like. So I've pre-configured this here, again, in the interest of time, but I've used some rule-based styling within Bloom to size the nodes based on the number of votes they had in. Now, there's one node here, if I zoom in a little bit, that I know is not super useful. It's like the catch-all, it's called summary. So I'm just going to dismiss this one and get rid of that. And then kind of zoom out and see, what are the biggest things that are, important in UK politics over the last few years. So I can see that the biggest policy set, the aggregating, is foreign policy here. And we can see that, by far the biggest node in terms of policy topic is European integration, so AKA Brexit, and something that has very much occupied UK politics for a very, very long time. So that's pretty cool to get that level of view here. So what's next? So there's loads of cool analysis you can do here in terms of looking at the positions that people hold on these policies as well. So I'm going to kind of cover this also super quickly so I can show you some of the final things too. But you could start exploring the graph and kind of, let's look at the against relationship that I'm creating here. We can start, let's decompose this query and let's just comment bits of it out for a moment. So let's return just the first part of this query. Let's return just one line of this. So we're looking at people elected members of parliament that voted on particular divisions, the things they vote on, and how they support a particular policy. So I just run that and we can see that pattern here. So we can see, and actually I ran this earlier and I knew that this person didn't actually vote on any particularly interesting policies as the first result. So let's just skip through the first 1,000 rows and look at somebody who might vote on something. Actually, let's skip another 0 and see if we get anything more interesting. So here we're getting somebody called Irene Adams, who was elected to Paisley North. Maybe I didn't find something super interesting in this example, but they're kind of voting on council tax, and this is kind of a policy around somebody who kind of observes conservative values. Now it's worth saying that all these policies are created by a community, so some of them roll up to that higher level policy set, some of them kind of just are kind of very niche topics, and this is probably one where they're kind of correlating and doing analysis on particular niche policy views that you can view in the data set. But what you can do, looking at these kind of patterns of here, is you can see that if we look at here that this MP voted no to this particular division, and we can see here that this supports relationship. If somebody votes A, which is kind of the old British arcane term for yes that we use in Parliament, then that means they support this policy. So that person voted no, so they're generally not in support of that kind of policy. And we can use that information to kind of create some kind of shortcuts in the graph to kind of cut out some of these parts of the path. And we can create position against relationships, and we can create, on the other query that I've got here, position for relationships. So we can start to see how people support or don't support particular policy topics, and aggregate on the relationships the number of votes on that. So I can show you some examples of the relationships created here. So for example, position against, there's a particular, let's have a look here, there's a particular MP returned, and you can see their positions with a number of votes on a number of different kind of policy topics like pro-Euro, one nation conservative, so on and so forth. And not shown here, I've kind of pulled in some of a kind of a further level of aggregation at the party level using a similar principle where you can view people's parties' positions on policy. So aggregating it up to the kind of the party level. So let's try that in this view here. I'll clear this scene and look at position on policy, and let's see what comes back here. So we've got quite a few parties in here. I'm just going to manually select, let's zoom out a bit, and I'm going to kind of manually select a few of the kind of smaller parties because I want to look at, say, focus on some of the bigger UK parties in this analysis. The two biggest being, let me just dismiss those few, dismiss those nodes. Where's my option? Can't quite see that. Let's try again, dismiss, and then let's dismiss a few of the others in here. I could have probably written a more sophisticated query to just bring these two things in, but I'm going with brute force here. So here are the two main parties in the UK party political system, and here we've kind of run in some metrics that also I'm not showing the detail of, but kind of looking at the proportion of people who vote for a particular policy on one party versus another, and representing that proportion as a thickness of line. So a thick line means supportive, a thin line means not supportive. And it probably doesn't surprise anyone that the nature of kind of two-party politics in the system shows that if one party is generally for something, another is generally against it. So you get thick lines on one side, thin lines on the other, and they're generally quite polarized on most topics. I did a further analysis of this kind of offline, and I think the only thing political parties generally agree on is kind of mass surveillance of people. So it's kind of an interesting takeaway. So that's kind of doing that further analysis on what people kind of tend to think about different policy topics. But going back to my initial theme of what I was trying to explore, I was also trying to look at kind of the kind of interests, as it's termed in the politics, the interests that the MPs have to register. So they're required by law to kind of show donations that they receive from different entities, be they individuals or companies, and that kind of thing. So here on the left is an example of for Ms. Diane Abbott, the one that comes at the top of the alphabetically sorted MPs, an example of something that she reports from back in June this year. So again, I won't show you the kind of detail of the importer config. It's pretty much the same thing I showed you before, using data importer to load in those interests. They had records of the people and the categories, so we could link them in based on IDs to link the interests into the people we had in our existing graph and some categorization. But we could then run some very, very basic entity extraction on that. And for this, I used Google Cloud Platform to do this. There are probably much cleverer and more sophisticated ways of doing this, and I kind of ran no tuning on this. So there are quite a lot of false positives in this. But it's good enough kind of just extracting some initial insights. And I can show you the kind of thing that came out of this. So I think I've got a GCP entity kind of link here. And we can see that, let's take this one over here. There's a particular interest here where a member of parliament, which I would see if I kind of linked out from this node, received complimentary tickets for a rugby match from the Welsh Development Agency. And there are other interests in these kind of things, where they've received them from breweries or betting companies, or there are interests in the financial domain that are probably even more relevant. And we can see how the entities have been extracted here from this. So the interesting thing is we have locations, but we have the organizations pulled out here, and that forms the basis for some of our subsequent analysis. So the final step in this analysis is looking at companies' house data, because the last chain in kind of my analysis was thinking, well, okay, we've got now a view. If we go back to our graph, we've got MPs, we've got the things they vote on for doing interesting voting pattern analysis. We've also, not shown in this graph here, but we've loaded in the interests and how they link to those people. But what we don't have is an understanding of, the kind of the companies that they've got interest from, what kind of categorization they have. So are they a financial institution, or are they a brewery that sells alcohol? All kind of people who are interested in lobbying politicians for certain kinds of, influencing the way they might vote on topics. So the last was loading the company's house data and writing some kind of basic lookup functionality to try and match nodes across that. So again, this is just kind of like a quick idea of how to do this, but we got I got some good initial results from doing this. So I thought they'd be interesting to share and show how you can use some of the capability of Workspace to do these kind of things. So here, quite simply, once the nodes for the companies were created, we ended up with these termed here companies house nodes that have got kind of quite rich information on companies. We've got addresses, we've got company names, and importantly, we've got some category codes here. So that's super interesting.
Can you zoom in a little bit on this one?
Yeah, I can zoom in a tiny bit. So maybe you can see a bit better there. But we've got things like this is an information technology company, and we've kind of got that classified here. So the next stage in the process was kind of creating some full text indexes on these nodes, so that we could then search against them and kind of match them up to the organizations we found mapped into the kind of financial interest that these politicians may have received from those companies. So I'll just show how that works very briefly. This is it's a lot of boilerplate in this query to kind of get around the fact that this is a kind of using a kind of full text Lucene based type index. Just making sure we kind of exclude certain characters. If I run this, I'll get an error because it's expecting parameterized imports. If I kind of replace, for example, here, so I work for Neo4j. I've got a vague recollection that our office is on a Union House or Union Street or something. So if we set that parameter and then rerun this query, we should be able to look up on the company's house data, the kind of matching entity. So we have here, we found Neo4j UK Limited with the address line Union House, and we get some kind of scores around how good that matches from matching here. So that's great. And then, so with that, what we've been able to do is then create some kind of similar company name relationships. So within our data set, and bear in mind that our entity resolution is not always perfect here. So we do have some kind of, or rather entity extraction is not always perfect. We do have some kind of false hits. But for example, here from the data, from the extracted entities, we've got the national, we've got National Wind Power UK, has a similar company name to UK Wind Power Limited, and GMB Yorkshire gets a match with, okay, this one's maybe not quite so good, but we see we've got some kind of matches here for the Welsh Development Agency that we saw on one of those earlier, mapping to similar terms there based on address and kind of name. So we've got something we can kind of start to work with here. So the final stage in kind of this step was to kind of look at, as I was using, I probably did this over a course of 2 or 3 days, kind of messing around with the data and working out what to do. Kind of the next stage in my kind of trying to prove whether there was anything interesting I could do here was working out that if I look at the industry classification codes for here, if I look at some of the examples, let's look at this code here. This is actually going to find all the some of the distinct values here. So it's going to take a little while to run because there are something like 5 million different company entries in here, but they're super, super granular. And there are, I think from recollection, about 1,000, 1,500 of them. So one thing we could do then is just scrape the web to look for, okay, well, what do these codes mean at this really granular level? And we can kind of create some kind of simple statements in here, some kind of matching statements to say, okay, well, if the code starts between 1 and 3, then it's something to do with agriculture, forestry, and fishing. If it's this range, then it's manufacturing. So we could quickly run this to kind of add a new property to our company's house nodes. And that means that we have like new properties now on these nodes that kind of have a much higher level of aggregation. So you can see that node property populated here. So this then enables kind of the final step of the analysis. So the query here is not super complicated. Let me just clear the stream view so you can see a bit more of what's going on here. So the final step is building on everything, or a lot of the steps we've done before, finding the organizations that I know will kind of reference on the interests that have a matching company where we know the category, finding people that are, companies that are involved in manufacturing, and then starting a new traversal again, going back from those organizations, finding out their interests and mapping back to the people who recorded those interests, and also looking at the parties they belong to. So kind of finding those kind of whole trails of going from the companies that are in a particular sector, finding the interests that they map to, and then the members of parliament that kind of received kind of those payments from those industries. And then we've done some stuff here to kind of cut out some of those paths. So we can create a virtual relationship between, here in this example, the kind of party person pairs in these relationships, because we're not necessarily interested in the full detail of a person was elected a member of parliament for a particular term and did this. Bringing the members of parliament nodes in would be kind of too much information for our visualization. So this is kind of creating a virtual node just for the purposes of doing the visualization. So here I've kind of run this against the manufacturing industry just to see what gives. And if I run that, we start to get a graph of kind of all the parties and the kind of interest they receive in pink here. So these are the parties, Conservative and Labour. And I've picked this one mainly because it had a tie back to my main image at the beginning, where you can see here that there are a lot of members of parliament in a certain parliamentary term. You can see a kind of a cluster of this company called JC Bamford Excavators Limited. So JCB, the people who build diggers, and probably don't expect them to be crashed through polystyrene walls, but you can see that there are a lot of members of the Conservative Party receiving various financial interests for their campaign. So it's stuff that we know about, but it's really interesting to see it in graph form. So equipped with this kind of query, you can then for example, set this up in Explore. We could clear this scene here and look at setting up a search phrase for this. So we could create some saved cipher, and I'm going to save myself time by just showing you the one I set up previously. So this is exactly the same cipher that I was just showing you in the query tab, but this time it's parameterized by that industry code. And we're giving the search phrase here, what do party interests coming from a particular industry look like, is the question. We're giving it a lookup for those section codes that we created for the company, just so we can kind of ask those kind of questions and quickly see in a visualization. So there's probably a slightly more efficient way of doing this in terms of lookup, because this is probably going to scan the full kind of 5 million nodes each time. But just for a quick illustration, let me show you this in action. So we can kind of have this search phrase here. What do party interests coming from industry? And then it's kind of looking at what different section codes exist in those nodes and allowing us to kind of choose one of those industries to save us kind of having to go and do a query and look those things up ourselves. So here we can see a list of all the different codes that we got from. So I looked at one with, I think it was manufacturing before, but we could look, for example, at financial activities and then run that query. And then here we're going to see, if I let that kind of all settle for the visualization, we can see kind of clusters of nodes. And I could probably do a better job of coloring these. This is not a super well set up perspective, but you can see a Conservative Party here. And you can see, if I zoom out, you can also see kind of Labour Party over here. And I think from having looked at this previously, I know that some of these companies that have been classified have not been done completely accurately, because I was doing this as a quick exercise. So this GMB I know is actually a union, so I can kind of I'll discard that as a false positive. And then if we kind of zoom out of this view, we can see that really the most activity centered here in terms of interests is maybe not unsurprisingly, if you think back to kind of my first slide of particular party being bankrolled by certain kind of industries, you can see that companies involved in the financial and insurance industries tend to have more of a propensity to kind of provide effect sponsorship and interests to this party in government. And we can just have a zoom in here, and not all of these are perfect. We can see HSBC, Europe, Arab Bank, IPGL, who I assume, and kind of assume most of these, Royal Bank of Scotland, are all kind of financial institutions providing funds to certain kinds of party, which is much less noticeable kind of on this side of it. So anyway, that concludes my kind of run through of all these things. So if you want to check out Neo4j Workspace yourself, it's available today for all new Aura users. So you will now see it as your default option within Aura. That's for self-serve. So if you're creating a free instance or a professional instance, you'll see that there as your default option. You can still switch to see the individual tools from the user profile menu being shown here. So bear in mind that's still available if there is not complete feature parity, for example, especially in query with what is in browser, but we're making quick progress to get there, and there's some much improved functionality within query versus browser in terms of performance and for example, some of the parameter setting functionality I showed you there. And yeah, for existing Aura users, you can just opt in. I think we'll leave it for you as default, the individual tools, but you can go in there and switch out to use Workspace. And if you're an Aura Enterprise customer or self-hosted, you don't have access yet, but watch this space for further announcements. Thank you for listening. I couldn't resist not ending with this clip for nobody, for people who don't know what this is. This is our Prime Minister before the current one, where there was a competition to see if she could last longer than the shelf life of a lettuce, and she didn't make it. I think 10 days was the record. So anyway, I hope you enjoyed learning a bit more about how you can use Workspace to kind of bootstrap your graph projects. And yeah, hopefully you weren't too disheartened by the things you already knew from the political sphere in graph form. That's it from me. Back to you, Alex.
Very cool. Thank you very much, Gregory. I think that was very interesting and very cool to see the new workspace as a demo and overview. So I hope everybody liked it as well. I hope virtual applause, please, for Gregory. I think we have a bit of time, so we can maybe squeeze in one question. Alec has one. Can you view an existing data model from the workspace? So how would it work if you are already having something ready, and can you explore it there as well?
Yeah, so you can continue to use, we have in the query tab, we have the call db.schema.visualization command, which will give you a view of your existing data model, that may have been created by whatever form. So I didn't show that in my presentation, but yeah, you can absolutely still do that. And we have some roadmap items looking at being able to do that in the import tool as well. So being able to kind of generate a view of what that model looks like in the import tool, in case you want to kind of load stuff against that additional kind of model. But yeah, absolutely, you can do that today.
Cool. All right. I think with that, thank you very much, Gregory, for presenting and for showing this. And yeah, we continue with notes, the beginner track. So we have a bit of time between now and next session. So I think that's exactly more or less 5 minutes now. So, maybe do this, go up and stretch your legs, spend a few minutes to saddle up with your whatever you're doing, not sitting around too much. We'll be back in 5 minutes. So I'll put up a short break in between now and then. And yeah, I hope to see you on the other side. All right. I hope you stretched your legs or grabbed a drink or something to eat from the fridge or from your pantry. We will continue. So next up is Anton Persson. Anton is software engineer on the kernel team at Neo4j and also a mindfulness teacher. I think this part of his role is more applicable to what we are going to experience next. The session is called A Space to Relax Guided Meditation. So I think that's says it all. But you know, in the middle of a very interesting, lots of interesting graph sessions, particularly today we had WoW keynote and a couple of interesting sessions just now with Gregory, a very interesting hands-on session. You might need some time to let things land a bit, give your mind some well-needed rest and come back recharged and energized for the rest of the day, which will obviously be packed full of exciting sessions. So Anton will guide us and help us settle in a little bit. So here we go.
Thank you so much, Alex. Yes, hello everyone. I thought it would be nice to do a short guided meditation together. This will be, like Alex said, a breathing space for you to kind of reset, to let things land a bit, to maybe find a place to let go of any stress from the morning or from the day, and come into the rest of the day a little bit calmer, a little bit more centered, and hopefully a bit more energized. So like Alex said, my name is Anton Persson. I work as an engineer in Neo4j, where I have the great pleasure to lead a guided meditation every Friday. So let's jump in. I invite you to sit down for this session, and you can come away a little bit from the back of the chair. This is so that your back can support itself. When we lean back, we have a tendency to kind of drift away more and even fall into sleep. And that's not what we want. We're looking for some alert relaxation. So feet planted steadily on the floor, seat resting heavily on the chair. And if you haven't done so already, I invite you to close your eyes. This will help you to turn inwards and kind of take a break from the outside world a little bit. Just sitting here, arms resting heavily in your lap. Maybe palms facing upwards towards the sky or downwards towards the earth, or folded in each other, whatever way feels most comfortable for you. You can maybe let your shoulders roll a little bit, flexing the spine, maybe rolling the neck, making sure that your body is comfortable. And letting the shoulders drop, relaxing them, unclenching the jaw, let the jaw drop. Softening the area between your eyebrows, softening the forehead. And I invite you to join me for a few deep breaths. We're gonna inhale through the nostrils and breathe out through the mouth with a sigh. So breathing in, filling up the belly, filling up the chest, hold it for a bit, and let go. And one more time, in through the nose, a little bit more, and hold. And let go with a sigh. The sigh helps the body to relax. Breathing in, filling up the body with air, and letting go. Allowing the breath to return to its normal pace. So for now, just sitting here. There is nothing for you to do in this moment. There is nothing in this session for you to understand, to analyze, to perform or achieve. So you can just let go of any thinking, of any pressure. Your to-do list will be there when you come back. So for now, you can just let it go, let it be, leave it outside. Take a break. I promise you it will not feel lonely. So just letting go of any doing, just sitting here. And notice that your body is breathing. It is breathing on its own. You don't need to take care of it at all. And you can notice that you can feel the breath either in your nostrils, in your chest, or down in your belly. So just check in with where you feel the breath most clearly. So if it's in the chest, you rest your attention on the physical sensations of the breath in your chest. And just try to keep your attention there. And whenever you become distracted by any thoughts, sounds, bodily sensations, mental images, whatever it is, when you become distracted, just give yourself a smile and return again with the attention to the breath. There's no need for any self-judgment or criticism. Your mind has been trained to be distracted, to seek out things, jump from thing to thing. It's just how it works. And now we're practicing something different. So any mental images, any sounds, any thoughts, any bodily sensations, they can still be there. You don't need to push anything away, but let it be in the background and let the breath be in the foreground. See if you can follow one single breath from start to finish. Through the inhalation, feeling the tension in the body with the inhalation, the small pause before the exhalation comes, and then the exhalation that relaxes the body. And maybe you can also sense the pause between the exhalation and the inhalation before the next breath starts. Just noticing the silence and the stillness in between the breaths. one breath at a time. And if there are any thoughts like this is not working, or I can't do this, should I do more like this or that? Notice that those are just thoughts. You don't need to give them any energy. You don't need to invest anything in them. Just leave them be. They will pass on their own and return to the breath. Be gentle with the breath, allowing the attention to float with the breath like a river. You don't need to manipulate the breath in any way, letting go of any manipulation. Just staying with the breath, following it wherever it goes. Where is your attention now? Is it on the breath, or has it floated away to something else? Just checking in where you are and return to the breath. And you can let go of the breath for a few moments and just allow the mind to do whatever it wants to do. If it wants to think, you allow it to think. And if it wants to be still, you allow it to be still. And you can start taking in the sounds surrounding you. Your body starts waking up, taking in the room surrounding you. And before opening your eyes, just see if you can bring with you this sense of relaxation and presence into the rest of your day. And you can open your eyes again in your own time. So welcome back. I hope this session was useful for you in some way. I will stay in the chat if you have any questions or if you want to talk a little bit. Otherwise, I wish you a beautiful rest of your day, and thank you so much for joining. Bye-bye.
Wow. I have the urge to speak very, very softly now. I floated away a little bit, so I hope you keep this relaxed feeling for a little longer. We will take a short break. Next session starts in 5 more minutes. So yeah, take more breaths, deep breaths, be in the moment, and yeah, I'll see you in a few minutes. Wow. All right. I think hopefully we are relaxed and ready for the rest of the day, ready for our next few sessions, settled in and realigned, thinking on graphs, thinking about technology and software and databases and all the good stuff. So yeah, next up we have Mark Needham. Mark Needham is developer advocate at Startree. His talk title is Graph Modeling the Shadow Graph. And yeah, what is this about? So one of the best things working with graphs is the flexibility of the graph model. We all know this. We saw this earlier a little bit. Gregory hinted at it. you'll see it all over everywhere you look. It's the flexibility of that graph model. As part of a tennis predictions app that Mark has been building, he needed to come up with a way to represent the actual results of a match alongside the predictions done by participants. So he took this in and made a shadow graph, I guess, out of it. So we learn how this works. We'll learn his journey, and I'm very excited to have Mark here. And thank you for taking on the next session, Mark.
Hi. Hello, everybody. Right, let's have a look. What is this shadow graph? So I am a tennis fan, which I guess is evident from the description. And at the beginning of this year, I started trying to see how good I was at predicting matches. I guess not very good is probably the answer. And so I built this little app, and so you can kind of see roughly on the screen how it works. So I predict who I think is going to get to each round in a certain position of the draw. And then I put in the result afterwards, and then you can kind of see red as I got it wrong and green as I got it right. And so this is from the Australian Open 2022. So this was like in January. And then it kind of computes you a score where you get more points the better the round. Now, the first version that I did was just some JSON files. So I put some JSON files in GitHub, and I had the tournament, had some metadata about the tournament, and then I had the events. So events is because there are men's singles and women's singles. Generally, I'm not skillful enough to do doubles, so I didn't try to do that. And then within each one of these, I would then have the actual player that got to that particular part of the draw, and then the one that I thought it was, and then for the other side of the draw as well. And so this is fine. This is all working. It was working for every tournament. And then in about May, I showed it to someone, and they were like, "Oh, I want to do this as well." And I was like, "Oh, I don't know how well my JSON file approach to this is going to scale." So I was talking to Michael Hunger, and he was like, "Oh, why don't you build a graph out of this?" So that is where the talk begins. So we've got to figure out how to convert this into a graph. So some of it is reasonably easy. So we'll start off with that. So there's a tournament, right? So we can kind of see that at the top. We've got a name of a tournament, we've got a start date, we've got an end date. So okay, so far so good. We've got within the tournament, there are multiple events. So it can be like an event is like men's singles, lady singles, men's doubles, mixed doubles, etc. Within an event, we've then got what they call a bracket. And so in a bracket, you have two players. So they are in that particular part of the draw. The reason that it's called a bracket is because this is what it looks like when you view it as part of a draw. So you kind of got like this almost bracket looking thing. And so Berrettini, Nadal, that would be one bracket. And then Tsitsipas, Medvedev, that would be another one. And then Nadal, Medvedev would be another one. So those are brackets. So bracket is kind of the representation of a match that's going to happen. And then we've got the players who actually got into that bracket. So in this case, Berrettini and Nadal. And so if we model that, it's not too tricky, right? We're more or less mapping it just how I showed now. So blue represents players. We've kind of got Tsitsipas and Medvedev over here, Nadal and Berrettini on the other side. We've got the event sitting in the middle, men's singles. And then below that, we've got the tournament, which is connected to that event. And then we can have other events as well, right? We can have, like there would be a lady singles. I've taken it out of this particular diagram, but there would be lady singles attached onto that Australian Open 2022. So that's fine. So far, so good. But then it became, okay, well, how are we going to model the players who I thought were going to get here? So we've done the players who actually got here. How do we model the players who I thought were going to get here? Keep it in mind that we want to be able to model it for multiple people. So me and let's say Alex wanted to compete, and Michael, we want to be able to track all of us and then see how well we're doing against each other. So how do we do this? So let's have a look. One way is if there was only the initial way I was thinking, I was like, oh, maybe we can just add in predicted player one and predicted player two. We'll just attach that onto the bracket. And so that would be the new bit of the graph, the bit that's highlighted kind of in pink / purple down here. So we've got this extra relationships connecting to some players. The problem is it doesn't actually work if we want to do predictions for multiple users. So like if I wanted to do, I mean, I suppose you could like add in predicted player one, Mark, predicted player one, Alex, predicted player one, Michael, but then it's kind of, you're sort of embedding like the name of a person inside the relationship type, and it doesn't really work particularly well the more users you want to add. So that's not really like a very generic solution to the problem that we're trying to solve. So Michael and I were talking about this, and he was like, well, effectively, you want to be able to shadow the brackets. So you've got the bracket, and then you've got the shadow bracket. So that's where the idea of the shadow graph comes from. So let me show you what it looks like with the shadow bracket. So the shadow bracket's now in red. And so we have like semifinals is one bracket. So semifinals in the Australian Open is one particular part of that draw. And then we've got a shadow bracket, which is like my prediction for that particular part of the draw. And so what we've got here, all these bits highlighted in purple, those are the shadow bracket. Like they're effectively a copy of the other part of the model, but they're for our predictions rather than the actual one. And so you can see we connect it to the actual bracket itself up here, and then we can make our predictions. We can say my prediction is player 1 is going to be Sinner, player 2 is going to be Medvedev. You can see down here it's got the user, so that's me, and that's my shadow bracket. My other shadow bracket's over here, and I'm saying it's going to be Alcaraz and Zverev. I actually got this one. This one is completely wrong. The actual result is up here, so Berrettini, Nadal. And then down here, I've got one of them correct, right? So I got Medvedev in the right place, but Sinner is in the wrong place. And players can only go, once you get to a particular round, they can only go to one part of the draw. Like you can't just suddenly go, hey, I was going along this path and then suddenly end up down here. So it's a little bit simpler than you might imagine. So that's the graph modeling technique that we've done. And then how would we go about actually querying it? So this actually gets a bit more complicated than what we started as. So we have like, hey, this is find my user. So this is like my auth0 code. Look me up. And then what I want to do after that is we're going to find the tournament, find all the events that are part of it, and then get all the brackets. So those are all the like parts of the draw. So this is like doing a query to find for the Australian Open 22 men's singles, and then bracket. Each bracket has a rank, so I could order them. So like, I think I started from the 4th round. So the 4th round was 0, the quarterfinal was 1, the semifinal was 2, and so on. So I was just like, find the semifinal and beyond. So that gets us, so this query here, so find all the brackets that are semifinal or above, and then we get the optional bit, because we don't, like at some point, like at the beginning of the tournament, we might not have predicted anything, and we wouldn't have the result either. So we kind of got lots of optional parts to it. So we've got to get the player 1, player 2 for each bracket. And then we connect the bracket to the shadow bracket and to the user. So that's what we're doing in the middle here. So connect my shadow bracket. So the shadow bracket for me. So remember user is me up here. Get the shadow bracket, connect it to the bracket. So that gets us just this one shadow bracket. And then the shadow bracket's connected to my predictions. And then you get back like the actual player, player 1, actual player 2, my prediction player 1, my prediction player 2. And so we end up back at like what we had on that initial JSON file. So we've got our prediction, the actual result, and then for the champion, it's kind of interesting because this one I only store player 1 for that because it's not, because there's not really like there isn't a player 2 when you're trying to say who won the final, because only one person can win it. So I just ended up like in this particular query, this just shows as null. And so yeah, that's the modeling technique. So just to conclude, it obviously adds some complexity to the graph, like putting this structure in, but it really does dig you out of a hole. Like I was kind of like trying to think like, how do you do this? And I think this applies in like more than one thing, right? Like if you were trying to model like employment history, you could imagine like introducing like an extra part of the graph. It's almost like it's like a composite graph model. This is just a version of that pattern. And if you need to connect, like in this case, it was users and players into like the same thing. So we could say, hey, these predictions are mine rather than these are just predictions. And this is a really neat pattern to do it. And kind of as a few of the other speakers have said, this is fun, right? Like coming up with this is quite neat, and it solved our problem. And I know it's not been quite 15 minutes, but I am done. So thanks very much. And if you want to find me, that's where I am. Cool. I'll hand back to you, Alex, in case anyone has any questions.
Cool. Thank you very much, Mark. That was quick.
You want me to answer this question in the chat?
Let's do some questions.
Yeah. I don't understand what a shadow graph is. Is there a general introduction to explain shadow graphs? Well, no, there isn't, because I just made up the term. And it was effectively in this particular domain model, right? Remember we had, if we come back, so we come back. Where do we go? So we had the concept of the bracket, and the only thing that really exists is the bracket, right? So the bracket is who actually got to a particular position in the draw. So that's like this bit up here, the purple and the blue. And then we're trying to layer on top of that Alex can have his version of that. I can have my version of that. Michael can have his version of that. So that's just the concept. Like we're effectively creating like a shadow copy of it, and there can be lots of copies. It does. I don't know. Maybe there's a better name than shadow.
It's a digital twin of a digital twin.
Yeah, maybe it's a twin. I should have called it the bracket twin.
Yeah.
But yeah, effectively,
Shadow graph sounds cool. I mean, dark and mysterious.
Yeah. But apparently, it doesn't take very long to explain either.
Well, you are a fast talker, so I think you.
I know. Yeah, I've been told that for 10 years. One day, maybe.
Yeah. Well, we can do another question.
Will says, "How do you generate the predictions?" I mean, I just guess very badly. Is it a labeled node? Yeah. So there's like there would be lots of these shadow bracket nodes like around the graph. So there are loads. Like for all the tournaments and all the predictions that I made, each one has a shadow bracket node.
Yeah, don't be shy with questions. Obviously, this is now your time. Matt
Stone, why player 1 and player 2 instead of something like, I guess you could. When I was doing it originally, I was trying to capture where exactly they were in the draw. So were they the first player or the second one? But yeah, I suppose it doesn't really matter. Yeah, as I said, like they can't move, like they can only go into one part of the draw. So yeah, we could model it as played in. Yeah, that would work as well. But I was trying to like make it like really like look exactly how it did on the draw.
Yeah, makes sense.
Is it a subgraph? Yeah, I suppose it is. Yeah, it's a kind of subgraph, isn't it? Right? We've got like a graph of the actual results, and then we've got like a subgraph of our predictions. And so on this diagram, there's only my predictions, but we could add in like if we had Alex's predictions, I guess maybe we could connect that to another part. But they would all come into the same bracket. Like we're trying to capture multiple predictions of the same thing. Can you show the code again? Sure. Good luck if you can memorize this though.
Well, we will be sharing the slides, I guess, afterwards, and then you will be able to copy that from there. So yeah, I mean that's definitely easy. Cool. So maybe you shared this in the beginning, and sorry if I missed this, but the data. Is this public? How did you get to it? Is there?
I mean, the data of the predictions is me like putting it in. I mean, I've done it all manually. I'm sure you could automate parts of it, but I've just got like a little UI and I fill it in.
I see. Okay. Yep.
So no. I mean, it is running on. It's running on Aura. See, they get the plug in there.
Yeah.
So I've got a little app. It's deployed to Vercel. It then connects to Aura, and it's kind of just a React app on top of it.
The app. Where's the app?
Where's the app? I can show you. Let's see if it. This is where I got it. Let's see. This is now we've added like a layer of risk to the tool.
Sorry, it's a bit small. No, here we go. Yeah.
Let's see how well this is going to work. So yeah, I don't know. Pick another one. So this is like. So this is like another tournament. From the year. So this is what it does. It's effectively going and running queries against Aura, and then it's coming back and working out whether I got it right or not. So for example, that's men's singles, women's singles. And I'm not doing anything clever. Like when I want to edit it, this is the mode. If I want to go and like put in the result, and then if the tournament would be live, like this one ended like 7 months ago, I would get another button next to it where I could go and put my predictions until the tournament had finished.
Are you betting on it?
No, I just wanted to see how bad I was because I always saw people doing these predictions. So I was like, surely I can do better than that. But yeah, like it's got like you can make a new event. Like I mean, this isn't part of the talk, but yeah, this is what is backing this model. Like this is all using a lot of this is using APOC to do stuff. So it kind of like you can create an event, create a date, like start date, end date, and it uses the start date and the end date to work out whether or not you're allowed to continue to do predictions on it. I can't remember. I think I did US Open. Let's have a look. Yeah. But yeah, I'm generally not. I'm not very good. Like other people are way better at this than me. So I shouldn't be betting. Don't encourage me to bet.
No, I'm not. I don't. That's not what we need to say.
Michael says there's a repo. Yeah, there is. Let's see if we can find it so I can share it with you. tennis predictions. There we go. I will paste it into the chat over here. That's where it is.
Oh, nice.
Follow the best. Well, yeah. So Zania was saying, yeah, like I need to get more people to participate with me, then I could see how bad I really am.
Yes. like a shared, almost like a enhanced version of this, because then it would probably you can feed an AI that gives in the end better predictions from all the knowledge from the people.
Yeah. But everybody asks, like, do you have like some ML to work out? No. Yeah, so Praveen, like, do you have an ML that's working out your predictions? It's not that clever. Like, it's literally just me guessing who I think is going to get there. Yeah, so Praveen, there isn't any predictions like on the queries. I don't know whether that is maybe beyond like what I've done so far. Maybe there is a way that you could use it, but yeah, it's not. It's just purely manual. The data is manually entered.
Okay, cool.
Cool. Now you filled up all the rest of the time. Good job.
Yeah, I mean that's nice. I mean, if you finish early, we have some time for questions. It's not always a given, but yeah, this is always cool to interact as well with the audience and with the speakers. So some questions are always great to have. Obviously, we cannot promise that we will answer all the questions all the time, but yeah, that's cool.
Cool. Well,
thank you very much, Mark. I hope you are well, and stick around maybe a little bit more for notes, and I'll see you another event maybe sometime.
Yeah, cool.
Thank you, Mark. Bye. All right, that was this. We have a few more minutes until next speaker is up, so I'll I had someone was pinging me here, so I'll need to check. That's fine. This will be my. I'm blurry now. This will be my last piece of hosting. I'm still blurry. What's going on with my camera? Yeah, here we go. Good. All right. This will be the last. The next session coming up will be the last session I'm hosting. It's been a blast being with you in the beginners track. So I enjoyed it all very much. I'm looking forward to the next session still. So I'm sticking around obviously for this one. I will be then moving over to chat and interacting some more with you guys live. My colleague Yolande will be next hosting. So give her a warm welcome when she is doing it after me. Yeah, I mean, I hope you so far had a great morning, afternoon, evening. I mean, it's all what's the time zone really? I mean, I don't mind. And yes, I will be back tomorrow. Thank you, Michael. I'll be back tomorrow morning my time. So at the ending out the APAC intermediate track and then hosting the beginners track again all day tomorrow morning for the EMEA time zone. So if you can't get enough of me, hopefully it's not about me, but it's about other speakers, then you'll see my face some more over the next hours during notes. So yeah. That's that. Again, obviously, don't miss the network session. Don't miss the goodie bags. You can win a T-shirt. So I think the live tweet button was broken, so it's fixed now. And if you are using hashtag Notes 2022 hashtag live tweet and at Neo4j as well, then you can win a free. Basically, you can win it. Of course, you can win a Neo4j T-shirt. So yeah, I'm looking forward to all your tweets and see how much you enjoy notes. I hope you do. But yeah, so I think we're good to move over to our next speaker. Next up is Michael Bandor. Michael is Senior Software Engineer, Software Engineering Institute, SEI, at the Carnegie Mellon University. His talk is graph database techniques to reduce risk and innovate. So a very hot use case, I would say, for graphs and applications. And Michael will look in his session at unique case studies that recently have been completed by the Software Engineering Institute, the SEI, to tackle challenges that were encountered by the DoD clients in cybersecurity risk management and policy. So I'm obviously stumbling over the words. I don't know what a DoD client is. I hope Michael will enlighten us. I'm pretty sure he will. So that's the next session, going all about cybersecurity and risk management, which is, as I said, super interesting and exciting. So welcome, Michael. Thank you very much for joining. And happy for the next session.
Okay, thank you. As Alexander introduced, I'm Michael Bandor with the Software Engineering Institute at Carnegie Mellon University. Welcome to be here. I'm in San Antonio, Texas presently. This talk is looking at a use case and prototype implementation we did for a Department of Defense client. And let's go to the next slide. So the problem space, we do a lot of work with the U.S. Department of Defense, and we had a customer that was struggling to identify software obsolescence issues. They were finding things were expiring when they least expected it, when they thought they had a handle on it. There were secondary and tertiary effects of things breaking. They would find that the hard way. We'd upgrade this particular product and the upgrade would die on them because there was a dependency on another product or a dependency further on downstream. The contractor that was doing the work for this customer was tracking the information across several databases and providing an updated spreadsheet once a month of what it was tracking. The tendency for a lot of DoD customers and people in general is you go with the tool you got, so they dropped into spreadsheet mode. Not necessarily a bad thing, but you don't get the additional insights into the relationships of the data and how things are going to cause those ripple effects. So what we looked at doing was doing a prototype implementation using Neo4j to ingest that contractor data and to start creating some knowledge graphs so you could start understanding those relationships and where clusters of things were happening that they weren't necessarily visible in those spreadsheets. So problem space, tracking commercial off-the-shelf software, COTS, government off-the-shelf software, GOTS, and free and open source software, tracking those obsolescence issues and vulnerabilities in software-intensive systems. So we started asking questions. What's affected? When is the product they're using no longer supported? What's the immediate impact? What are those secondary and tertiary dependencies on my system? Where are the products located in my system and what environments? Are there any impacts from identified vulnerabilities, the common vulnerability enumerations, for example? And how do we track all of this? As I said earlier, organizations tend to drop into the tools they have most commonly available, typically a spreadsheet. So they had looked at trying to use a design structure matrix or dependency structure matrix, depending on which school you follow, which gave them an A and a B, but it didn't give them the secondary and tertiary dependencies. And they quickly figured out that that was not going to work. Real quick, Graph 101. We know everything's connected in a graph. We built a property graph using the nodes and relationships. Nodes are the entities, so those were representing the objects of interest in this case, and the relationships between those entities. This is, again, Graph 101 type work, if you've had any of the Neo4j graph introductions. Real quick example, person works for a company, company's located in a city, you've got your nodes, you've got your relationships and properties in those nodes. So looking at the data they had, we started to figure out answering the question what information needs to be tracked. So every product has a name and a version. A company, obviously, they created it. There's an end of support date for that particular product. There's an end of extended support date, an end of life. So I'm going to expire, but I can keep working on you for a little bit longer, which is your extended support date. And then End of life date, no, it's a dead product of that point. What category is it? They were interested in what's COTS, GOTS, and FOSS. Any possible dependencies on other products, what operating systems it runs on. They were operating multiple operating systems for this particular system. They may have had some of their obsolescence of the products go through a formal obsolescence evaluation process, and it may have one or more vulnerabilities. So we also looked at it from an operating system perspective. You still have same ideas with name and version, manufacturer, end of support, end of extended support. So the difference between the product and an operating system is an operating system change has a much greater impact on your system than a single product. So initially when we went into this, we were leading towards tracking the operating systems as a separate entity or node. You'll see we changed our mind slightly on that. So how we defined it, we have a product that runs on an operating system node, may depend on another product. It's created by a company with a created by relationship. If it's got an obsolescence issue that's been formally done, it's represented with a has relationship, and it's tracked to a node that has their JIRA information where they're tracking those tickets. May contain one or more vulnerabilities, contains relationship, it's installed in one or more environments. So where is it? Checking the vulnerability. So it's checking those boxes and those questions that we're asking. Similar idea on the operating systems. And then I talked a little bit about the obsolescence issue. We intentionally did that as a separate node because it does have a link. It could drop right into their JIRA ticket. Now, there could be, the way we found out, their JIRA tickets and their obsolescence process, it wasn't necessarily one JIRA ticket to one product. You could have one JIRA ticket covering multiple products, or one product was under multiple JIRA tickets, depending on which environment it had been installed in. They also had some risk categorization that was contained within that JIRA information. So our initial stab at the modeling, so here's the product, and then it depends on other products. That relationship was there. Where it's installed, created by a company, has an obsolescence issue, runs on an operating system, contains a vulnerability. And if you look, these are basically mirror images if you go diagonally. And you'll see why in a little bit. This is why we rethought this operating system note a little bit. So we came up with some possible use cases for this particular customer. Keep in mind, this is Department of Defense, the military system. So they're asking things like, manufacturer announces that software product will no longer be supported. What are the impacts to the system? We got notified of a vulnerability in a product. Where is it, so we can determine the risk to the system? What do we need to do to eliminate or mitigate the vulnerability? Company sells the product to a foreign company. That's of great interest to the Department of Defense for obvious reasons. Again, answering the question, where is this in the system? What's the impact? If they needed to stand up a new test environment, for example, we needed to duplicate an environment, what products need to be installed in that environment? Or if there's a newer version of the product, is there anything to keep us from upgrading those dependencies? So what we ended up doing after looking and playing with the data a little bit, we ended up coming up with this model. Again, it's very similar to the initial concept. So the main difference is this node now has two labels, product and operating system, where they're keeping the OS as a separate node on its own. So you have a software category. There's your COTS products, your GOTS products, your FOSS. Your company is still there, which platform it was installed on. If it has an obsolescence issue, still links to the JIRA tickets, and that can link to whatever platform. Now, what wasn't discussed is this in the support node. So we'll talk about this a little bit later. This allowed us to do some interesting clustering of the data that was not readily apparent in those spreadsheets. So the implementation, we had several goals. We were going to use the existing data source, that spreadsheet that came from the contractor. We did not want to cause a contract change just to accommodate a different data format. In a perfect world, they would have been ingesting this live from the databases and not have to go through a spreadsheet as an intermediate product. But it worked well for both sides, so we left it the way it was. The government customer would ingest the spreadsheet each month, which is their standard process. They would get a normal delivery. The government customer would perform the analysis. This does not preclude the contractor from doing the analysis, but the government would be the one that would be doing the analysis and getting back with the contractor. Part of the prototype implementation, we would provide the installation instructions, the model details, all the documentation, the use case scenarios with examples, the Cypher scripts, and the primary script for the initial data ingest and the updates. And we want to try to make this as easy to use as possible. The customer side on the government had never been exposed to graph databases. And when we started doing some prototype with some actual data, they got really, really excited that this is answering questions in real time that it would take them weeks to figure out. So the implementation steps we took, we had to dig through the data because it was coming from 3 different databases. We had to figure out, okay, this is represented different ways. How is this data being used and what is it being used for? It turned out there were only about a dozen columns out of the 60 some odd columns that were actually being used to make decisions. Developed, refined the model, did some small test sample imports to make sure we got the logic correct. Based on those tests, started building the ingest script using APOC with the spreadsheet. Love APOC. That really simplified things a lot for us. We had to figure out, because of the human side of things, how to handle those data entry errors. For example, empty fields that are indexed for performance, empty date fields, typographical errors and some data elements, date representation. Had to figure out how they wanted to handle that. So again, we tried to make it as easy as possible for the government customer. Go back, confirm the import, subsequent graph was correct, a little bit more refinement, refine the model as needed. That's where we started to decide operating systems don't need to be their own node. Let's take advantage of the fact you can put more than one node label on a node. Implement those, and we decided, okay, we've done an ingest, we're great. How do we handle the next month's ingest? Do we want to wipe and reload? Do we want to keep it and do updates? How do we figure out what's new, what hasn't been changed? So I had to think about that logic. And the more we started looking at an update script versus the initial ingest script, it turned out that it's the same script. We had to do some calls with the merge statement and Cypher that really cleaned things up for us. Again, did some more analyses, proved out the use cases. Are we getting the answers to the use cases we were expecting? And we were. Tuned the script just a little bit, thanks to the modeling courses at Neo4j that helped us tune it, make it a little bit better for performance. And then write a lot of support documentation. Again, the government customer had not been exposed to this before, so they were definitely very new to this concept, but they really loved the idea of being able to do this. So what were the results of all this? We took 3 different months of data that was ingested. We ended up with 1,554 nodes total based on the model and how we divided things up. That consisted of 134 different companies, over 1,000 products. There were over 160 JIRA tickets. The software categories kind of surprised us. Instead of just COTS products, GOTS products, and FOSS, they had 12 different categories of software that they looked at. So that was not really apparent in the spreadsheet. It did show up really readily apparent in the graphs. And if you remember, I talked about doing that end of support date cluster with just the year and the month. We ended up having 166 clusters of expiring data or expiring products that, again, was not necessarily visible using the spreadsheet, but then it was using it as a graph. So This shows some of those support clusters. So I see I have large groupings of products are all expiring or due to expire the same year and month that I need to start working on proactively, 6 months to a year out. Same thing with the JIRA tickets. We found mappings, like I said, the JIRA ticket could go to multiple products. You could have a single product with multiple JIRA tickets depending on the environment. So figuring out how those related, and we started finding a lot of things in that area as well, how it was done. This was not without its challenges. Like I said, multiple data sources went into this, and there was a lot of data that honestly was not usable, that we had to figure out how is it being used, is it not being used for decisions. That took a little bit of getting what we refer to as the magic decoder spreadsheet from the contractor to figure out, walk us through, okay, what does this column mean? What are the range of values? How is it being used? Best way to parse the spreadsheet. We looked at, okay, do I take the spreadsheet, do multiple passes since I have multiple nodes? Or do I try to bring everything in one pass? We opted for performance to import everything in a single pass. So that product node got huge with the properties. Then once it was already in a graph and in memory, we could start spinning off the separate nodes based on those property values and then delete the property values from there out of the product node. In the service node, again, we left the end of support date or that date as a property in the product node. However, by using that node with just the year and the month, it made a big difference on how effective we could do it. So if you remember graph engines, graph theory, it costs you a lot to go into a node, dive into the node, go to the next node, dive into the node. So I would have had to hop and go parse every single node to figure out where those clusters are. But by using that end of service date as its own cluster, I can just do a quick hop, and I'm there. I didn't have to hit all the nodes to get that data. So hopefully that answered the question that Charles Campbell had. Did some refactoring of the, I talked about, we were looking at an initial ingest script followed by some sort of update script. The more we looked at it, it would have duplicated the initial ingest script. And so with a little help from the NeoJ community forums, we looked at and put a date created and date updated property on each of those nodes. So when we did a merge operation, so the on set or on create, it would set a date created with the current date. So I know this node and this data was created on this date. If I had seen this already, so it did the on merge side, we did a date updated. So I could start seeing, okay, this has been updated. I have seen this. Oh, I haven't seen this in 6 months. Is this no longer being tracked? So that's by doing those two properties in the nodes, that made it really easy and simplified the scripts actually. We also, they created on subsequent ingest, we put a new label on the new node. So I can query, give me every node that's new, and it would show me everything that was new that I had not seen previously. And then a subsequent ingest, it deletes that. And then, so you've got a steady state. Like I said, the spreadsheet gets updated once a month and provided to the government customer. So that was a way to easily identify what was new since the last time they seen it. And then a lot of documentation, use cases with examples, installation instructions. We also did a Docker YAML file if they wanted to go that route with their installation. So for those of you dabbling in software bill of materials, the data being tracked should sound familiar to you. I started looking at this when the executive order got signed last year by the president as part of the cybersecurity implementation, and they talk about using software bill of materials. So looking at SBOMs, okay, what is it? It's a formal record containing details and supply chain relationships of various components used in building your software. They thought about what are the minimum elements, greater transparency in the supply chain, laid out the options for future evolution. This came out of a U.S. Department of Commerce guidance from July of last year, talking about minimum essential elements. So looking at that, and if you read that, somebody, when they came out with that guidance, was thinking about graphs. So this is right. So it talks about that and all the topics through it, and it's further into the graph will provide more information. Somebody was giving some serious thought to this. And again, it goes further on. It should be noted some of the cases require complete or mostly complete graphs as the ability to not on the network. Somebody's thinking ahead. Again, further in the information, known unknowns, full dependency graph is not enumerated, must identify the known unknowns, other component relations. This relationship is implied in the SBOM graph structure. So they use the term graph multiple times. Now, the interesting part is a cursory look at the current tools out there that generate a software bill of materials. None of them generate a graph. So because of this work we did with the obsolescence, and there's a strong overlap between the obsolescence fields and the SBOM fields, we've got a candidate for some future research is to importing and ingesting SBOM data to produce similar graphs for some of the customers. And that's it. Are there any questions? I finished early. I don't think we've got our moderator back yet. Let me try here. We talked about digital twins. We talked about the end of support date as a node versus a property. Ethan Surrey, did the transition from relational databases spreadsheet to graph technology trigger wider adoption for other use cases? Yes, a little bit. While we were still prototyping this, we got a secondary request to see if it was feasible to analyze their defect reports in Jira. You thought the obsolescence spreadsheet was huge. The Jira tickets that they were tracking in a spreadsheet, again, an export trying to do some analysis on it, it had 164 columns and multiple representations. And we were trying to get them to get out of what I refer to as whack-a-mole mode, for those you remembering the game from a kid. So basically a defect pops up, you smack it. Defect pops up, you smack it. No, start looking at where are my clusters of problems. And we did some prototype for them that unfortunately didn't go any further. But that again is one of the ideas we're looking at is, could we read this out of Jira directly that I'm looking at trying to possibly implement. The graph model, the model is in these slides. So the slides are publicly distributable. I can't go too deep into customer sensitivities on specifically what they're tracking and why. Julius, how do you create / capture relationships from getting spreadsheets into random? So they were not capturing those relationships. That is one problem area that the government was going to have to resolve. Again, we did not want to create a change in the contractor processes that would create a change to the contract. If you go online, a lot of the products, Microsoft, et cetera, if you get into the product, it shows you what things it runs on, or this requires .NET version such and such, or this requires Java version such and such. So some of those would have to be built, and that was some of the use cases we provided them in the documentation. Now that there's an SBOM requirement that's slowly being implemented, that data should be available from a lot of the vendors. Kenneth, it looks like definition of nodes was largely driven by the data that was already there. Is that true? And the relationship? Yes, it was driven by the data that was there. That definitely causes us to think about things a little bit. The relationships, again, part of that was by the data. Part of that was their their recurring lesson learned about figuring out what the dependencies are based on learning it the hard way when trying to do an upgrade or a change and it wouldn't work, and they'd figure out there were some dependencies they didn't know about. That was in the documentation and they didn't pick it up. How will I have automatic relationships with the JSON file that I imported? That you'll have to refer to one of the Neo4j folks. I know there's the APOX import and export calls. I believe there are some settings or filters. I know on a CSV export, if you export the model or the nodes, and you try to re-import it, it looks for a node file and it looks for a relationships file. And I think that's probably what you're looking for. But you'll have to refer to the documentation further on that one. The Neo4j community can help you out quite a bit with some of those. Are there any other questions? Okay, thanks to everyone who was here, and I'm actually off to another presentation for thank you very much.
Thank you, Michael. Okay, so we have like a 10 minutes break. So we'll be back with Jennifer is our next speaker. Okay, welcome back. I hope you enjoyed that quick or the 10-minute break. So our next speaker is Jennifer Rife. Jennifer, hello. And she's going to talk to us about microservices. Can you hear us, Jennifer? Jennifer, can you hear us? She's thinking.
Oh, sorry. Can you hear me?
Yes, I can hear you.
Okay. Sorry about that.
Yeah. So you're live, actually.
Okay. All right.
Just a small detail.
Okay. So
Cool.
let's get started then. My session is Divide and Conquer, Send Forth the Microservices. My name is Jennifer Rife. My contact information is there in the lower left-hand side. This will be a pretty snug presentation. I'm writing a lot of code, demoing a lot of code for you guys. So I will get to questions at the end. I'll be sure to check back in the chat and be sure to answer those. But we'll just kind of charge on through for the session time. I'm a developer and advocate at Neo4j. I enjoy learning technology, and then I like sharing technology in a variety of different ways. So whether that's through writing blog posts or creating videos or speaking at virtual or in-person events, such as this one, I'm happy to do that. And I just really enjoy sharing and talking tech with others out there. Again, my contact info is there in the lower left. It'll also be on the final slide. So if you think of something after the event is over, for some reason can't reach me within the event in the next couple of days, feel free to contact me. Any one of those methods you're most comfortable with. I'm happy to continue the conversation about tech, Neo4j, and such. So I would be remiss if I talked microservices and didn't mention kind of the alternative or kind of maybe the contrast to that. So most people, when you talk about microservices, the opposite of that is going to be something like a monolith. And this is typically when you bundle multiple functionalities or maybe capabilities or functions or features inside a single application. This can be designed intentionally, or sometimes it just morphs into that over time, right? We're all familiar with tech projects. They may start really small and then all of a sudden, oh, let's add this and let's add that. And pretty soon you have this gigantic monstrosity. So it can happen either of those ways, whether intentional or unintentional. And if any of you recognize the image there on the right-hand side, that is from Lord of the Rings. I kind of like to think of monoliths as kind of this big, imposing fortress. So this is Helm's Deep from the Lord of the Rings series. So maybe not the most movable, but definitely has its place in certain contexts and in certain situations. So the good sides with a monolith are that you kind of have this one and done package, if you will. So whether you're dealing with, binaries or RPMs or jars or what have you, you kind of have this one and done type of approach when you're dealing with kind of pieces to implement. There's less communication because everything can kind of communicate within the same package, right? Or same classes potentially. The downsides to this is finding and reusing code can be quite complex. Implementing fixes, you could potentially impact other pieces of the application. Resource consumption, so especially when you're talking about scaling up, scaling down, maybe storage or just bandwidth size to implement the package itself. And then handling failures is trickier as well. So if some piece of the application is down, it's very likely that you could have the whole entire application down, which is not always the best when you're talking resiliency. So on the flip side of that, microservices tend to be small applications for either a single functionality or even limited functionality. And you'll have different people kind of vary on how strict they are in their definition of microservices. But basically, microservices try to deal with only necessary communication. So you're not bundling a bunch of classes into a single application when maybe those classes don't need to communicate with one another. You'll only have maybe service A only needs to connect to service C, service B connects to C, D, and E, and so on. So you'll only connect those wires that need connecting. The good side to this is that microservices tend to be very independent. They have a small footprint because they're typically small applications, small jars, binaries, etc. And this is very reliable and scalable. So you can kind of spin up, spin down, add additional services without increasing kind of your load or your overall system structure. So I like to think of these as more kind of battle units, and then you can see that kind of image on the right-hand side. So this is the battle units from Lord of the Rings as well, the campaign for Middle-earth. And so you have these small individual groups, much more flexible, much more spin up, spin down, kind of wherever you need them, and so on. The downsides with microservices, and there are some, is testing can be a whole lot more complex and tricky, and adding a communication layer. So you need something in order for these services to connect and communicate with one another, ping, send data back and forth, and so on. You're typically adding additional layers for this. So communication layers, maybe configuration layers, operations, and kind of monitoring layers, and so on, that might be a whole lot more complex than what you deal with when you're simply looking at monoliths. Now, I will say, as kind of a disclaimer, neither solution is a silver bullet. You're going to have both simplicity and complexity in either situation. So no matter what you go with, it really just depends on your business need and kind of the risks and things you're willing to take on. Just as kind of a side note, I alluded to this earlier. Different people kind of classify or define microservices slightly differently, depending on the scope of the functionality, whether you're dealing with asynchronous or synchronous communication, and the level of automation you have in the system. So some people will look at a microservices system and say, that's not a true microservices system. It's a blend or hybrid of monolith and microservice. And then others will consider it to be a microservices system. So just so you're aware, there's kind of various definitions of what a true microservices system looks like. So we will dive right into demoing now. So we're going to start with kind of a basic, as trimmed down and simplified as an application as possible. And then we'll kind of move up and create different levels here. So we have, we're going to create two applications, one a back end and one a front end. And we're just going to have them toss a string back and forth to, or from one to the other. So we'll have the backend basically be like an API layer, and it's going to provide a string endpoint, and then the front end is going to accept that and show it to the client potentially. Then we'll kind of move on up in our system. We're going to add a Neo4j database on the back end, and this will be handled by Neo4j AuraDB free tier. So that's Neo4j's database as a service offering. And then we do have a free tier for that. So we'll have a database that has book reviews loaded onto it. I loaded a Goodreads data set to it. And then we will have our backend service. It's going to interface with a config service that's going to basically get a hold of the database credentials and then reach out to the Neo4j database in order to pull the data that it needs. And then it'll pass that information on up to the front end service. And then finally, we will add a layer of Docker Compose or orchestration in order to handle startup and shutdown of 3 of our services altogether. The only one that's not included in that is the Neo4j database, because, as I mentioned, it's running on Neo4j's hosted cloud, our database as a service. And so we don't need Docker Compose to handle startup and spin down of that. All right, let's dive in and just code. So I'm going to switch over and we are going to just create a couple of Spring Boot applications. So we're going to go to Spring. I'm going to choose Maven. Java is kind of my preferred language, but any of them are fine, whatever you're most comfortable with. We'll stick with the latest stable version of Spring Boot. I'm going to kind of change the group just for organization of my projects. And then we can change this. Let's just call this backend. We'll stick with the same jar and Java version that's default. And then we need a couple of dependencies. So we're going to add capability in for reactive web. This is going to give us the capability to communicate and build reactive web applications. So this will allow us to transmit data back and forth between our applications and set up for non-blocking reactive communication between them. Now, again, some people will consider only asynchronous communication to be true microservices. Some will consider some synchronous in certain situations still to be microservice. It just really depends. But we're going to go ahead and set this up to be reactive so that we have that non-blocking reactive capability out of the box. Then I'm also going to add Lombok. This is going to cut down some of my boilerplate, reduce the time that I have to sit and write boilerplate code so that we can get to the good stuff faster in the demo. So with that, I'm going to generate this. and I'm going to stick it in a folder. And then I'm basically going to create just the same thing, but called a front end. And so we're going to stick with the same dependencies and everything in there. And then I can unzip, and I'm going to unzip the front end as well. And I'll open these in IntelliJ, or at least let's start with our backend application and get this loaded up. And I always like to start with the POM, and it's going to take a couple of seconds to complete loading. But I like to check to make sure that everything I requested from the Spring Initializer actually made it. So stable version of Spring Boot, Java 17. We have our WebFlux dependency, so that's that reactive web. And we have Lombok. And then it also tosses in a test dependency for us and the reactor dependency as well. That gives us the reactive capabilities. And then we have a Maven plugin that gets included there too. So everything looks good here. Let's jump on into our application.properties. So we have two applications. They're going to run locally. And so we need to have the communication between those to not conflict with one another, right? So we're going to assign different ports to each one. So server.port 8081 for this one. And I like to have the front end application, or what's going to be the client interfacing application, to be the kind of the default of 8080. So that's why I've assigned this odd 8081 over to this backend service here. And then let's dive on down here. And we're just going to start with something kind of run of the mill out of the box. We're just going to call this message controller. So we're going to create a controller class. And then this is going to be a Spring REST controller. We're going to have Lombok create a constructor with all arguments for us so that I don't have to add that boilerplate. And then we want to set up a endpoint for us to hit. So in this case, let's just call it something simple and basic like text. Then we can set up a method a method that's going to have an endpoint for us. And so let's say we're going to return a string. We're going to call this method getText. And then we're just going to return hello world. So again, super straightforward, nothing fancy. And if I go ahead and run this, then I should be able to head over. Oops, it didn't switch over to my browser window. Okay, 1 second. There it goes. Okay. IntelliJ doesn't like it when you try to switch windows when they're in full screen. So 8081. So we set up our endpoint 8081 / our application is at port 8081. Our endpoint is /text. So if I run that, we do in fact see hello world come up, which is what that string that we provided as a return for the method. So, okay, there's application 1. Now, let's switch gears here, and we want to open our front end application. Okay, and I'll go to full screen for this one as well. Again, POM, straightforward, just checking that, made sure everything gets here. Our WebFlux dependency, our Lombok dependency, our test dependency and reactor dependency, and the Maven plugin. Okay, everything looks good there. Let's jump over to our resources. Now, again, we want this port to be different, so we're going to assign it the 8080 port, so that way it doesn't conflict with our backend service on 8081. And then we're going to jump over to our front end application, and we're going to basically create the same thing over here. We're going to create a controller class, but this one is going to accept what the backend is providing. So again, it's REST controller. We're going to have Lombok create a constructor with all arguments, and we're going to set up a request mapping. Let's call this one /hello for our nice client happy endpoint there. Now, we need something in order to accept an HTTP request that's coming from that backend service, right? In order to do that, we're going to set up a bean that's going to use web client, which accepts HTTP requests in a non-blocking fashion, which means that we have reactive capabilities using web client. So we can accept as many requests or as few requests as we set up. Non-blocking means that it's not going to stop them. It's going to let them just kind of stream in. And so we can set this up to have a bean for this, and then we can use that bean in order to grab that backend API and pull the data that's coming back. So we're going to return web client.create, and we want to go to HTTP localhost port 8081. So that's where we're expecting that backend service to live, right? And then we need to inject that. So web client, we're going to call this client. And then we need to use that in a method. So again, we're dealing with reactive types. So we need to specify a mono of string because we're only expecting a single string to come back, right? Just that hello world. And then we can call this get text or get message if we want to, anything we want there. And then we're going to return client.get.uri. Remember, port 8081 /text is where our endpoint lives, where that information lives. .retrieve body to mono. So it's going to take the body of that HTTP request. It's going to convert it to a mono type, that single element that we're expecting. And we're going to expect a type of string.class to come back. Okay. So everything looks happy. I don't see any red. So that's good. Let's go ahead and run this application now. Oops. For some reason. There we go. I don't know why this message keeps popping up for me. All right. And then let's switch over to our browser. And now I'm going to open a separate tab here so we can kind of flip-flop between the two. Localhost port 8080 /hello. That's our front end application. And you can see now we're getting that same text. So we are able to, from the front end application, grab the back end application or ping that back end application. It provides that text string and it sends it back up to the client application. So everything is working as we expect it to. Now, again, this is nothing super fancy. We're just tossing a string over the wire, right? This is not, maybe to some of you, true microservices. So let's fix that. I'm going to flop back over to the backend service and let's plug in Neo4j to this. So we're going to plug in a database. Now, in order to do that, I've got to add that to my POM. So dependency, I'm going to use Spring Boot Starter Data Neo4j. And this will allow me to use Spring Data, the Spring Data project for Neo4j. Spring Data has a lot of different projects for MongoDB and so on. Now, I also need to plug in details in the application.properties in order to connect to that database. But since I'm running a cloud database, I don't really want to share those. So what I'm going to do is I have a backup application.properties that has that info in there. And I'm just going to copy that in. If you want to see what it actually looks like, the template and so on, that is available in my code repo at the very end. And I will show you guys where that is. But for now, we'll just copy it in there. And that will allow me to connect to my cloud database. It has things like the URI, the username, password, and then the actual database name to connect to. All right. So with that, now we're dealing with book reviews. And so we need to connect our Java entities or our data entities inside Neo4j to our Java application on the front end side. So we're going to create a data class. We're going to call this review. And we're going to use the @data annotation, which is a Lombok annotation that does getters, setters, equals, hash code, and toString methods for me. So again, I don't have to write all that boilerplate. We don't have to like read through all of that boilerplate. Next, we need to specify that this entity is a entity type in the database. So because we're dealing with Neo4j in the data model schema works with nodes and relationships. So this is a node entity in our database. We need an ID. I'm also using a generated value as the ID. I'm going to start with just the internal ID for the entity. We just call it a kind of a Neo ID, if you will. And then we also need to specify don't have to, but are basically our technical key or business key, if you will, which is the review ID itself. So the ID that gets assigned to the review. And then we also have the book that it's attached to. So the book that review is for. And we have the actual review text. And then we have the date that it was added. And then finally, we want to keep track of the rating that this reviewer gave for the book. And so we can track that through an integer. Okay, that's our data class. So now we can map our node objects that are reviews to review objects inside our application. Next, we want to be able to interact with the database via a repository. So we can call this review repository. It's going to extend the reactive Neo4j repository. We're dealing with entity types of review that have an ID of long. And we could actually utilize Spring's derived finder methods if we wanted to. They kind of build a few things like find one, find all, and so on out of the box for you that are derived methods. However, we have thousands upon thousands upon thousands of reviews sitting in our Neo4j database. And because I don't want to overload the browser for demo purposes and overload my internet speed and so on, I'm going to limit this down just a bit. So I'm going to create a method that's going to return a flux of reviews, so multiple reviews. And I'm going to say find first 1000 by. So normally with Spring derived methods, you would provide some sort of criteria. So find first 1000 by name, by title, by author, by rating, so on. However, if you kind of a little hack is if you don't provide a criteria specifically, then it just grabs a random 1000, which is exactly what I wanted, what I was looking for. So we're just going to do that. And then we need to inject that into our controller, our repository into our controller so that we can utilize it. So review repository, and we're just going to call this repo. We're going to return a flux of reviews. We're going to call this get reviews now because that makes more sense. And actually, we could call this endpoint. We're going to a database now, so I'm just going to call it Neo. Again, a little bit more of an alignment with what we're working on now. And then let's say we're going to return repo.findFirst1000. And that pulls our method. And I think that's all we need here. Let's rerun the application and see where we end up on our endpoint. So flip back over to here. Go back to, again, my /8081, but now remember we've changed this to /neo. And this should now provide reviews. And of course, now I'm too zoomed in. So now we get several reviews coming back. We've got our ID, we have the review ID, the book ID that it's the review is for, the actual text, the date it was added, and the rating. And we can scroll through, but we're going to get 1000, which is what I specified in the method. Okay, this is good, but we haven't actually provided that to the front end. So let's swap over and head back to our front end application and plug this back in. So now we need to add this info. So nothing else needs done there. We just need to plug it in right in our application here. So let's just change this to reviews. Again, we're not dealing with simple text anymore. We're dealing with objects. And we also want a data class here. The reason for that being is we could just deal with a map of data and work with it that way, but it's a little bit cumbersome. The easiest way I have found to work with this data is to create a data class here. And so we can use @data. Again, it handles the getter, setters, equals hashcode 2 string for us so that we can access those member variables inside the class. But we don't need to specify the @node because we're not interacting with the database. So this application really doesn't care whether it's a database entity or not. So here we just need to specify, we have a string of Neo ID. We have a string of review ID, and we have some strings for our book ID, our review text, and our date added. And then we have our integer of rating. So that's all we need to provide. Again, just the outline of that class so it maps to our data object here. Now we need to plug this info in. So we're not dealing with a mono anymore. We're dealing with a flux of reviews. And we can just leave that as is, or we can change this to get reviews just so it matches our data a little bit better. We're no longer going to /text. Remember, we are going to /neo. And we're no longer accepting a mono, right? We're going to take the body of that HTTP request and we're going to turn it into a flux. And we're not expecting a string to come back. We're expecting reviews to come back. So without further ado, we can restart that up. Okay, and switch back over to the browser. And 8080, remember now we have our /reviews. And we get our reviews coming back. So now, again, we have that front-end application that pings that back-end API. The API is going to the database and then returning that info kind of in that chain all the way back up to our client application. Okay, now this looks good, but we're still running everything locally, right? We're not having an orchestration service or automation kind of handle this for us. So what we can do is I will switch back over here and stop the applications. That way I don't have anything conflicting when I spin up Docker here. Over to here. So I have a couple of shortcuts that I will walk through. First off, I have another application.properties file for my backend service because I no longer want to have the internal application ping the database. We are actually, as I mentioned, and as I kind of showed on that one slide, we're going to use a config server in order to handle the database credentials so that I don't have to share my database credentials within the application itself. So I've modified the application.properties to basically comment out those database credentials. And now I can just set this in to my resources, and I'm going to I'll probably have to delete this and just rename this here. There we go. And then we have a sample Docker file. Now, there are a variety of different ways you can go about orchestration services. I have chosen to go with Docker Compose. And the way that Docker Compose and several other orchestration tools work is you typically spin up Docker containers with the applications in them. So in order to do that, we're going to need a Docker file in order to containerize each one of these. So I'm just going to paste my Docker files in to my services, but I will need to make a tweak in the front-end application because I can't use the exact same Docker file. I have to modify it for front end. And same here. Oops. Spelling. There we go. Got ahead of myself. Okay, so I'm basically creating a base image, so a container that has Azul's OpenJDK version 17 in it as the base layer. I'm specifying if anybody has questions about this particular Docker file, this is who to contact. And then I'm copying in the jar file for this front-end application as frontend.jar, and I'm exposing that in the container as well. Okay, so with that, we have the Docker file, and then before I forget, let's go ahead and build the jar files. Because if I looked in my target directory for each one of these applications, we actually would not see anything in there. There we go. So let's go into our backend application, and I can do a Maven clean package. And oh, I forgot one other thing too. Let's see here. So I mentioned that we have the config server that we're going to use the data or to access the database credentials. But in order for the backend application to utilize that to be basically a config client, I need to add that to the POM. So I'm going to add this as a Spring Cloud Starter config, specify a version, reload Maven for that. And now this will kind of default. It's going to be looking for a config server. So now I can switch back over here, and within my backend folder, then I'm going to need to specify a separate option, because now that I've specified it as a config client, it's going to look for a config server running and try to connect to it. Since I don't have config server running locally, it's not going to find one and it's going to fail that test. So it'll actually fail the build if I don't add this additional option onto the end. But we're going to go ahead and say, okay, we know it's expecting it. We don't have one running. Skip the tests. Obviously, in production or even in real applications, you would want to build a test into that and have a test config server to run against and so on. But this creates our jar file. So now let's go over to our front end and basically do the same thing. However, our client application does not use config server at all. I didn't add that in the POM, so it's not going to look for the config server. Therefore, I can just do a Maven clean package, and that'll build the jar file. It'll run all the tests. You can see in just a second, you'll see some test results that kind of show, yeah, see it there, it's running tests. So it takes a couple extra seconds from what we did on the last one. Okay, so now we should have our jar files ready to go. The only other thing is I will walk through very quickly the Docker Compose file. Open this with, here we go. Now, I could have coded this all from scratch, but who really wants to watch me write YAML code? So if you call it code, I guess, but config file basically. So we need something in order for Docker Compose to use as a template in order to spin these services up and down and to know what to spin up and down and what configurations or environment variables to add. So here we have the version of the Docker Compose file and then the list of services that we want to add. So I mentioned we're going to add a config service in there. We have the container name that is going to specify how we can access this container directly. This is going to run off of an image that I created in Docker Hub. However, you can build it from a local folder or other places, but I've specified it's just going to pull from Docker Hub. The default port for config service is 8088, or 8888, excuse me. So we're going to specify it's going to expose the internal port of 8888 to the external port on the container of 8888. We're setting a couple of different profiles. This you can do if you're running with different environments and you need different values for running test environments versus dev environments and so on. I'm going to mount a couple of volumes on my local machine, one to actually access the config files. You have the option to have config files in a GitHub repository or elsewhere. You can also put them in a local folder for testing purposes. And because I didn't want to expose my credentials on GitHub, I just put them in a local folder. So I need to mount that so that any changes I make locally will get shown in the Docker file or in the Docker container as well. And then I want to mount log files as well so that I can access them outside the container. Docker network, I go into a little bit more specifics in some of my blog posts, but basically Docker will create a default network for you if you don't specify one, but that means that the containers can only talk to one another using IP address. So if you create a custom network, you can actually reference by the container name, which is much easier for me when I'm demoing to remember which container am I going to, instead of trying to remember, okay, which IP address do I need for this particular container. Next, we have our backend and our front end services. Sorry about that. And so our container name, again, this is our reference for the name. So I can ping backend and it's going to grab this service. It's going to build from a local folder that has our application in it. It's going to expose this port, and it's going to depend on the config service because obviously our config service has the database credentials that we need. So if it doesn't find the config service, or if for some reason the config service is not up, then all of a sudden this service is not going to work. I go into a little bit more detail in my blog post on this as well, but basically if you have some failures within the application, you try to build resiliency into the application itself, but when that kind of hits a wall, then you can actually restart the entire container. And I had some issues with config server specifically on this, and so we could just restart the container here. So it will do that if it finds a failure. Set some environment variables, so it needs to find a particular config file to reference for this application. It needs to know where the config server is located, and I'm using a particular profile of Docker. And then, of course, the custom network that I specified. Same thing, looks really similar on the front end. We're just going to port 8080. It's going to depend on the backend service, because now that backend API, if that's not up and running, then obviously our front end client won't be able to do anything. It also has a restart and the custom network, and then an environment variable here. Now, I did actually forget to go back and do this, so let me pop in and fix that really quickly. So we have a, if you remember right, in our application, our front end application, we specified the web client bean to look for localhost port 8081 for our backend service. Now, this works great if you're running all locally, but not so much if you're running, for instance, in Docker containers or remote servers or even the cloud. That localhost is not going to find anything. So one way we can add a little bit more flexibility in, you could ramp on up and use something like service discovery, which is probably the more kind of professional approach to use. But one way you can kind of get around this to provide some flexibility without a whole lot of extra stuff is we can say, look for an environment variable called backend.hostname, and you could call this anything you wanted. If it doesn't find it, it's going to use localhost for the value. And then we're going to say this is private. We're just going to attach this basically to a variable name. And then here we can plug this in and say host name in the middle here. So now it's going to go wherever that host name happens to be, whatever we specified. If it finds a backend host name environment variable, it'll use the value that's that. Otherwise, it'll use localhost in there before that port 8081. So it'll be a little bit more flexible. Now I will need to rebuild that jar file here since I changed that. Almost forgot that little change. And then once that completes, then we should be good to go, and I can run the Docker Compose. So now I should be able to, let me just go back to my main project folder here. I should be able to run Docker Compose up -d. And because I'm building from local folders, I want it to build each time I'm going to run this command. So I add that -- build onto the end. And hopefully this all works. This is the part that if it's going to go wrong, this is where it goes wrong, because Docker is finicky in my mind. So we'll get that spun up. Oh, that's taking a long time. That does not give me warm fuzzies. What did I miss? Goodness gracious. Oh, this is much slower than what it has been. Nothing like a live demo to introduce all the problems. Okay, that at least looks good. I did do this once, and I ended up I copied the same Docker file in, and it did not like that. But that should not be the problem this round, because I fixed that. Oh, there it goes. Hello. Okay, so now we should be able to go over to, I have no idea why that took so long. Over to we could test our port 8081. Look at that. Okay, so our backend service is working. Again, we're not running this locally. Remember, I stopped those applications. We are now running within Docker. And so now let's run our front end client application. And you can see we still get those reviews coming back. So again, we've got that all of this running in Docker. It's our front end application is pinging our back end application, which is then reaching out to config server, grabbing the credentials for the Neo4j database, and then back end service goes to Neo4j database, grabs the data from there, and then passes it back on up to the front end. So with that, let's dive on over to our last slide and just showcase a couple of resources here. So all of the code that I wrote for today is in that first GitHub repository link. If you want to see this full project, so I've got multiple levels. I've included things like MongoDB and Eureka, service discovery, and some other things in there as well. I go much more in depth on config server and clients and so on in the full rendition of the code, which is there at the second link. I also talk a lot more about a lot of the things I had to skim over today in my blog post. So feel free to check out my blog there. Some of this stuff is also available in other places, but my blog, everything is centered there locally. And then if you want to spin up a Neo4j Aura DB free tier database, just like we were running today for the demo, feel free to follow that last link. And again, my contact information is there in the lower left. I will pop into the chat and answer all of your questions, I hope. And thank you so much for attending, and enjoy the rest of Nodes.
Thank you so much, Jennifer. That was a lot. So thank you. Okay, so we are going to move like right away to our next speaker. So thank you, thank you. Okay, and our next speaker is Zach. Welcome, Zach. You're on mute. Okay, here we go.
Thank you.
Zach is going to talk to us about security. So take it away, Zach.
All right. Hello, everyone. Thank you for attending this talk. My name is Zach Probst. I'm a senior software engineer at Intuit, and I work on the platform security and compliance group at Intuit. And the title of this presentation is Security and Velocity Through Declarative Ingestion. And my hope is that by the end of this talk, you will know what all those words mean in relation to one another and how we at Intuit have been able to do some cool security work with graph databases and consuming lots of data with it. A little bit about me, just before we get started. I'm originally from Hershey, Pennsylvania, and a side effect of growing up in the backyard of one of the largest independent amusement parks is you become a roller coaster aficionado very quickly. And I didn't stay in Hershey forever. I went to school in Rochester, New York at RIT. If you've never been to Rochester, you'll know it's a very cold and a bit desolate place, but it's also very beautiful in the summertime. So if you're ever going to visit Rochester for something, I hope it's in the summertime. I've been an engineer for a while now. I cut my teeth in Ruby and C#, and I kind of drifted into Python after that. Recently, I've been really loving writing Rust code. As a security guy, it provides a lot of benefits in memory safety and other things to write secure software. But let's talk about not about me. So we're going to go ahead and skip to our work at Intuit. I work on an application which is starting to become known as the Security Knowledge and Insights Platform. Prior to this, we used to call it the Endpoint Mapping Service. And the name change is representative of the kind of success we've had with aggregating together data in a graph and using that to secure Intuit. And in particular, our mission statement is securing Intuit through visibility, hygiene, and collaboration. And so we try to gather a bunch of data sources from across the company and kind of make sense of it to solve security problems. So to kind of journal our story, in the beginning, Intuit didn't have a great way of attributing software to sort of host names, DNS endpoints out on the internet. It's hard to see behind abstraction layers and content delivery networks and all kinds of other things like that. And there isn't a great way other than to manually kind of trace your way through all the applications at Intuit and understand how they interrelate. Applications at Intuit are built from lots of microservices and micro front ends. And so understanding the composition of any endpoint and where a particular security vulnerability may lie is quite difficult. Fast forward to today, and we have a graph that's over 7 million nodes in size, roughly 45 million relationships. And to build that, we process data from over 20 data sources and process hundreds of millions of records per day to distill all this information down. And what we're able to do is sort of provide ownership of who owns a particular endpoint or a particular URL on the internet in like 100 milliseconds. And we can tell you all kinds of information about it, like what GitHub repos is the source code for that application, who's the dev manager responsible for it, where it's deployed in our cloud, what technologies compose that, and a whole lot more. And to sort of exemplify that, this is www.intuit.com, the corporate host name of our company. And as you can see, there's all kinds of dots. It's like confetti. There's just a collage of different colors here. And don't try to make sense of what this is. Just try to make sense that there's lots of data coming together from different sources to kind of stitch together a story for every given application in the company. And if you think about your own enterprise or your own company, you rely on lots of vendors, and you kind of compose them together to build your environment, right? You might have source code that's managed on GitHub or GitLab. You might have CI/CD, that's something like Jenkins or Circle CI or what have you, and you're deploying it onto a cloud like AWS or Google or Azure. You might have a CDN in front of it like Cloudflare or Akamai, and presumably you also try to secure it. So you might run over your source code and your applications tools like Snyk or Veracode to check for common security vulnerabilities, check for vulnerabilities and third-party dependencies that you may be relying on, and a whole lot more. Even things like Kubernetes and stuff like that. All of this together is what it sort of represents how your application gets built from a developer all the way to production. And understanding the story that every application goes through is complex, and it requires data from all these different places. So you might be asking yourself, like, okay, so what, right? You have a lot of data, you put it in a graph, like, we're done. Turns out that it's not quite that simple. And to get a sense of it, you have to think about like what the first step is. And the first step is to ingest all of this data. And ingesting a lot of data means that you have to like write code to scrape from APIs or access a system and stuff like that. And a lot of the code ends up looking like this, where there's like random like or zero. Like I wrote this code and I don't know why the default version is 0 anymore, right? It's long past. It's been cast off into the void. Or up above that, where it's policy info status. If the activation object doesn't have policy info or status, that code's going to break. So all of this is it's very easy to write brittle code to try to tease out the information you need in complex data, and to be able to distill that to nodes and relationships. Once you have that data, the graph database takes care of connecting things in such a way that makes sense and lets you explore it. But getting the data distilled from all kinds of different formats is quite challenging. Even if your organization is itself very disciplined about how it structures data and has strong schemas for things, like I said before, your organization also probably relies on a lot of vendors that may not have that same discipline and schema, or just have a schema that's not very convenient for projecting into nodes and relationships. And so this is a kind of further example of that. Like there's all kinds of crazy things that can go wrong when you're sort of teasing through data, right? A value you need for a key or a property might be null. What do you do then? It might be drilled deep into like lists of objects that have lists themselves of other objects, and that value is all the way deep down in some crazy complicated JSON structure. Or you might just have crazy things like a JSON string encoded in JSON, right? Like, what are you to do with that, right? So you have to write all this very brittle, complex code just to be able to use a graph database, just to be able to ingest all of this stuff. And so this is the problem we found, is that it's hard to kind of sustainably do this. For a given data source, you can hack together a Python script pretty quickly to gather all this data. But when you start adding tens of data sources to your application, it's tough to be able to do this repeatedly and fast. And to sum it all up, writing code for each one of these data pipelines is a nightmare. It really slows you down and limits your ability to provide value for the organization. And so enter our solution, which we call declarative ingestion. And the idea is that essentially what we're doing is ETL. And there's lots of different ETL frameworks out there that let you do all kinds of stuff. But at the end of the day, you still have to write some code for a lot of these things. And we wanted to really minimize that and provide a way where you can quickly, and sometimes as low as an hour, introduce a whole new data set to the graph. If you think about what an ETL job is, here's some source of data, and then you need to transform and filter that data down into the things that you're really trying to get at. And then in the case of ingesting stuff into a graph, you need to be able to turn that thing into a series of nodes and relationships. You kind of need to project it into its own little subgraph. And then once you do that, you have to figure out some way to deploy it and run it, right? It might be a scheduled job that you have to pull data every so often, or it might be something where you're listening on a Kafka topic or a stream of some kind and just ingesting stuff that way. And our goal is to be able to do all these things in such a way that you don't have to drop to code. You don't have to drop to writing infrastructure as code either. Everything's just kind of sleek and easy to do. And that's what I'm going to kind of walk through how I've done that. So the first step is what we call the extractor. This is your source of data. And there's all kinds of, in our framework, we have all kinds of built-in implementation. This one is one that reads from a Kafka topic. Into it, there's a layer on top of Kafka called our event bus that does some encryption and a few other things. And you'll see that the first step is that we just basically point it at a topic, give it some credentials to use to read from that topic. And from there, we're able to retrieve records from it and feed it through the rest of the pipeline. Another example of an extractor, you might imagine things like I mentioned before, Kafka. You might write one for SQS or something like RabbitMQ. You might also pull stuff from a data warehouse or a data lake. You can think things like Google's BigQuery or Amazon Athena, Vertica, all that sort of stuff. And we talked a lot about pulling data from APIs from different vendors and things like that. The way we typically do it is we write a scraper for that API and then ship the items across a stream, like the Kafka stream as mentioned before. And I'm going to note a distinction here between sort of infinite extractors and finite extractors. If you run like an Athena or a BigQuery, it's going to produce a finite number of results. So your extractor is going to run out of data at some point, versus a Kafka topic where your extractor is just going to keep pulling, keep waiting for more data. And so you have to kind of run those two workloads differently. If you're deploying something that never terminates and constantly needs to pull, that's something that has to run on sort of like a perpetually running container, right? It can't be a cron job that kicks off every so often. So we kind of needed a way to distinguish these. We'll come back to that in a second. I just want to point out that differentiation while we're talking about extractors. The next thing is to kind of massage the data, right? There's maybe you need to filter out certain data. You need to manipulate data. If you go back to that, like the encoded JSON in a string thing, we have transforms that will take that thing and sort of decode it as JSON and put it back in the object. We have filters that make sure a particular value is one of a list of possibilities and things like that. And as we encounter new use cases, we implement kind of these reusable components, right? If you like the expand JSON fields, the one on the right, you can think, hey, we didn't build like the expand this particular field in this particular object transform. We built a generic transform that can be reused across different pipelines. Same thing with filters. Before we continue, I want to do a quick little aside on JamesPath because it's going to set us up for the next section of this. If you're not familiar with JamesPath, it's basically a query language for JSON. So I have a couple examples on the screen, but in general, what JamesPath lets you do is it lets you drill deeply into complex JSON structures or complex JSON documents and tease out the exact data you need. And you can even do more complicated things, like you can slice arrays on a particular index, or you can project some part of it as something else, and all kinds of things like that to kind of minimize or narrow down the data that you're looking at to a particular thing. And this is how we get at the necessary fields that we need to draw nodes and relationships out of these complex documents. And we do so with a mechanism that we call interpretations. And the idea behind interpretations is you're looking at a document, and that document tells you a bunch of different things. For instance, it tells you, hey, this thing should this field should be used as the primary key of a node, right? So if you're looking at a user and it's got like an email address, maybe that's a unique way to identify a user, right? In this example, we're sort of encoding the org chart into it. And so I create an employee type or a node type called employee. And the key for that is the email address. Because in our system, our email addresses are unique to an individual. So we use that as the key of the node. And then next to it is it has another field in this object is the manager's email ID. And so we can create a relationship called reports to another employee. And that way we're bootstrapping up an org chart. And we can also do other cool things like extract variables and then use them later in some other place. The way all this works is it kind of gets distilled into an intermediary representation of nodes and relationships. We have sort of an in-memory model of nodes and relationships we're creating per record. And then that in-memory model gets fed to something that upserts this information into Neo4j. And so just for fun, this is the Intuit org chart blown out 5 degrees from our CEO, just to kind of prove that it works. And as you can see, it gets pretty hairy pretty quickly. You might be asking yourself, though, like, how do we test all of this stuff? We went back to the playbook on this one, and we found that in JavaScript, there's a testing framework called Jest. And one of the technologies it has is something called snapshot testing. And the idea is like you give your code some input and that produces an output. And then it stores that output. And then every time the tests run, it runs it again and ensures that the output matches what it was before. And so we use our in-memory representation of nodes and relationships to act as our snapshot. So we give it a reference to our pipeline file, which is made up of all the components we've talked about so far. And then we give it a sort of test set of data, a test fixture of data. And then we use the snapshot component to make sure that that snapshot matches every time. So you can go in and tweak the pipeline, or you can change the underlying engine. And as long as your snapshot matches, you know that it's going to work. Obviously, we test locally and test in pre-production environments as well, but this is how we sort of write automated testing to ensure that given the same input, the same output is produced. Now the next phase is we've got some data, we've interpreted that data as nodes and relationships, we've tested it locally, we've run the snapshots, we're ready to roll this out, right? So the last part of this puzzle is what we call the registry. And the registry is basically just a list of all these different pipelines. And this is where that distinction comes back between things that are infinite or finite. Things that are finite, we can run on a cron schedule. So we have a block of the one on the bottom right. We have a block for different pipelines and the schedule that they operate on. And for things that are infinite, we can define the same pipeline definition, but we can also give it how concurrent we want that to be. Some of our topics are drinking from a fire hose, and one instance of our pipeline is just not enough to churn through all the data, where others it is. And so what happens is we have Kubernetes workflows that basically read this file and provision the necessary cron jobs or pods running in a replica set to handle the load of all these different pipelines and distribute them. And so we don't have to write a whole bunch of Kubernetes resources ourselves. We have some sort of automation that reads this and then produces those jobs automatically. And it lets us be able to churn through creating all these jobs very quickly. And so here's the end-to-end flow of all of this. The data is on the left, and the graph database is on the right, and the story in the middle is what we've been talking about so far. We have some things that come out of like data warehouses and things like that, operational data that we can just read directly in through cron jobs. And then for things, vendors where we're scraping APIs and pulling data, we have a cacher that pulls that data, sticks it on a Kafka topic that we then ingest. And the declarative ingestion is all the stuff that's in the Munchlax box. Munchlax is the code name for our service that we use to ingest all of this data. And the output, again, of course, is the Neo4j instance. On the other end of that, I talked about our API before. So we have an API that sits in front of the graph database and also expose Bloom for visualization to some of our customers as well. This slide sort of potpourri. It's a couple of miscellaneous thoughts about all of the way the mechanics of some of this stuff works. So first, we run all of our data off of a TTL. So as things expire, they're removed from the graph database, and we set definitions for different nodes and relationship types and give them each an individual TTL, because some data is collected more frequently than other data, just by the nature of some things change more often, right? For an example, EC2 instances or virtual machines get torn down and stood up all the time, right? It happens very frequently. So we collect that every hour, as opposed to something like the contributors to a GitHub repo. That changes fairly infrequently, right? It's usually the same people that contribute to a GitHub repo. So we don't need to collect that as frequently. And so basically everything gets periodically recollected. So if it maintains its presence, right? If that virtual machine sticks around for a long time, or a database or whatever sticks around for a long time, we'll keep seeing it, and we won't ever TTL it out. But things that are sort of have drifted off, we eventually TTL out. Some other notes about developer experience: we have the ability to kind of automatically create the necessary constraints and indexes that are used in the ingest. So by nature of you referring to a particular field on a node and saying, hey, that's the key, it'll create an index automatically as it starts to ingest that data or ensure that the index is in place. We also have a whole bunch of links that are in place to make sure that you define TTLs, that your key usage is consistent across different pipelines. So if you have 5 pipelines and 4 of them refer to the employee node by their email, and the last one refers to the employee node by its by the person's name, that's sort of an inconsistency that we try to avoid as much as possible. And the last thing is, I think one of the key points around the way that we do this quickly is that it's composable. We can reuse these sort of building blocks between different pipelines, and then only reach for creating new code when all of the building blocks we have don't solve the problem. And so, we might have to create a new transform or change an existing transform to support manipulating data in some new way. And this allows us to write a lot less code and churn through adding new pipelines to our data, or adding new ingests or pipelines into our graph very quickly. So what has all this bought us? And the answer is a lot. So we're able to handle significant amount of load. So we have certain topics that don't even register sometimes. So the charts on here are the backlog of items on a given topic. And so there's just almost never a backlog because of how quickly we ingest some of this stuff. And others that produce hundreds of millions of records, maybe sometimes we'll have a couple million as a backlog, but usually it's pretty close to 0. And so we're able to look through all kinds of data and project it into a graph at kind of an extremely quick rate. And we're also able to do this without just blowing up the database. So one of the critiques we heard when we started using Neo4j was that sometimes it's slow with writes, and it hasn't been our experience. We're able to, for the most part, keep our ingest in sort of the 10% of CPU range on a 32 gigabyte cluster, which is not huge by any stretch. And we're able to keep things as low as like 2 to 3%, depending on how bursty our ingest of data is. But as far as business outcomes, we're able to introduce about 1.5 PRs per working day, which is kind of a lot. And we're about a 3-person team. I say about because there's 2 people that are full-time, and we've had some people kind of contribute stuff here and there on a part-time basis. One of our projects we have is to score the risk of every asset in the company. And we're able to produce 100,000 risk scores in 4 minutes, thanks to all of the data we're able to aggregate and stitch together. That's including all kinds of things like the presence on cloud, right? What your posture is on cloud, if you're configured to talk to third parties, and all kinds of stuff like that. So it's very complex traversals, and we're able to do it extremely quickly. Intuit's also a very big company. It has a huge presence on the internet. It has a very large attack surface. And we're able to attribute over 500,000 different DNS endpoints or host names to the owners, to the code, to the vulnerabilities that may or may not be associated with any given endpoint. And we're able to do it in milliseconds. And one of the on that note, one of the interesting things about this, because we're able to add new data so quickly, whenever there's a 0 day and there's some new piece of data we need to look at to find out if we're exposed, we're able to turn it around very quickly and do analysis. If you're in the security space, you might be aware of the OpenSSL vulnerability that recently hit. There's a lot of cool things in there that require you to analyze the system, not just the dependencies that belong to the application. You have to know about the system that it's running on, and we're able to ingest some of that data very quickly to analyze it. There are some shameless plugs I'm going to throw out. My coworker Chad Close just wrote an article about the way we deobfuscate some of our infrastructure at Intuit. On this topic, it goes into some of the detail. There's some code there as well, showing off kind of the proof of concept of a lot of the things we've talked about here. And I would also like to foster a community around this, if at all possible. We're looking to open source a lot of what we talked about here in some capacity. So if what you've seen is valuable to you, if it's something that you might find yourself wanting to use, please reach out to me. My email is right here on the slide. It would be great to kind of generate some interest around this and foster a community around it. So I have some time for Q&A if there's any questions. I've been monitoring the chat. I don't see any questions, but I'll give it a minute to see if anyone has something, brings up a thought. So excited, motivated. Yeah, Aisha, I think reach out. Let's see if we can collaborate in some way. Yeah, that sounds good, Michael. All right. I think I have a few more minutes left. Let's see, Gabe, by asset, you mean all developed software and services? Yes. So asset is a bit of an Intuit term. Basically what it means is any piece of software or service that the company has developed. And so we're able to attribute to services, to websites, and then from there, what the source code is and all that sort of stuff. Michael asks, what was the biggest challenge in building this? I think it's really how to say it, finding the data that actually is proved valuable to add, and sort of building sort of a manual graph, if you will, of all the data. So if you have data set A and B and C and D, and you're trying to figure out how to get that path, right, you kind of have to look at some of the data before it's in graph to see how it kind of pairs up, and then from there turn that knowledge into ingestions. And digging through all the data before it's in graph form is, I think, probably the hardest part. Does the declarative ingestion tool or framework only work with Neo4j? So currently, yes, in that we only have sort of one output to Neo4j, but the framework has the ability to kind of swap in a write component. So you just need to implement the writer for some other database, right? And that would probably require like a change in query language or things like that. So the framework is there for that. The framework was built to support that. We just have never implemented any other source or destination but Neo4j. Great. So I think questions have mostly dried up. So I just want to thank everyone for your time. It was great being here.
Thank you, Zach. That was a very insightful presentation. So thank you so much.
Thank you.
Okay, so we have 8 minutes before the next session. So time for a little break. So welcome back. I hope you enjoyed that little break. And our next speaker is Warden Cunningham. And Warden is going to talk to us about super collectors.
Hello, it's a pleasure to be speaking here. And let me get my slide. I did Wiki a long time ago and have done a few more. The current wiki is a data wiki. It's a federated wiki, and we've recently added graphs to it that are based on really kind of a clone of Neo4j, which works a lot better, I would say, than any other attempt at graphs we'd done over the years. And I'm interested in why it works so well. And so what I'd like to do is talk about that in the context of a couple projects, and especially this thing we call the Super Collaborator. That's a version of Wiki with a different sort of storage mechanism. So this is how I think of it. Wiki and Neo4j have a lot in common. They have nodes and we have nodes. Our nodes we call pages. And we have links and they have links, but they're links they call relationships. The thing that impresses me most and has drawn me into Neo4j is the computational ability, that those nodes and links can mean more than they ever meant in Wiki. And so when we draw that into the client-side environment in Wiki, we find that we, not for nearly as large a graphs, but for, hundreds or thousands of nodes, we have a right behind the glass sort of feeling. And so it makes them browsable. And, I mentioned plasticity. That means we like to set things up so that when you put them next together, they figure out how to hook together. This is what a federated wiki tab looks like. We'll have, here I have 4 different pages, and they all have something to do with data. In this case, it's about graph data. And as it moves from left to right, it moves through a couple of different stages in that third slide, and then is rendered by GraphViz, which is just a standard plugin in Wiki. So the computation happens before it's rendered. It isn't a drawing tool, it's a representation tool. And here it happens to be representing stuff related to a learning process that was developed by Thompson Morrison. And he's been very active in using Wiki and is very excited about using this graph stuff too. And I'll say something more about that in a minute. But let me show you what we think of it as developers. That in Wiki, we handle a lot of data, and that could be lists of things or tables or trees. We use JSON. There's good text representations for these things that are kind of devoid of any application. They're just that. But in the client, we didn't have a good representation for a graph, except what might be associated with some drawing program. But then it has all the drawing stuff in it. We like the Arrows app, which is a Neo4j thing, and that doesn't have too much, but it is still, ours is simpler. Let me draw a picture of it. And by the way, I mentioned, lens making because it was the lens makers that made a real advance in science. And we feel a little like lens makers by just bringing capability to the wiki for other people to explore. This is what we put in memory. If you want a graph, you say new graph, and that allocates room for nodes and relations. And nodes and relations have enough room in them as just JavaScript objects to be able to keep track of references to others. The graph abstraction that wraps that all up just keeps the pointers straight. And I just love this idea that the reason why this works so well is that the relationships are materialized, pre-materialized. You You know what the relationships are because you put the relationships in. And I give that a barn star. A barn star is a compliment. That it's a wiki thing. It's kind of like that gold star you get when you were well behaved, I guess, in kindergarten. But I'll, when something really works for us, especially in this idea of things can flex to be what it needs to be based on how you're using it, then on my slide deck here, I'm going to hand out some barn stars. So this is a little closer look at what Thompson was doing. He's tracking the learning behavior, in this case, of 2 different students. See, we actually have tracks for 4 different students, but we picked 2 students and then they merged them together and said, these 2 students were, curious and wondered about things and were surprised as they do things, and that leads to more curiosity. And this is just tracing out the nodes of a history, but it turned gold there where the 2 students touched the same thing. And that's what we're really trying to do, is find out how the students are working to create excitement and curiosity and learning with the other students. And it works. This is I give a barn star to Jess. Jess is the teacher in a 4th grade class, and she's adopted this scenario for what stages somebody goes through when they're doing independent study. And so these are 3 independent students, and she just interviews them. She say, well, what were you looking at today, and what surprised you about that sort of stuff. And then they offer up this stuff, and she writes it down, and they become very interested in how she thinks of their learning, and are proud to describe how they learn to their students. So this is on paper the same thing I was just showing you there. This is actually Thompson on the right, Jess on the left, and David in the middle are 3 educators working on this project. And this is them writing in Wiki over the past 2 years about why it all works. And so this is on its way to be a book. I showed you what Thompson's other book looked like a minute ago. I should have pointed that out. But as they authored independently, that makes this thread that goes down the page. And then the brighter blue, aqua color, are things that they call the garden. There's the story, and then the garden is all the things about the environment. And these eventually link up, but this is how they're going to turn these 3 author stories into a volume that makes sense to educators and is convincing. Now, this was actually rendered not in Wiki. We built a tool that says all the graph stuff that we've done in Wiki in the last 6 months, it feels really exciting. Let's put it all into an app by itself, which we call the Super Collaborator, and see what we can do there. It gives us a lot more room to draw complicated graphs. It also lets us explore different UI techniques that we did on pages in Wiki, but when we put it all here together, it feels especially good. And what I want to do is I want to describe these 2, the green and the brown boxes on the left, because they're both ways to control what's on the screen. So the any user in there is going to see the same green panel as anybody else. This is a single shared distributed environment, is what Croquet is described at, and it's bit identical for every user. So if I add a graph for a student here, or if the whole class is on this, if we have 30 people on here, they'll see the same thing, and then they can do with it as they will. They can select things, drag them into that mixing area, or even create new stuff. And the way we create stuff, we describe this as sort of a systems-oriented chat system. And the way you chat is to select something from this kind of relationship. Now, this is actually another one of our community members, Mark Pearson. is interested not so much in education, but in community services. And this is his model, is what I had a slide of, but you could say, how do groups organize for action based on an ideal? And so I picked a person here. I said, let's start with a person. And I typed Michael because I know a Michael. And as soon as I did that, it says, well, what ideal does he hold, or what group does he foster? And I picked groups. So I just followed this from here to here. We call this a thematic sketch. And it says, in this world, we would say, well, what is, well, it's the Neo4j community, of course. And I could keep going and what actions they do and what ideals were furthered by, those actions and so forth. And, I end up stringing out a kind of long. Now I can actually scroll back and say, well, Michael does more than just foster groups. I could just, scroll up and down here and keep growing this graph. And what's neat is, while I'm doing that, that shows up in this. You can watch me develop as there and kind of watch what I'm doing and so forth. I would like to mention I resisted calling this a schema because I think, some people will beat you over the head with their schema, and it's really an authoritarian way to tell you what to do. And we like things that are a little more open than that. But this just makes it easy to describe something. And you could describe something else. You say, well, we're going to talk about learning journeys instead of organizing for action. And you just drag a new scheme over that, and that changes this to ask different questions. So it's a pretty neat thing. But it's also reasonable to ask, well, where did Pearson get this idea that we needed a tetrahedron? And that turned out that he did a work with a dozen community services in the county where he was. He was in Whatcom County, which is near Seattle, Washington, and then put all that into Neo4j. And he wasn't sure what he's going to do it, but he was sure if he had it all down that was flexible enough to do it. And he discovered this command where you just say, call schema, and it draws a picture of how you organized your data. And he was surprised to see this tetrahedron show up there. He studied this tetrahedron, and I'll give him a barn star for this. And by the time I got involved, he had reduced it and was very confident about that. I shared that confidence with Thompson, who says, oh, can I change it to be more about a learning journey than a geographic journey or versus an action? And make it be about what you want to talk about. And that has worked pretty well. Mark and his colleagues are studying a little deeper. This is a Venn diagram that explains all those arcs that we just might name something, but this is them trying to figure out why those four things work. There they are in color. And I expect as this develops, we'll find even more ways to use it. And just so you know that this is something you could play with, it's out there. You're welcome to find your way in. You'll be dropped into the Hypertext Super Collaborator by just going to HSC, Hypertext Super Collaborator.fed.wiki.org. And in its welcome banner, it says, would you like to see the documentation? And that takes you to a wiki where there's things like, well, you can say more about this idea. Tell us where this idea came from. And that has a link to our implementation of property graphs in JavaScript. And in fact, I almost gave myself a barn star there because down below the fold here, it describes our implementation of the query language. Cypher. We have a mini Cypher that does the match part and then relies on JavaScript for the rest. And that's pretty neat in many ways too. I could give another talk about that, but instead I think I'll ask if there's any questions. I'm looking here. I have fans that I know who are saying I did a good job. Well, if there's no questions, I think I had 15 minutes and we've used it up. So thanks for being here.
Okay, well, thank you, Warden. And we'll have a 5-minute break. Okay, so our next speaker is Katerina. Katerina, hello. How are you doing?
Hello. Good. Hello.
So, and you're going to talk to us about invisible patterns in your data. So how can we find that? So please take it away. Thank you, Katerina.
Thank you. Good afternoon or evening or morning, depending on your time zone. Today, I will explain you how you can use your data more efficiently. Do you have a Google account, right? I will start with this foundation, and we will use the Google Sheets and Neo4j and connect them. The reason for this talk is to teach you on one technique for connecting the table to the Neo4j graph database and discover some invisible patterns in your data. So let's begin. This is our plan. And you see on the left side the table data, and on the right side the graph view. Here's the link to the data. Let's open it and see what's inside. Good data, but what you can say about it? You see the data, it exists, but can you start talking about it? Why you freeze? The answer is simple. When we talk, we're using nouns, verbs, adjectives. We think using objects already, but there is no verbs in table data. So let's build these words and connect the data as bridges you can see on this picture. Let's visualize what we think. We will build the data model. In other words, we will create their schema of our data. We connect the bridges to have roads. Then we can drive safely on our data highway. The college has the scope. The teachers a direction. For example, IT, information technology. The direction teaches level. The course number, for example, 300. At the same time, direction has a course that can depend on each other as well. And the course has a number. We need courses to get a degree, right? Bachelor, master, or doctorate degree. At the same time, the course available in some semester, spring or fall. Nice. So we have our logic ready. And we can fill it now with data. Next, we connect the table with a graph. But before we do that, both should see each other first, and then they can exchange information. So here you can see the settings for the Google Sheet. You see it's easy. We need just share the file, make sure it has a type of CSV, you publish it, and you copy the link. That's it. It's very simple. Now let's go back to the Neo4j settings. Here are settings for Neo4j Aura. You see it's a little bit more steps, but it's doable within a few minutes. First, we agreed that you have a Google account, right? So you can do it. We'll log in, create a new instance, select empty, copy password, click on query the data, insert your password here, and that's it. You connected. You can now start to speak with your data. Now we will go back to the code, but don't worry, It's really easy. This Cypher is very intuitive programming language. I will open the code. And now it's time to dialogue between your data and the Neo4j. Here I just copied the URL link for the tab data, and another tab I have unique data and my password. Each tab in Google Sheet has their own ID number, so you see it's different number. And here will be our first code. If you have something in database, you can remove it and match everything that you have, the touch if it is connected, and then delete it. So we create our first node, use word create, and that add logic. I create my college, College Business Innovation Leadership and Technology. The abbreviation is BUILD. So I will copy this code and run it. I don't have anything in the database, so it's empty. Great. The first node is ready. Let's add more nodes. Use the word load CSV with heads from. Next, you insert the data link from CSV file. And say you will read this line by line. Next, you see in the column that the data values duplicates. To ensure we have only one node of summer, fall, or spring, we use the command merge to create semesters. And it will create a node if it does not exist, and don't create if it does exist. The word next to the line represents the name of your Google Sheet head of table. Let's look on the code together. The same technique I use for the other column, school. And I will copy and run it so we can see it in real. Great. So we have 3 schools, business, technician, and design and art. Let's go back to the code and add more nodes. If you access another tab in Google Sheet, for example, I have another tab, unique data, and I created the column from using the command unique for the direction. We have only 19 different directions. So first it's head, so it will be 19. And you can set a limit for your Cypher code. For example, here we look line by line, yes, but then we'll limit it to look only on 19 rows. The same, we create the direction and have it in our database. So I will run it. Good. We have some nodes in the data. And now it's time to build a relationship between nodes. So when we create relationships, we load our CSV line by line. We match college, we match school because it already exists. Direction we just created. Next, we merge college has a school because we designed our schema that way. Next, school teaches a direction. That's it. Let's run it. Great. Let's go back to our slides. So now we can see that their School of Design has 4 directions, and the same as School of Technology, also 4. But the School of Business has 2 times more. Would you get this in a table view? Why we just have the data? It's hard to see how many directions you would have for the school. Let's continue our discovery. We loaded courses and now see that information technology, IT, has 3 times more courses than any other direction. MBA, marketing, has the same 14 courses. Very nice. Next, let's review how our courses can depend on each other. When we add connections between courses, we can start to see some clusters of the courses, and we can get the path to our desired course. Publication design depends on typography, but also depends on the digital publishing. We have about 40% of courses that depends on each other. That means 60% of the course are running independently. With Neo4j graph technology, we can find a path between nodes. For example, here I run the code to get 7 connected courses between each other. We can see that the data in cloud depends on cloud computing. At the same time, cloud security depends on cloud computing. And cloud security depends on cybersecurity attack. Cybersecurity risk depends on the basic principles of cybersecurity. This is very interesting and true. Would you get all this information just from table? It would be hard without connections. Let's move on. When you have a lot of nodes and relationships, use the Neo4j Bloom to visualize the data. Here are a few steps with settings. So you open the Explorer, then you copy and paste the password, and then you type your logic, what you're interested in. That's it. It's really easy. Here I investigated degree and courses, since we need the courses to get some degree, right? And we can see that the bachelor degree courses in 2 times more than the master degree. At the same time, the doctoral degree less than master in 2 times. Let's explore our last object, semester. We teach 3 semesters, spring, fall, and summer. It's efficient to use time properly, but we see from data that the fall semester has less loading than the spring. We need to balance. Some courses we can see teachers in both semesters and available in both semesters. The time is expired for this talk, and if you have any questions, send him out to me. And here is my LinkedIn profile. If you're interested in my content, you can follow it. I hope you learned something new today, and you can practice with your data and make discoveries. Remember to add verbs and connect your data points to make a data-driven decisions. Thank you so much for attending and listening.
Thank you, Katrina. It was a wonderful hearing you. Thank you so much. So our next guest is Mark Heckler. Mark, hello.
Hi.
And he's hello, talking about getting functional. Take it away, Mark.
Oh, thank you, Yolanda. It's always a pleasure to chat with you and to do anything with Neo4j. Just love the tech, love the folks there. So let me go ahead and get started. Thanks for everyone attending. So hello there. Let's get functional. As I like to say, pull off a trifecta with Spring Cloud Function, Azure Functions, and Neo4j. Again, my name is Mark Heckler. I'm a principal cloud advocate of Java and JVM languages with Microsoft. If you have any questions, comments, or feedback, hopefully we'll have a little bit of time at the end, but time is so short. And if you're like me, you think of the best questions or comments or feedback after the fact anyway. So please do reach out to me. Email works. Twitter is better. I'm also on Mastodon as well, but Twitter is kind of an ideal jumping off point. So let's, I guess, start there for now. A bit about me. I am an architect and developer by background, also an advocate, as was mentioned earlier. Advocacy allows me to do two of the things that I love the most, talk and code, and do it at the same time, which is always a treat. I am an author, a book author. I am a Java champion, Java 1 Rockstar, Groundbreaker ambassador, Kotlin developer expert, and licensed instrument-rated pilot, which gives me a little bit of a chance to see the world from a little different perspective, several thousand feet in the air, because again, this is US, so it's feet. But anyway, feet meters, it's all distance, right? So it gives you a little different perspective, and it's a lot of fun. Again, I actually had co-authored a couple of books with good friends of mine, loved it, had a great time doing it, but realized very quickly how much work was involved, even as a co-author. So I swore I would never write a book by myself, but questions kept coming up in my work, as well as, when I would be speaking at different places with different folks. And I just felt like maybe I could contribute to the conversation. So when the pandemic hit, I thought, well, I'm home anyway. Why not write a book? So this is out there. If you're interested in checking it out, I put all the code out there in Java and Kotlin. I'm actually borrowing a piece of that just for a data feed today. But if you're interested in finding out more, you can follow the book on Twitter or access the site listed and get a free trial to O'Reilly Safari Books Online if you want to just check it out, if you want to buy it. If you don't, it's all good. So the plan for the day, I love a good quote. And Leonard Bernstein, the former conductor of the New York Philharmonic Orchestra, once said, "To achieve great things, two things are needed: a plan and not quite enough time." And I think we have both of those today. Again, time is short here together, but we have a lot of time afterward to continue the conversation. So my purpose today is to start the conversation, and we can carry it on as long as we would like or need to. So a quick overview of what we're going to be covering today. First, a question that is very common is when to app and when to function. And one thing about our industry, about the technical field, is that in many cases, we actually don't start with the question. We start with a solution, and then we vigorously apply that solution to every problem domain that we run across, which is probably a terrible way of going about things in many ways. However, it does have the advantage of very quickly filtering out what is the appropriate problem domain to apply said solution to. So in many cases, we get a shiny new tool and we start pounding on everything like it's a nail, right? This looks like a hammer, everything must be a nail. And over time, we figure out that some things are nails and some things just really aren't. And that's kind of what maybe we'll discuss a bit before we start off. I think we do make that a little bit harder than it has to be, at least in the general sense, as we'll discuss momentarily. Then we'll talk about why Spring Cloud Function, why Azure Functions, why Neo4j, and then we'll just dive into the code, because most of us, I'm pretty confident, live in the code. So it's good to understand and establish context, but then it's good to actually see things as they unfold. So that's where we'll spend most of our time today together. Pardon me. So here is the simple version of the flowchart, if you will. Notice the bottom center, some caveats apply. This doesn't mean you can shut off your brain and blindly use this. It's very simplistic and simple flowchart. It doesn't cover all exigencies and outcomes possible, use cases, edge cases. But what it does do is give you, I feel like, a very good starting point. And from there, of course, you have to apply your wisdom, your understanding, your experience and expertise to determine if something falls outside of that more common path, right? So typically I look at a piece of functionality and I consider a couple things primarily, and then branch out from there. Is there a low time between calls? Meaning, if you're spending most of your time making those calls and in any time period, let's say 24 hours, because it's easy, it's a day. If you're spending most of your time making calls and there's very little time in between those calls, chances are that should probably be an app. Also, and kind of a corollary of that, if you will, is if these bits of functionality are long running. So if you make a call and you want to accomplish something and it takes 3 minutes or 30 minutes to do so, and you spend a lot of time in execution, chances are that you might want to make that an app as well. If you combine those two and you have very low time between calls and they're very long running, it's obvious that in most cases, again, I don't want to ever say 100% because there are edge cases in every potential circumstance, but in most cases that tends to lean heavily toward the app. If you're calling something sporadically, if there is a long time between calls, if it's called infrequently, that's really kind of the ideal use case for a function. And in terms of the function versus app debate, many times you're looking at cost factors as well, resource factors, but that's just kind of that rule of thumb that you start with. Now, again, no rule, that's why they call it a rule of thumb, right? It's not 100% applied to every circumstance, but this is I feel like an excellent starting point. And then from there, when you're dealing with something that doesn't fall neatly within that 80 to 90% of cases that you can quickly sift through that way, that's when you apply the extra vigor and rigor and look at ways to determine whether it should be a function or an app. So diving right into why Spring Cloud Function, why Azure Functions, why Neo4j? Well, I'm going to hit this fairly quickly too, but I do want to give it a little bit of examination individually and in a combined fashion. So Spring Cloud Function is a very, well, it's a Spring project, right? So it obviously allows you to leverage the capabilities of different Spring projects under the Spring umbrella. So things like Spring Data, Spring Cloud Stream, and various things like that. Webflux, if you choose. And Spring Cloud Function is in and of itself based on Java functions. So it's very close to the bare metal if you consider Java functions bare metal. In this context, we do, right? Because in its purest form, it's just taking one thing and doing some kind of a transformation and then providing that other thing that comes out the other end. And that's all that Spring Cloud Function does, other than it allows you to leverage things like auto configuration and other Spring projects that allow you to, again, focus on what you need to do first, increase that developer experience and give you extra superpowers without going through a lot of boilerplate and things that slow you down in terms of your velocity to deliver to production. So Spring Cloud Function is an excellent starting point. Spring Cloud Function, obviously anything you develop using Spring Cloud Function has to be deployed somewhere. Azure Functions is a very powerful capability, a very powerful deployment model within the Azure ecosystem. And folks who have made the strategic choice or one of their choices to deploy to Microsoft Azure platforms can leverage the power of Azure Functions very easily in combination with or without Spring Cloud Function, but they work extremely well together, as you'll see here, hopefully momentarily. Neo4j gives you the power of the graph, right? And I don't think I probably necessarily need to expand on that a whole lot because we're here at Nodes, right? But Neo4j allows you to get the power not only of the entity, the node, but also the relationships among them. So this makes for a very clean way to leverage the power of the graph, even if you're breaking things out at a lower level, more granular function level. Hopefully we'll be able to communicate at least a little bit of that today and start the conversation. And again, happy to expand on that later when we have more time after the fact. But with that, let's dive into the code, because I don't want to lose a lot of our time. Once we establish the context, it's good, again, to see it in action. And that's where I like to live anyway. So I'm going to go to the Spring Initializer. And I guess to give you a little bit of context in terms of what I have running, and I'll show you a little bit more about that later on. But I am using live data, and the live data that I'm using is a feed of aircraft that are in my particular area at this point in time. So I have a small device running on our home network called a plane finder, and you can get one of these and set up and log anything that's within range using an antenna and the proper protocols, etc. And I use that to feed a global model, so it gives you a kind of a picture of the global air traffic at any given point in time. But even if you don't run it with that, even if you don't have one, in my feeder application, I generate some sample data. So if you don't have that and want to run this app, it still works. And again, I pulled that from my book. It's a nice little application that feeds data, so I can use that in my presentations because live data is better than generated data. It's certainly more interesting, I think. And then I actually have the use case that feeds, because what it'll do is pull from any plane that's within our area, within about 200 miles of where it's located. And it feeds, it'll grab aircraft positions, which include information about that particular aircraft, its transponder hex code or hexadecimal code. And then it also gets the aircraft registration number. Here it's with the Federal Aviation Administration. So FAA tail number, they call it. That's the number that identifies the aircraft. And then it also pulls in the type of aircraft. And sometimes not all those fields are there, but certainly the transponder code is there, the transponder registry number. And then you have the position, the exact position at that point in time. So of course, this makes a lot of sense in many ways. If we were going to be pulling this regularly and tracking this like consistently 24/7, 365, you'd probably want apps. But what I wanted to do is create a scenario where we could do this dynamically, just when we wanted to, sporadically. And that makes perfect sense to have functions that we can use that to fire up a function and save the aircraft information as well as the position information, and then perhaps go back and do some analysis on that later. That's still in progress, but we've got the functions in place. So I have a position function that's already written and running, and I'm using a local version of Azure Functions to do that. I have the feeder application, which is just a Spring Boot application that's pulling this device on my network. And then we're going to together build our aircraft function, and we're going to work through that. And I'm going to show you kind of my very much abbreviated, but my workflow and how I develop functions. Again, I'm abbreviating this because we have such a short amount of time, but I'm going to show you kind of the distilled version. And I think it's incredibly useful to see how all these things work together and come together to allow you to develop functions quickly to leverage the power of Azure Functions, Spring Cloud Functions, and Neo4j. So I'm going to just change a little bit of the project metadata, create this at thehecklers.com. I'm going to create something I'm going to call aircraft function, and we'll call this our aircraft function. And then I'm going to use Java 17, jar packaging, and then let's add some dependencies. First, I want to add the Spring Cloud function dependency. I'm also going to, of course, add in Neo4j, and then I'm going to add in Lombok. Now, you don't have to use Lombok. You can just generate your domain class. You can use records. I'm going to use Lombok because I use it for a few other things as well, so might as well. But I'm going to save this down here on my desktop, and we'll open our project, and we'll get started with that. There it is. Okay, so desktop, and let's open that in IntelliJ. Now, I know I work for Microsoft. You probably expected me to use VS Code. I love VS Code. I use it probably almost 50% of the time, but many cases I still use IntelliJ. I love IntelliJ. It's a great IDE, and use what works, right? So, so let's start off here. I'm going to just open our POM, and we see that we've got, as we would expect, a few things in here. Now, I'm going to add one more thing because I have Spring Cloud Function context, but what I want to do at this point is to be able to have this execute and hold open, in this case, a Tomcat instance, so I can use this to respond, well, get requests and respond via HTTP. So not required in certain cases, in other cases, but in this case, I'm going to be using, I'm going to add this in so I can use that. The next thing I'm going to do is go to the application properties and just set my server port to 7071. For a couple of reasons. One, I already have one application running on the default of 8080, so we don't want port conflicts. And two, because when I switch this over to Azure Functions, Microsoft Azure Functions, it defaults to, when you're running it locally, port 7071. So it just makes an easier transition for me down the road, but that's configurable as well. So the next thing I'm going to do is just start off with our domain. And I'm going to create a domain class here called aircraft. And I'm I'm going to use Lombok to make this a data class, and then have Lombok provide a constructor with a parameter for each of the member variables that's indicated that is required, that it must be non-null. So I'll have things like our string ADS hex, which is again the transponder hexadecimal code. And then I'll have, let's see, the registration, aircraft registration, and their aircraft type. And of course, at some point, and not just yet, but what I'm going to do is make this a node, right? We'll get to that. I'm going to go ahead and put this in here now just in the interest of time. And I want to make this a generated value. So Neo4j will dutifully provide that for me. And then I want to make this a private long ID. So that's our node ID, if you will. The next thing we're going to do is go back here and start off with providing a bean. And this is what Spring Cloud Function relies upon, right? A function. I'm just going to receive an aircraft and turn back around and reply with an aircraft respond. And this isn't really a transformation in this case. It's more like an echo. Again, in the interest of time, this is going to be very simple. So I'm going to grab the aircraft and return the aircraft, right? And that's okay. I mean, typically you do some kind of a transformation. So you might do something like this, a dot get the hex, a dot get the reg, and a dot get the type. But regardless, this should work. So let's find out if this really works. And again, this is kind of the path I follow, greatly distilled. So I'm going to start this up. And once this is running, we actually have the application running here in the background screen. I have my position function running here. And then let's go ahead and start this. And I will just use HTTPy to hit the aircraft endpoint and see what's flying around in our area. Okay, so we see that we have a response. And the way I've written this, just for the ease of demoing, is that it prints out everything, it logs everything that it has, and then it shows any aircraft response I get back from the aircraft position or aircraft function, and then it shows the positions I get back from the position function. So if we go here and look on this side, well, I didn't log it, but we saw that it worked because it returned the value properly. And that's one way to get started very quickly with Spring Cloud Function. Now that's one mechanism you can use. What I also can use is for Spring Cloud Function, another way to do that is to just create a component. So echo, we'll just call it an echo class, right? And we're going to implement a function, again, accepting an aircraft, returning an aircraft, right? We're going to make this a component. So again, this is a bean. And since we have the code, it makes sense to define it as such, right? And it's telling us that we must declare this abstract or implement an abstract method, and we certainly want to do that. So I'm going to implement the apply method, and then we'll just do this. And actually, I need to change this really quickly. And of course, we can do this. There we go. Return new. There we go. I get ahead of myself. And that should work equally well. So let's go ahead and do that. And actually, before I do that, what I'm going to do is just make a few changes here. So aircraft. That way we can see what's going on. Return aircraft. It's always nice to get a little more visibility into what's happening. So I'll restart that. All right, that's up and running. Let's go ahead and try that again. We see that it works again, and we see that we're getting back something now. We're showing what we're actually doing before we send it back, I should say. And then, of course, if you check here, we can verify that, yes, indeed, we're getting back the aircraft in the area and the positions that they're reporting. So that's all good. So far, we've gotten Spring Cloud Function up and running with very little effort, right? I mean, this has been pretty painless. Now, what do we do to actually get those values saved? I'm already saving the position information, but what I really want to do is save it all so I can associate it and get some insights into the relationship and what happens over time with a particular aircraft. So what I'm going to do now is just add our repository or define our repository. We'll call this our aircraft repository, and this will be an interface. And, well, let's see if I can change that, because I just noticed, oops, wrong ones. Okay, so I'm going to just do this, refactor, rename. Typos are a bad thing. Refactor, there we go. And I'm going to extend our Neo4j repository. We're going to be storing objects of type aircraft with IDs of type long. And then, of course, if we go back to our aircraft, we want to make this a node, right? So we uncomment that. And then we uncomment these 2 lines. And we import that. That is a Neo4j ID. And of course, we want to do the generator value the same way. And then if we go to our echo function, what I want to do here is just inject our aircraft repository. And once again, since I'm using Lombok, I can do this and just have Lombok provide a constructor that incorporates a parameter for each member variable. In this case, it's just one, so all args. And that gets us what we need here. We can just do a repo.save of our aircraft. And voila, we're up and running, right? Or should be. Let's find out. So I'm going to save this. And since we're actually, what I need to do in order to access Neo4j Aura DB is I have some environment variables set. So I'm going to run this from the command line at this point. So let me go into that. And then if I do a Maven Spring boot run, you can see that this is very developer friendly. I mean, everything I've done has been super simple to do. I know I'm going at a kind of a fast clip because of our limited time, but it's pretty simple. And once you get into a routine of this, even doing it all manually like I am here is fairly easily done. So I'm going to go ahead here and we'll access this one more time. We see that, we have an ID, which is null. Oh, that's because I actually am getting that back. So let's see. Oh, I'm printing it out before I get that back. Ha, never mind. Okay, so that's why, because I'm actually printing it before I get that back from being saved. But if I go here, oh, I'm not returning that part. So yeah, so if we want to make that a little clearer, what I can do is just do this. Yeah, let's do this. Let's just move this about here. Repo.save this. And we'll introduce local variable there, aircraft. Aircraft, there we go. And then we'll print that out and we'll return aircraft. And it should work. All right, so let's try that again. Always good to see things live and in real time. We're up and running. And there we go. So everything works. And of course, we knew it would because things never fail in live demos. Okay, so far we have Spring Cloud Function working, and we have Neo4j. Everything is being saved in Neo4j. So now how do we make that transition to our deployment environment? And that would be Azure Functions. And that's pretty simply done as well. I mean, Spring Cloud Function works brilliantly with it. That I need to do a few things to set it up first. Now, I could add in these things manually to our POM file, but of course, and that's a little tedious. That's not even really coding. It's just YAML, or excuse me, XML, right? So, which is similar to YAML, I guess, in a ways. It's a lot of brackets or braces and or should say, anyway, it's a lot of values here that we're putting in and indenting. So what I'm going to do is cheat a little and copy paste that in. But what this involves is a few parameters here that I'm adding, a few properties. And then if I want to just verify everything is the way it should be, I can do this and add that. And yeah, that all works. We know that we're going to be storing a few things here in source main Azure for our properties. So we also have things like what our plugins we need to add in order to deploy this locally to a local instance running Azure Functions, or deployed to Azure for real in the cloud to run. So there are a few things that we have here, but we've got the build file set up now with the additional dependency and the additional plugin information. The dependency is literally just this: the Azure Functions. The Spring Cloud Function adapter for Azure. So what I'm going to do now is just create a couple of property files. And these aren't, well, in one case, there is some essential information there. But most of it is just optional information. It just cuts down on the noise when you're running it and adds to the specificity, if you will. So I'm going to create a directory called Azure. I'm also going to create a file called host.json. And within that, I'm just going to have the version here of our functions, which is 2.0. Again, that's the only value here, so that's not technically required, but it's, again, very good to specify because there are different versions you could potentially deploy to. And then I want to create another file called local.settings.json. And here I want to add just a couple of parameters. So is encrypted, which I want this to be false because I want to be able to access this from anywhere by anyone in this particular limited set of circumstances. And then I want to provide some values. And the values are just the runtime, which is Java, and then the main class. And what I want to do at this point is just go to my application and grab the package right there, local, and paste that, and then go back once again and grab the application name and add that. And it's pretty simple in that regard. The next thing I want to do is create my function invoker. So I'm going to call this, so since we have an echo function, I'm just going to call this the echo invoker. I'm then going to extend the function invoker class here. So we'll receive aircraft, will supply aircraft. And part of what I want to show is the simplest way and some of the shortcuts that make it a lot easier to get started. And one of the things that I can show you that I think is kind of useful is this HTTP trigger. If I start to put this is not where you'd put it, but by simply typing it and then hitting B, you can drill in and see the hints that are provided by Oleg Zhurikovsky and his crew. Oleg's a good human being and has documented this very nicely, so it seems a shame not to use it. So I'm going to just paste this in, and we'll make a few small changes and get up and running. So I'm going to change this to AC, because this is our aircraft function, and I'm just going to import all of the unknowns here. I'm going to change this from returning a string to returning an HTTP response message. We'll just call this echo it. Why not? And then what we have here is we're using an HTTP trigger, since we're going to be using HTTP to provide or to be able to listen to and respond. So there we go. There we go. And we're going to return an aircraft. I'm also going to include as a parameter here the execution context, and because we're going to use that as well. So the first thing I'm going to do is just create an aircraft. We'll call this, again, cleverly enough, aircraft. And I'm going to use the request coming in, get the body. I also want to filter this because occasionally there will be some bad data coming in. And if the hex code is not equal to null, then it's good. Otherwise, if there's no correct body, if there's no ADS hex code, what I want to do is just create a supplier to supply us a new aircraft, just some dummy data. And I'm going to provide a dummy hex code here. The registration number we'll just make up 98765. And then we'll have a type of unknown, since we don't have any idea what possible kind of aircraft this is. And then I'm going to return the request. I'm going to use that to create a response builder with an OK response. And of course, I'm going to provide the body, and I'm going to use the handle function, or handle request function method, I should say, that's defined within the function invoker itself. I'm going to provide it the aircraft. I'm going to provide it the context, and then I'm going to supply a header. In this case, I want to specify a content type. And again, these are optional things, but I find them extremely useful and helpful within the context I'm developing. And then application JSON type, and then let's build it. That, as they say, should be that. That's all that's really needed, is this invoker, so that Azure Functions knows what to invoke. And in this case, it's going to go ahead and invoke this function, and it'll work the same way it has, hopefully, that's the plan anyway, the same way it has using Spring Cloud Stream. So I'm going to go out here now to our function. I'm going to rebuild it, Maven clean package. We'll see if I have any errors. Of course not, right? No errors, ever. And then I'm going to, have to try to be optimistic here. This is a live demo. And then I'm going to go ahead and do, yeah, so far so good. That's looking positive, right? And then I'm going to Maven Azure Functions run. And this will take a moment. I'm running this locally. Of course, it's the same thing if you want to deploy. Instead of doing a Maven Azure Functions run, you do a Maven Azure Functions deploy. And based on the information that you've already specified in your POM, it will deploy. So in this case, it would, in my case, if I deployed to, let's see, POM, where did I lose my POM? There we go. If I deployed to Azure, it would use this resource group to place this function in. It would use the AC-fun as the function name. It would place this in the East US region. You always want to be closest to where it's going to be executed, right? In my case, that would be East US. And of course, you have the information like the start class and so on and so forth. Now, I do want to show you, while we have just a moment, what's going on in front of this. So let me bring the application over that I'm using as a data feed. And I am just referencing the local device on my local network to grab the aircraft that's reporting a position at this point in time. And then I'm using two different web clients, reactive web clients, to connect to these different functions running on different endpoints locally in this case. So I've got a position endpoint, a position client that's going to access our position function, and our aircraft client that's going to access our aircraft function. And then each time I get a node, each time I get a position for an aircraft, I split that out. I post the aircraft to NEO in an aircraft node, and then I post the position to a position node. So that's a very quick look at that. And of course, we should have this up and running, or nearly so by now. Let's see. So yes, it is already up and running. So let's go ahead and try this. Everything is working fine. You can see that it's running Spring Cloud function. It's going ahead and returning those as expected. So with that, boy, our time is short. So let me go ahead and just to give you a quick look, if we go over here to Aura DB, actually I have this already open, assuming it didn't time out. And if I want to run this, we see that we now have 992 aircraft logged in there. It was 876. So we have several aircraft flying over at this point in time. Good to log those, right? So with that, again, time is short. Let me go ahead and wrap up. If you want to know more, the actual meta repo is at GetFunctional under my GitHub account, github.com/mkhackgetfunctional. And that will point to the component repos, right? The aircraft function, the position function, and the feeder application. If you have questions, comments, or feedback, once you check that out, and by the way, I would encourage you to watch and star the repos because I will be making changes as I develop this and continue to develop this. If you have questions, comments, or feedback, email is great. Twitter is better. And the Spring Boot book also has a Twitter account if you'd like to follow that and check it out. Thank you for coming. And with that, I think we have like 2 minutes left for questions. If you have any questions, fire away now. If you think of them later, by all means, don't get discouraged. Just reach out to me. I'm happy to answer them. With that, Yolande, I think we have it.
Okay. Do you want to? Can you see the comments and the questions?
Hold on. Let me find out. Comments. Yes. All right. Okay. So let me. Oh wow, there's a lot. Oh dear. Okay. So let me. No, I scrolled back too far. Oh, good. Okay. So that's fine. Let's scroll down through here. Yeah. All right. Hi, Scott. Hi, Michael. Good to chat with you both. Awesome quote. Yeah. I love a good quote, right? And some of them just really, they nail it. It is live. I'm live. I think I'm live. But yeah, it's all live and it's, yeah. So, and it all worked. That's a win-win. There is a repo with the full code. Absolutely. GetFunctional will take you to the meta repo. It just has a README and links to the other. I sometimes do a nested repos, but I find that folks sometimes get a little turned around on those. So I just put links in there this time. Yeah, it is live. I just went up to that again. It is too fast to replay the code in IntelliJ. Yeah. So by the way, please do feel free to take pauses. I actually will try to break things out a little bit better over time in the repos where it's easier to see the steps as we go. But I do try to just comment and not delete code as I go, just so you can reference that later on as well. And YouTube, yep, get functional. Yeah, I guess should be a workshop. I'd be happy to do that sometime. So we just need to make that happen. By the way, everything that I showed, there are many ways to get there from here. There are many paths. I just like to show the simplest, fastest path because I think that's a great place to start and build out from it. So if you have a question about something I did, maybe I took a little bit of a shortcut, happy to explain why and maybe other ways to get it done in a more maybe production friendly way. I don't know, but there are certainly other ways to get there. It's just a what I feel like is the shortest path and the most comfortable path to show, to repeat, and whatnot. So I guess that's it. Let's see. I might have missed it. Are there life cycles? Yeah, I mean, that's another whole topic for another day. They're also like, and tied in with life cycles, there are default run, durations and things like that. I should probably add to some of those resources to my ending helpful resources. But if anybody wants to check those out, I'll look up and paste some of those into a tweet here in a little bit. So check me out on Twitter. That's probably the easiest way. Email is 1-to-1. Twitter is kind of 1-to-many. So follow me and I'll share more later.
Yes, I totally recommend following Mark on Twitter. Very active and very responsive.
It's fun. Or Mastodon, but I find that Twitter is kind of the still, and who knows, but still the kind of the central place for people to get together and chat with hopefully a minimal amount of noise. So
that's true. Thank you, Mark. Thank you so much for all that content. That was wonderful. So
thanks for having me. Always love to hang with the gang. So
take care. Bye-bye.
Bye now.
Okay, so we are taking like 3 minutes break, and then we'll have our next speaker, who will be Jason. So stay tuned. Okay, so welcome back. So our next speaker is Jason. Hello, Jason.
Hi, Yolande. Hi, everyone.
So take it away.
Cool. Awesome. All right. Hi, everyone. Welcome to our beginners session on graph databases for Python developers. As many of you know, if not all of you know, the creator of the Python language, the esteemed Guido van Rossum, created the Python language and named it after the BBC comedy group Monty Python. Now, this group went on to create the iconic movie Monty Python and the Holy Grail, which follows the comedic adventures of King Arthur and his merry band of knights as they attempt to find and retrieve the Holy Grail. Now, early on in the movie, there is a scene where a famous historian is tragically cut down by a mysterious knight. And at first, this seems to be kind of a throwaway scene, but as the movie progresses, they keep coming back to the scene of the murder, and additional police and investigators start showing up, and they start trying to figure out who had killed this historian. And this culminates toward the end of the movie, where right before the climactic battle between King Arthur and his knights and the French garrison at a castle which presumably has the Holy Grail, right before this fight begins, or just as it's beginning, a convoy of police cars shows up. Police come piling out, and they arrest all of King Arthur's knights and himself. So this has never been explained as to how the police decided that it was King Arthur or one of his men that had committed this atrocity. But I like to imagine that on the cutting room floor somewhere, there is an entire CSI episode's worth of crime drama where the police and investigators are diligently going through the crime scene, investigating people in the scenes right after King Arthur had gone through, and stitching together what had happened to this historian. And I like to imagine, as in most CSI episodes, them using a crime map or an evidence board. And this Hollywood trope is fantastic, right? Because it takes disparate pieces of data, a photograph, a piece of document, and connects them with all these red lines. And these lines aren't even like notated. It's just the audience just knows what these lines mean because the movie prior to seeing these crime boards already gave you the context from which you're looking at this board. So you can gauge whether like, oh, this person knows this person or this person is related, right? And the other reason I really love evidence boards is because these lines connect all these disparate pieces of data, it becomes a network, right? And a network is just, another word for a graph. And we're here talking about graph databases. Okay, so evidence boards, how is that important to a Python developer? Well, according to Gartner, the vast majority of upcoming data and analytics innovations will come from graph technologies like graph databases in just the next few years, right? And so the people most interested in these technologies is going to be your data engineering teams, and probably you as a Python developer as well, even if you aren't specifically touching the same things that these roles are. Or maybe you are one of these people, right? A data analyst who's going through information in a BI tool, the data engineer who's creating a pipeline for all this information, or the data mad scientist who's looking at all this disparate data and trying to glean new insights for moving the business forward. Okay. And supporting this prediction by Gartner is this great graph-friendly chart from DB Engines, which shows the increasing popularity of graph databases compared to other databases. Now, just as a point of clarity, this chart is showing the increase of popularity of a given technology against itself over time, right? So as time progresses, graph databases become even more popular than it was previously. And so this is not a comparison of today, like, who's using what technologies. Obviously, our DBMSs are at the top of that pile. Okay, so now that we have kind of an idea of why graph technologies, graph databases are important, what exactly is a graph database? Like, how does it work? Okay, so in summary, graph databases are one of 4 broad NoSQL database categories, right? We have documents, key values, column family, and here I've got a short list of the famous companies and technologies that represent these other NoSQL database technologies. Okay, so graph databases internally are differentiated from these other databases in how it stores data. Right, so you've got a node, which is an object, and it's related to another object, right? So think of a node as maybe like a row of data in a table. And that relationship is stored as a first-class citizen inside a graph database. So this sort of relationship is typically a join in like an SQL a query, but in a graph database, it's already part of the data store. So you can traverse through information very, very quickly. And on top of that, both the node and the relationship can have properties associated with them, right? And so when you can have a node that has a name, a title, a date, you can have a relationship that has some sort of weight or other information if you want to add that as well. And when you do that, this becomes a property graph, right? So this is a type of graph database. Okay, now general pros of graph databases. Again, you don't have to do the typical SQL joins, and schemas are optional. Of course, having indexes or constraints will dramatically improve your query performance, but they're not hard set requirements. So when you're initially setting up, or if you need to iterate, it's much quicker to iterate on a graph database because you can reassign nodes, you can shuffle things around without having to kind of peel apart all the guardrails before putting it all back together, right? And again, since the relationships are first-class data citizens, and you can traverse the data fairly quickly when you attach a graph database to a visualization tool, you can do some amazing discoveries just by perusing your data, right? So for example, say we've got the movie The Matrix. We want to do a really complicated Kevin Bacon game. So let's find the relationships between all the main actors in Monty Python and the Holy Grail and all the main actors in The Matrix. Are there any movies where they're working together? Like what is the tree of relationship between those two clusters of actors? And when you run it, and this is accurate as at least up to 2016, we can see here that none of the main actors from Monty Python or the main actors from The Matrix ever worked directly together in a movie. But there is this long, thin line of actors that are intermediaries that know or have worked with both sets of actors. Right? One of the most interesting ones is at the very top, which you probably can't see, but it's Sean Connery, who had worked with Terry Gilliam on Time Bandits and also with Lawrence Fishburne in Just Cause. And there's another interesting one with Gary Oldman there. But anyways, you can see all these paths visually just by looking at the result from a graph database. Okay, some downsides, or kind of one major downside, is if you are just doing pure transactional data, right? You're just logging tons and tons of data, and you have no intention of analyzing or acting upon that data in the future, graph databases aren't going to be of benefit, right? There's no reason to use a graph database where another database solution is probably going to be much better for this scenario. Okay. Another way to look at when you might want to use a graph database is this. I love this chart from Manning Publishing. I think it's Intro to Data Science. Okay, so on the y-axis, we've got the amount of data that you're dealing with, right? From small to a very large amount of data. And then the complexity, how interconnected is the data that you're working with, right? From very simple on the left to more complicated on the right. So you can see on this chart, if, like, hey, I've got some project and I'm just storing mad amounts of data, more than my current SQL option can handle, go look at a key value store, maybe a column family. But if you're dealing with lots of interconnected data, say lots of different systems, then you should consider a graph database for your solution. Okay, use cases. I'm not going to spend too much time here because every session here at Nodes is basically a use case. But I will highlight one, which is the Panama Papers. And the Panama Papers, I love this story. So it came out about half a decade ago. This is what initially introduced me to Neo4j, well before I started working here. And what the Panama Papers was, in general, if you haven't heard about it, was the ICIJ, the International Consortium of International Investigative Journalists, got this huge data dump from someone at a bank or a law firm. And in this information was this giant global financial conspiracy. And it was just too much for the ICIJ to kind of figure out. So they built a system on top of Neo4j that allowed a bunch of investigative journalists around the globe to work together and piece together the evidence to figure out who was who. And when they revealed the story, lots of people were fired or prosecuted. And I think 2 congressional acts came from this to help bolster the financial system against this type of fraud that they had detected. Okay, I'll skip past this. Okay, major players in the graph database space. So according to DB Engines, again, the top 10 graph databases are, as you can see here, and you can see Neo4j and Microsoft's Cosmos DB rank really high according to their scoring mechanism. Now, I don't know what their magic algorithm is, but they supposedly take information coming from Google Search, LinkedIn, Bing, a few job search engines, put this all together into their magic cauldron, mix it around, and they get this wonderful ranking system that Neo4j does really well at. So if you're in Greenfield, you don't know which graph database to start with, I would start with this list and move from there. Okay, now those 10 databases can be roughly broken up into 3 general categories. On the far right, we talked about property graphs already. Now in the middle, semantic graphs, these are a little bit different than property graphs. So unlike property graphs, you can't store attributes to a given node or relationship like directly. Like they're all triples, right? They're all using this subject, predicate, object for subject, predicate, value system, right? So if you have an object that represents a movie, one of the connections would be predicate would be like the name of this movie is string value, right? So you can connect nodes with values or other objects, right? So one would be relationships and one would be like basically a property of a given node. Okay, that's a semantic graph. The last broad category are multi-model databases. Now, these databases basically allow you to have a wide variety of incoming data sources, right? So you could have JSON files, CSVs, you could have other graph databases as a data store. And the idea, and in an ideal multi-model graph database, is you'd have one query language that would be used to traverse all the knowledge in all the different mediums. Now, a multi-model database is very top-heavy, so they can be complicated to implement, but that is an option available. Okay, so now these 3 broad categories, if we chop up those top 10 databases, they fall into these categories. The categories I would not say are like super sharp. You know, some databases kind of drift into other categories and they have functions that allow them to do things that other databases do. But roughly speaking, you can see that they spread kind of evenly across these three categories. Okay, now even with just these 10 databases, as you can imagine, with each one of them, not all, but most of them having their own query language, we unfortunately get a giant zoo of different query languages that you could use to query a graph database. Now, fortunately, there is a working group from some of those graph database companies, including ours, and a few academics who have gotten together into a working group, and they are trying to create an ISO GQL standard, a graph query language standard. And fortunately, they already began a couple of years back. They're about halfway through, and hopefully in the next 2 years, maybe 1.5, they will have a standard out for the market, for the community, for all of humanity to use one sort of standard for querying graph databases. Okay, now GQL, graph query language, should not be confused with GraphQL, which is a REST alternative developed by Facebook, a few guys at Facebook a number of years ago. It's a great protocol, but it is not for querying graph databases. Sort of. I mean, you could use them to query some data from graph database. So like dgraph, which is a graph database, their entire query language is just using a variation of GraphQL. But GQL and GraphQL are distinctly different. Okay, if you're interested in learning more about GraphQL, there was a session I think running concurrently with this one that Will was doing. But there's another talk later, much later. So if you're in the West Coast like me, there's a talk by Thomas who will be talking about Neo4j GraphQL library features. So he'll be talking at 1 GMT, but 5 a.m. Pacific. So if you wake up very early or do not sleep at all, then you could check that one out, or just watch the recording. That also works if you are not waking up that early. Okay. All right. So GQL. Back to GQL. these are the 10 query languages that they are considering as source material for deciding what the future GQL will look like. I am not proficient in all these languages, nor do we have time to kind of go through all of them, but do know that there are differences between each language. Each has their own strengths and weaknesses. But since we're at Nodes and Neo4j had helped develop OpenCypher, I'm just going to talk about Cypher. Cypher is a declarative language, and it is very ASCII art-like, which I'll show you in just a minute. And it's open source. So it was open sourced, I think, shortly after it was originally created. 2015, I think, is the official open source date. Okay, so to show you what the ASCII art looks like here up on top is an example query, right? So instead of select, which you would have in SQL, we've got match. And here we've got things. We got variables and nouns in parens and brackets. Anything in a paren is a node. So the first part of this pattern, we've got person, and we want to, we're doing a dash to a bracket, a relationship with the type called acted in, to an arrow to another node, movie. So this is just a general pattern, right? We want to find people who acted in a movie. And then we've got a filter using the where keyword. So we're just looking for movies that have the title The Matrix, and return me all the names of these people as a list. So if this query was sent to me and I am a Neo4j instance, I will spit back out this list of names, right? Lawrence Fishburne, Keanu Reeves, Carrie-Anne Moss, Hugo Weaving. Okay, simple use case. Now, a more advanced use case, but still similar. This is only one of several ways you could do this, but this is a query for getting that graph database or graph subgraph that I showed you earlier between showing actors from The Matrix and actors from Monty Python and the Holy Grail. So here we're just doing several match statements, right? So we're finding two sets of people acting in a movie, because we're going to check for a different movie, and then find the shortest path between that clump of actors with the other clump of actors. And filter, I'm just putting in two titles. Monty Python, it should say Monty Python and the Holy Grail, but it made this very long, so I just shortened it to Monty Python. So anyways, you run this and you return the two nodes for the two movies, so you can kind of see it all connect, and then the path, right? And so a Neo4j instance will put this out, and you've got a graph where you could peruse to your heart's content on what the actual connections between the main actors are and actresses. Okay, so there's an example of Cypher. If you want to play with Cypher yourself, Neo4j has a great sandbox environment with many preloaded data sets that you could peruse through. One of them is the movies recommendation, which I was showcasing. But we've got things like Stack Overflow, Twitch is in there. There's a couple of fraud detection information. And there's also, if you watch some of the YouTube videos from Alex and Michael, they've gone through tons of data and put it into repos that you could just kind of load in yourself and play with. Okay, so this is an option if you want to play around with Cypher. Another option is if you like to learn through kind of more of a narrative style, I suggest looking at Graphville. This was a new education site that was created by Vlad, who also will be giving a talk later. So tomorrow from here, so 8:50 a.m. Pacific, 4:50 GMT, also on the beginner track, and he will talk about have a lightning talk talking about how he created Graphville. Okay, Python tools. All right. Here's the good stuff. Okay, so I'm just going to quickly kind of go through the different toolings that we have available for Python, or not just us, but community and other third-party services also have built a number of tools and services to allow you to kind of build on top of all the graph database goodness that has been built. Okay, so the first thing I'm going to talk about are the drivers, which is built and maintained by Neo4j. First one is the core driver. And this driver you can throw into any other Python framework, right? You can throw it into Fast API, Flask, you can put it into a Streamlit app, which I really enjoy doing. And the big thing to remember with the driver is the current version is it uses transactions and sessions, right? So sessions manage, a given query connection, and it will retry automatically for you if the transaction fails. And transactions are basically static functions that have the query kind of baked in, and you're just passing in arguments if you want. And this is the block that gets retried if the session fails for some reason. Okay, if you're interested in seeing this work with Streamlit, David is giving a presentation tomorrow at 8:10 in the morning Pacific on the intermediate track, rapid app prototyping using Streamlit and Neo4j. The next driver I'm going to talk about is the GDS client library. So if you've got the GDS package running on a Neo4j instance, you can run the GDS library. And if you're building a Python app and you want to connect with some of those features, the GDS client is a good option to go with. And you can see here, gds.run Cypher. So this client is built on top of the Python driver. So it will run Cypher, with this command. You can just pass in a Cypher string and run it just like you would the driver. So this generally has kind of a cleaner look. But if you use the GDS client to run Cypher commands, the results you get back will come back as a Panda data frame. So just be aware of that. If you're not intending to use the result as a data frame, like you want an actual object, then this may not be the route you should go. Okay. And fortunately, this is a great thing about having a talk early on is there's all wonderful talks happening after me that can extrapolate on the stuff that I touch about. So on the advanced track, Matt is talking about the fundamentals of the graph data science library system and pipelines. And so he's going through a whole bunch of stuff. So if you're interested in GDS, definitely suggest you check out his talk at almost 1 a.m. Next morning. So a couple hours from now, well, 6, 7, 8. Okay, moving on. Okay, so if you don't want to write Cypher in a string and then throw that into a driver, you can use a query builder. And there are a couple of query builders out here. The two I'm going to talk about is Pyfer, which has been around for quite a while and is quite mature. As you can see here, you're making Cypher commands as functions instead of writing a Cypher string and then putting that in. Okay. The great thing about their package is they have a kind of an app that goes with their repo that allows you to put in a Pyfer function call and see what the actual Cypher is. I don't know if it'll, destroying my own glasses. I don't know if it will go in reverse. So I don't know if you put in Cypher command and it'll give you what the Pyfer call will. So be aware of that. Something worth trying out. And the next query builder is Simple by some folks at Accenture. And it is, again, it's a query builder. So you can see here that it's very similar in terms of making function calls in place of making Cypher string calls. And what I like about Simple is they made it so that when you run it in Visual Studio Code, maybe IntelliJ as well, you get auto-completion, right? Auto-completion, love it. Who doesn't love auto-completion? And also, the creator, or one of the creators of Simple, Roe, is giving a lightning talk on that tomorrow at 5:40 a.m. on the beginner's track as well. Okay. Yes, I was just thinking, how are you? This is all in the schedule, so I'm just kind of highlighting that these talks are coming down the pipe. You don't have to. Probably difficult to write all this down very quickly. Okay. All right. Second to the last thing I want to talk about are OGMs, object graph mappers. So if you don't want to learn or use Cypher at all, you could use an OGM instead and just use it to create and retrieve nodes and relationships. These can be very powerful. GQ Alchemy, created by Memgraph, works with both MGraph and Neo4j databases. And they also have a query builder built in, so you can kind of use it for both if you wanted to. Okay, the other OGM is NeoModel, built by our community. And the great thing about NeoModel is there is already a Django plugin that's available. So if you're a Django developer, you can just slap that in and you got an OGM ready to go. So here you can see you just got a sample of how you would define the nodes and relationship classes. And then right here, just one quick example of how you would retrieve nodes, right? Person.nodes all or person.nodes get, and then give it some parameter to find the specific nodes you're looking for. And we don't have anyone, I don't believe we have anyone giving a talk on NeoModel or GQ Alchemy directly, but later tonight, Estella is going to talk about a personal project that she's done she's built her own OGM. So if you're interested in OGMs, that talk may be super insightful for you. Okay, so last bit of tooling I wanted to talk about is two things. So visualization tools, right? So if you're using Jupyter notebooks, as many Python developers in data science at least use, you can visualize graph database results in a Jupyter notebook. And one example is from YWorks. They have a thing called Y files. So you can put this into your Jupyter notebook, and you can visually interface with your data. And fortunately, at I think midnight tonight, Pacific Standard Time, anyways, Sebastian, who works at YWorks, will be presenting on exploring your graphs with Jupyter notebooks. So that's perfect segue there. And the last visualization tool I want to talk about is NeoDash, which was built by a few folks here at Neo4j. And this is a great tool. So when you spin this up, you get basically this blank canvas with the ability to add all these widgets. And when you add these widgets, they're pretty much they're pre-built for you, except you can tweak the underlying Cypher command that's used to retrieve the data. So you can change the data, you can change the calls to match your specific domain. And there is just a huge host of widgets for you to choose from, right? As you can see from here, you got a number of different charts. You got a map that you can put pins down. You've got a graph visualizer. Yeah, this one's a great way to get some information into a dashboard up and running very quickly. And for NeoDash, we don't have just one. We got like 2 upcoming talks that are talking about it. The first one coming up is by Deckel, excuse me, who will be talking about its use in Bloodhound for a community-driven security thing. I should have researched Bluehound more, but he's doing this talk, so check that out. And then also Neil, who is one of the creators of NeoDash, will be giving a talk tomorrow morning on visualizing geographs with NeoDash. Okay, I think that's the end of my scan of Python tools that may be of interest for a new Python developer. And here's my entire presentation as an evidence board. Because I love evidence boards, I don't know why, but it just succinctly kind of visualizes everything, although we don't really have a victim per se here. But anyways, if you have questions or want to reach out to me, I'm available on LinkedIn, which is where I'm usually at most of the time. I do have a Twitter account, which you can tweet corrections or funny jokes at me, or anything that you desire. But anyways, okay, so that is my presentation. I will now turn my eyes to any questions that may have popped up. Boop, 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 boop. And let me go all the way to the top here. Let's see. Okay, here we are. Okay. It's just a flash one. Yes, the Black Knight. Monty Python CSI. Totally agree. We should totally make that happen. Is it going to relate to Python? I hope it related to Python toward the end. Digital humanities and social sciences show up over and over in graph database use cases. Yes, true. Let's see. I'm going to now scan for question marks. Okay, here we are. Are Neo4j Cypher and OpenCypher different? Yes, and someone can jump in if they know better, but I believe they are, but very subtly. They're not, I think generally we try to match the OpenCypher spec as best as possible. Should have called it GDQL. Yes. The whole naming drama with graph databases and query languages is there's many ways it could have gone. GraphQL can be used to DDoS your backend by accident. Oh, that's good to know. I guess you could find some way to DDoS everything. One example of Dataform. Dataform. Not familiar with Dataform. So I will have to get back to you on that. Python is 20 times slower than Java. Yeah, Python isn't known for being a fast language. It's generally, it's known for being an easy to use language. Although, with version 11 that came out, it's what, 40% faster without you needing to do anything. So, they're working on it. Oh, thank you for the links, Jeff. Okay. I think I've got all the questions. Oh, how close will GQL be deciphered? That is a great question. I wish I was a fly on the wall or had like a security cam on some of their talks. I have no idea which direction they're going at the moment, or what they've thrown out, what they've kept. So if anybody knows anybody on that group or knows where they might be listing that, because I think on the GQL site, so there's a website that the GQL group is maintaining. I don't believe there's like a meeting minutes. At least I didn't find one. So I unfortunately don't know the answer to that, Roy. Okay. All right. If there are no other questions, mostly based on Cypher. That's awesome. That's great. Okay. If you have any other questions, you can put it in chat and I'll answer it later. Otherwise, thank you all very much.
Thank you, Jason. Thank you so much. So we are going to take like a short break, and then before the Q&A that everybody's waiting for with our CEO, Emil. Thank you so much.
Right.
Wow. Okay, well, everybody, welcome America, welcome the world to Sweden. Welcome to the Neo4j offices here in Malmö, Sweden. I'm sitting with Emil Ephraim, the CEO and founder of Neo4j. And in the next 20 minutes, we've got some time for you to ask this man some questions where he will provide answers. Some of you have already provided some questions in the poll that we have running on the platform right now. And to help you figure out how to do that while we're getting going here, I'm going to switch to the slides. But first, Emil, do you want to say hi to the people?
Hi, fantastic. Great to be able to join you all. I've been trying frantically to check out the sessions and be on Hopin. It's super high quality so far. So excited to be here.
It's been absolutely an amazing day. So
Yeah.
Can't wait to get into these questions. I think this will be fun. A good way to wrap up the first session. Okay, so first we're going to hop into some slides, if that's okay, and take you through what we're about to do. It's a simple Q&A with Emil. And here's how it's going to work. First of all, that's Emil. Hi, he's Emil. And hi, I'm Andreas.
And what do we usually call you?
And for those of you in the know, you call me ABK. You can still just call him Emil.
Yes.
Okay. If you want to participate, if you've got some questions you want to ask for Emil, please go to the tab that you see here. First, go to the reception tab on the left, and then on the right, you'll end up seeing a tab next to polls, people. You'll see Ask Emil. Click on that, and then just type in your question, or please upvote any of the questions that you see there that you think are worth asking. We've got 20 minutes to run through them. We'll see how many we get through, but please, the more participation, the better, okay? That's it. That's all I've got for slides. Now back to live. And all right, so this has been a huge day. There's been a huge amount of material. I love some of the questions that have already come up, and I'm going to just switch over to the what we've got coming up here at the top already. And this is interesting. This really gets to what are graphs all about, and what are graphs? What is the potential of graphs in a way? So this first question that's been upvoted really well is, what is a domain you think is ripe for leveraging graph technology, but has been slow to adopt?
Yeah, such an interesting question. So by kind of way of background, I'm one of the co-founders of the company. We started the company in 2007, right? And we've been working on the technology forever. Initially, I was one of the 2 kernel developers, right? And then I did all of the API design for a while, and then I did all of the documentation and the unit. I progressively flowed kind of out and out and out in the outer rings of the architecture, right? And then after a while, the job became kind of less building the product and more building the organization that built the product, type of a thing. And keep me honest here, in 2010, we grew the team from like 5 to 10, and that's when you joined.
That's right.
Is that right?
Summer
of 2010.
I was employee 10. That's
employee
right.
10.
Yeah.
There you go. Perfect. So that's just a little bit of background, just to give context on who I am and who ABK is. And we've certainly seen waves of graph adoption in a lot of industries over the years. And for the longest time in the early days, my big kind of conundrum was the financial services industry. Financial services typically tends to be early to adopt technology. They spend a lot of technology if it can kind of move their top or bottom line forward. I felt that there was so much relationships in their data that was very valuable, right? I'm sure you did the same, right? But for some reason, it just didn't catch on. It took like years and years and years, and the use cases were so clear. It was so crisp,
easy
like,
to explain. It was whiteboardy.
It was all
those
there,
things.
but something just held it back. And I think it was some combination of just inertia. Like a lot of even developers in financial services, I've observed, like tend to move between financial services companies, right? Maybe not outside of it. So there's maybe some of that, right? And then I think there's also a huge amount of stuff around security, right? Which of course, like, in the early days where this embedded Java library and all that kind of stuff, right? And then, boom, like that. Don't even remember what years, maybe 14, 15, 16, something like that. It just started taking off, right? And all of a sudden, now, today, financial services is the biggest vertical for graph adoption on the planet, right? And so that's just one example. And so we've certainly seen that play out many, many times. Right now, what would be a domain? Probably the one that comes to mind, and this is colored, of course, by kind of current events, would be utilities, right? Because, so we're here in Malmö, Sweden, which is in Europe, and, energy crisis and war in Ukraine, all that kind of stuff, right? And you look at analyzing and figuring out, like, basically, let's call it a big power grid, right? That's exactly a graph model. Right. And you think about that use case, it's exactly the same one that has a lot of deep adoption in telcos, right? It's the same, right? As with a telco network, a utility network or a telco network. It's exactly the same thing. But I've not seen that adopted. We certainly have seen some, right? Kind of big energy companies, but nowhere near as much as I would imagine, considering the technical fit. And then also just considering how impactful that is on the world today. So that would be a number one domain in my mind.
Okay. So if there's anybody out there listening from the energy sector,
go ahead, adopt, use it.
Call us. It's a great fit according to Emil. I think you're absolutely right. That makes great sense to me. Something we should look into. Let's look at another question here. And this is going back to the history, actually. This is going back to the founding of Neo4j as an open source project first. This question from David Allen, and he asks, new folks might not know the history and the name Neo4j. Can you talk a little bit about the name? Who is this J guy? And why does he get his own entire graph database?
Neo4j.
Why is it?
Yeah, man.
Yeah. Congratulations, Jay.
Yeah, Jay did well. There's a short version of this story, there's a medium version of this story, and then there's a really long over beers version of this story. Sadly, this is water, so I'll stick to maybe the short to medium version of it all, right? So when we initially conceived of the idea, way back in the days when dinosaurs ruled the earth, years and years ago now, right? We called it Project Neo. And Project Neo, because Neo in Latin means new. And this was a new way of looking at data, right? And so that was kind of one reason for it. The other reason, of course, was that we were back then and remain today massive fans of the Matrix movies, right? And of course, Keanu Reeves in the Matrix movies is Neo, and he's fighting against the Matrix. And the Matrix, you could argue, is a table, right? And so we figured Neo is a great one. Also, we immediately came up with a recursive acronym for it. Neo stands for the Neo engine, of course. The Neo engine, of course. Right? And Neo stands for the Neo. So it's a recursive acronym, which we felt very happy about, and that kind of stuff, right? So we call it Project Neo. And then fast forward a few years and we wanted to commercialize it, right? And then we go out and we, of course, try to get Neo.com. And of course, Neo.com was mind-numbingly expensive because it was all of $2,000. Right? Which, of course, by today's standard, that's not a lot of money, right? But it was like, I don't know, $1,900 more than we had at the time, or something like that, right? And then Peter Neubauer, there's three co-founders of Neo4j. Peter, he was very deep in the Java community at the time, and there's like this common pattern where people said, "Hey, I'm going to build a logging framework for what? For Java. I'm going to call it Log4j, right?" And so then Peter said, "Hey, let's just use Neo4j." And it kind of doesn't make sense. What do you mean, like log for Java? That makes sense. It's a logging framework for Java. Right? Or for JVM. Neo for Java doesn't really make sense, but the domain was $9.
Sold.
So,
and pretty fantastic SEO, right?
And then we had that thing, like, which is always like for the longest time, kind of the early grassroots adoption of Neo4j, which has always been core to us, right? And this event is a great example of the long arc of that, right? For the longest time, anyone who mentioned Neo4j on Twitter, we saw.
Right.
We tweeted them, we engaged them, and said, "Hey, how's it going?"
With any other product, it was very differentiated.
No one else
yes.
called their product Neo4j for some reason. And then the company, was called something different back then, Neo Technology, and I kind of refused to rename the company, to this because I wanted to separate them and this and that. And then over time, everyone just knew us by Neo4j. So then at that point, we said, "Hey, let's just go ahead and rename the company Neo4j."
This is how we're known. That's
the story of that. And for a later day, I saw there was some comments in the chat before about Cypher and stuff like that. We'll do the story of the naming of Cypher.
Maybe we'll have an entire session just on naming within the
exactly.
universe. There's a lot of paths we can go down, I think, there. That would be fun. And actually, this gets around. So that was the bit of the origin story of Neo4j. This kind of looks forward towards where's all this going. And I love the ambition of this question. This is from Alec Manfra. Do you think graph databases will replace relational databases or even to their market share? Said another way, do you expect a large number of apps to become graph native?
Oh, wow. I love that question. Even kind of the tail end of that, apps become graph native. Yeah. Like with all these questions, there's like a short and a long version of it all. So maybe let's bucket two broad buckets to start with. Existing applications versus new applications, right? And so Neo4j actually and graph databases have actually had to play with existing applications, unlike many new types of databases, right? If you take a Mongo, for example, or maybe like an InfluxDB, like a time series database or something like this, typically you wouldn't say, if I have an existing application, I'm going to add, let's just take Mongo as an example, right? Which, this, I've long been a fan of Mongo, right? People think that there's some kind of, but like I've always really liked Mongo. But like the reason you would use Mongo is developer productivity, agility, stuff like that, right? And if you have an existing application using a relational database and you add Mongo to it, that's not going to give you more developer productivity, because all of a sudden you're dealing with two databases. That's the opposite of developer productivity. Yeah, exactly, right? And so for us, though, if you have an existing application, let's just keep it simple, using a relational database, there's a real value proposition for pulling in Neo4j, right? Because you will have, in that relational database, you might have some connected data. What example did we talk about before? Telcos or utilities or something like this, right? You might have like an application that is operating on your, let's talk about utilities, your utilities network, and who's allowed to access it, who's allowed to do whatever operations on it. Maybe that's stored in a relational database, maybe not, right? But then the network will be stored in a relational database if that's where the application started. But that's a really poor fit with a relational database. So really it will be trapped, that network data structure will be trapped in a relational database. If you then inject Neo4j into that and run them side by side, you can take and you can replicate the network overlay, like how the utilities are connected, into Neo4j. And that's actually really powerful, because all of a sudden you can do queries on this that are much, much faster, of course, than you can do with joins in a relational database. So that's kind of the first bucket, existing applications, right, that are already using a relational database, right? We have a play there. I don't think that's the big one, right?
It's interesting, though, because it's a nice way in.
Exactly.
It's a fantastic complement to what you already have. Arguably, it's almost like, oh, you've got a relational database, you want to add search, you'll grab Elasticsearch, mix it in.
Exactly.
You've got an existing database, but you want to add how is it structured? How are things actually connected? Deeper insight into the data. Add a graph into the mix.
Exactly. That's exactly right.
Yeah. Okay.
So that's that bucket. The other bucket that I think is more interesting is greenfield projects. And I guess the question was framed as, hey, will it, kill the relational database over time?
Take over the world.
Yeah, exactly. Yeah, that type of a thing. I am massively long on graph databases, over time becoming the first database that developers reach for. And so first does not mean the only, right? I still believe that in any non-trivial application, there's going to be multiple database backends, not 5 or 10, but like 2 or 3, you know, type of like a low kind of single-digit number type of databases, right? So I believe that in that future, but there's one that's going to be the first one you reach for. When you sit down and you start prototyping your application,
right?
I think Neo4j has the potential to become that over time, right? Because most applications will become more and more connected over time, because the world is becoming more connected over time, and data models the world. So that's going to happen. And then as we release by release by release, improve the developer experience, reduce the friction between what's in the head of the developer, the cognitive model of the developer, and how they actually express that in their data, right? As we do that release by release, it's going to be easier for them to reach for Neo4j over time to build that new application.
Right.
And I think that's over time how we would, like the graph world would eat into the market share of the relational database.
So no sailboat yet.
No sailboat yet.
Okay.
Not quite there.
Larry's safe for now. All right. Let's see. We've got, I think, time for probably just one more question. Oh, and this is the same, you know, sort of in the same lines. Let's see. We could either go here to what do you see for Neo4j and graph databases in the next 5-10 years?
I feel like
Actually,
I can't.
It's kind of in the same area.
Yeah,
right?
I can answer that.
Let's see if we can diverge here a little bit. On this, maybe a lot of this is about like how relational fits in with graph, which is fantastic. This maybe we go to oh, what's been uploaded.
Maybe we just sit here and watch you
we
scroll.
Can just watch you scroll. You know, it's
Scroll
great
up.
TV.
Yeah, exactly.
Is just
This is live on your screen right now.
So the variation on this is actually, so one of the biggest challenges with, you know, that growth and with that dominance. So like this is from Mike Morley here. Mike asks, what do you see as the biggest barriers to Neo4j being adopted as the database and machine learning platform? So, okay, let's say we have the ambition. Let's say we do want to take over the world. Yeah. What's the biggest challenge right now? Like what's stopping us? Yeah. Sometimes you call it the graph problem. Right. Right.
Yeah. Yeah. The graph problem. That's an interesting one to unpack. How are we doing on time? How much more time?
We've got a few minutes. So
a few minutes, yeah. So the short version.
Pithy.
Yeah. So I think the biggest challenge for us here in the graph world and for Neo4j to become increasingly more adopted is it's the mismatch between the number of applications, the number of use cases for which graph databases in Neo4j is the best fit. The mismatch between that and the perception thereof. So in other words, there's a wide variety of applications that really is very graphy in nature, but people don't think of them that way. Right? For those of you who are watching this in a browser, which I guess is all of you, like pull up a separate tab, go to images.google.com, type in domain model. Just do that right now. Hit enter. And then you scroll down, images.google.com, domain model. You just keep scrolling. What you'll see there is a bunch of domain models from applications. Every single one of them is a graph, right? Most of them are a great fit for Neo4j, but the perception out there amongst other developers, not the folks on this call, right? You get it, but amongst most developers is, you know what? Hey, graphs are kind of niche. It's good for XYZ, digital twin, personalization, fraud detection, handful of use cases is what people know. And the mismatch between that and the reality, I think that's the biggest barrier. And it's a big thing that all of you here on this call can help out with, which is spread the word about the breadth of applicability, the breadth of use cases for graph databases.
We talk sometimes about like people having a graph epiphany. And the moment that happens, exactly what you're talking about, the script flips and it's like, okay, I've got graph problems everywhere. Like, oh, I can use a graph for this. I can use a graph for that. And like, it suddenly becomes pervasive in everything you do and how you even think about things, whether it's a database project or not. It's like the thinking carries forward with you.
That's
so
exactly right.
Exactly. Like everybody here, like you're all part of like this future of like building the graph community. You are the graph community. Everybody that you know, we know from Nicholas's talk in the morning, all of your friends, who apparently you all have more friends than I do, because you're my friend, right? And more than you. I don't know how that works. The math was very intimidating, to be honest. That's how all this spreads. That's how the growth maybe actually is unlocked.
That's right. Well said.
Cool. Thank you all for this session. This has been fantastic.